Hey guys, good morning, good evening. Thank you so much for joining in for the .NET Dev Summit 2020. So we know we are all having a trying times at our personal life due to this pandemic and the COVID situation, but I'm super happy that you all are taking time out during this crisis time and then trying to invest your time in learning new things and joining us here. Thank you so much. So let me start with a quick introduction about the organizers behind this event. So first off, it's me. This is Swami. So I work as an architect at Maersk. I am a Microsoft MVP under Developer Technologies. So I'm the organizer of the BDotNet and XHackers meetups in Bangalore. And my GitHub handle is github.com/svswaminathan. And I tweet at svswaminathan. And I recently started a YouTube channel. So that's youtube.com/g/swaminathanvetri. And I also write a technical blog at swaminathanvetri.in. We also have a couple of other organizers from different communities. So next person is Durgesh. So he works as a solution architect at Kimberly-Clark. He is also the co-organizer of XHackers meetup. And he is a pretty active open source contributor for Xamarin Forms. And his GitHub handle is TechDugu, and you can follow him on Twitter at iDugu. He used to be a Sidecore Smurf, so his blog is sidecoresmurf.wordpress.com. So you can follow along him there. And the next organizer is Anbu Mani. So Anbu works as an associate technical analyst at ChangePoint Technologies in Chennai. And he's also a Microsoft MVP under Developer Technologies. And he's pretty active in the community, organizing various events, boot camps, and workshops under Microsoft Technologies. And you can follow along him on Anbu_Money27. And XMonkeys360 is the one which he has founded. That's his community. All right. So, and I'm talking about the communities. Like I mentioned, this is more of a community-driven event. So, 3 primary .NET communities in India. So, BDotNet, XHackers, and XMonkeys have partnered together today to bring you all this particular event. So, if you want to follow along on BDotNet, so those are the handles. You can go to meetup.com/BDotNet UG, and the same thing goes for Twitter. And if you're pretty active on Facebook, you can definitely join our group. And for the XHackers, you can follow along as meetup.com/XHackers and follow us on Twitter at xhackers.co/xhackersco. And even we do have Facebook groups there. And XMonkeys is the same everywhere. You go to Meetup, Twitter, Facebook, YouTube, it's XMonkeys360. All right. And of course, nothing would have been possible without the sponsors. So I would like to thank our sponsors, JetBrains, who is giving away some free licenses, and Microsoft and .NET Foundation. So if in case you're not aware of .NET Foundation, I would like you to definitely be aware about that. So .NET Foundation is an open source foundation. So it's more the mission is more about to making it more independent, innovative, and have that open source thing striving, right? So and if you want to know more about .NET Foundation, go to .NETfoundation.org. So I want to give a brief about what are the things you can get out of .NET Foundation, right? So it helps in, let's say you are running an open source project, it helps in getting your protection on your legal or IP related stuff. And if you want to understand how you want to set up your contribution license agreements or copyrights, trademarks, etc., you could get the help for those things. And also, if you want to know about the best practices in running an open source project, you can very well get that too from the foundation. And if you're running your meetups, or if you want to promote about your .NET events, etc., you can definitely take help from Foundation. And definitely this particular event is also being hosted by .NET Foundation, and it's been live streamed from Foundation's support. Right. So thank you so much, .NET Foundation. And of course, yeah, if you're running projects and if you want any help in hosting or code signing and DevOps perspective, you can also take those help from there. And if you want to be part of the foundation, there are different ways you can be part of it. So one thing is you can be a member. Anyone who is a .NET freak can be part of it. So just go to .NETfoundation.org and then say become a member, and then you'll be able to, your request will be evaluated, and then you'll be getting your membership approved. And you can also join some of the meetups by going to meetup.com/pro/.net. And if you're already running your meetup, but it's not part of the .NET Foundation, you could very well do that too. And or if you just want to be listening via the newsletters, you can do that too by signing up for the newsletters. And if you are very much interested in contributing to some of the open source projects, but not sure where to go and start, this is a good place. So go to .NETfoundation.org/projects, and then you should be able to, look up the project of your interest, and then you can go and start contributing. And yeah, if you're already running in some awesome project, but it's not, and if you wanted to be part of the .NET Foundation, you can just reach out to them by contact@the.NETfoundation.org. All right. And next test. So these are the amazing speakers what we have for today. and definitely they have taken out a good amount of time on their day-to-day work, and then they made for the event. So thank you so much, speakers. So first off is James Montemagno. So James is the principal program manager in .NET team. So he's joining us from Seattle. And we have Nish. He's also a program manager in .NET team. So he's joining from Bangalore. And we have Renuka, Ravi, and Amrish, who are all part of the communities. They are running their own communities in different parts of India, and they've joined us today. And we also have a couple of MVPs, Amal, who has joined us from Cochin, India, and Mohit, who works out of Germany currently. He's also joining us today. And it's me, Swami, and Anbu and Durgesh. Yeah, thank you so much, guys. And yeah, so this is a quick walkthrough about the agenda. So we would be starting with the first session by 10 a.m., which would be on the Xamarin. And then we take a break for 15 minutes around 10:45. You can just take a coffee break or whatever. And then let's get back on 11 a.m. to talk about or to listen about the Blazor. And followed by, we have a session on SignalR. And then we'll be having about a lunch break of 45 minutes. So from 12:30 to 1:15. And all of these times on IST because we're streaming from Bangalore, India. And yeah, post lunch, we are going to have sessions on microservices and DAPR. And finally, we've got an AMA session, Ask Me Anything. So if you have any questions around any of the topics, what we've discussed, or even beyond that, feel free to post your questions, and then we'll be able to answer them. And please stick to us till the end. We are going to have a raffle and good goodies. I would like to close with a bit of an event etiquette. So every session would be for 45 minutes. And at the end of the 5 minutes is where we are parking for the questions. So all the Q&A will be answered towards the end. And you can keep posting your questions in the YouTube comment section, and we would pick it up, and then that will be answered. Right? And also you can tweet your experience about this event using the hashtag .NET Dev Summit 20. And finally, we would like to get your feedback about the good and the bad and everything. So please share your feedback at b.net.in/feedback. All right. Without further ado, let's rock and roll. Thank you, guys. So up next would be James. So whose session would be starting around 10 a.m. sharp.
Oh my goodness. I am so excited to be here with all of you live from the Pacific Northwest over here in the USA. I'm really excited when Nish pitched to me the event, the amazing community event that y'all were doing over there. I knew I wanted to try to be part of it. So I'm up here late, almost 10 p.m. here, but I'm really, really excited for all the amazing stuff that we have to offer coming from the .NET team and the Xamarin team. I'm really excited by that amazing introduction from Swami and the amazing team behind this event. I'm super humbled and super honored to be here with all of you today. And I hope I have some really awesome stuff to share with all of you. Everyone behind the scenes here is really making this happen. So give them a big applause in the YouTube chat. Of course, we'll be monitoring it as well. Really excited, and a big thank you to everyone making this happen. So I'm James Montemagno. I'm a principal lead program manager for the .NET community team over at Microsoft. I work side by side Nish and Neil, who you'll see later, giving an awesome, spectacular presentation. Everyone's going to give an awesome, spectacular presentation. And a lot of my years have been focused on Xamarin mobile development, and a lot has happened. So I have exciting demos. I have some exciting stuff to talk about going into the future with .NET 5 and .NET 6. So I'm just going to go ahead and get into it here. So, at Xamarin and on the .NET team, we've really always wanted to delight developers. Our goal and mission has always been able to build beautiful native cross-platform apps for any platform, specifically iOS, Android, and Windows, but more, and share all of your C# and .NET logic. And what I've loved is that over the years, we've expanded that, and we've grown the capabilities of what you can do as a developer, enabling you to share more code, be more productive, and have beautiful native applications. So not only can you share your core business logic with your .NET applications, whether it's desktop or mobile or web, but specifically for iOS, Android, and Windows and Mac, we have cross-platform native APIs in Xamarin Essentials, so you can access platform features like geolocation, connectivity, accelerometers, and a whole lot more. Over 80 different APIs built into that single library for you. Additionally, we have Xamarin Forms, which is our most popular cross-platform UI framework from the .NET team. It enables you to build beautiful cross-platform native applications from a single shared C# and XAML code base, and enables you to be super productive in both Visual Studio and Visual Studio for Mac. So I love this story because it just continues to evolve over the years. And that's really what I want to show you today. So maybe you're a developer that looked at Xamarin years ago, or maybe you're still using Xamarin today, which is awesome. So am I. It's been 9 years and I love every minute of it. Hopefully there's something brand new. I sort of try to reintroduce the new Xamarin before I go into the future of what we're doing next year. And the thing is, we've built this amazing framework, but we see an amazing community flourish around it. Not only from amazing component vendors like Syncfusion, DevExpress, Telerik, and more, but also the amazing community, all of you, building libraries, publishing NuGet packages, doing events just like this, making the .NET community and Xamarin community flourish. And what's great as a developer, when you want to go in and start building applications, you have all of this amazing stuff that you can take advantage of. So I think it's absolutely fantastic just to really see the Xamarin and .NET community flourish over these years. Now, we've really focused on shrinking and making it faster to get started with Xamarin more than ever. In fact, between Visual Studio 2017 and 2019, we've shrunk by 1/3 or 2/3 actually, the installation time to get started with Xamarin. And it's now 2 times faster to install, which is ever so important when you want to get started getting development done. But more importantly, we've really focused on developer productivity. We've built in tons of amazing features being part of Microsoft, leveraging Visual Studio, .NET, collaborating with the Windows team to help developers code faster with things like IntelliCode and advanced IntelliSense. Also, deeper integration into third-party libraries with SourceLink, so you can actually debug into third-party libraries. But also, we've listened to our developers and we said, what are your frustrations? What are the things that you want us to be better at? So we've basically optimized our build and deployment times. And we've reduced up to 50% our build, increment, and deploy size times when building Android and iOS applications. We've also listened and said, how do we help make your applications start faster? That was one of the things that developers always are worried about. We introduced ahead of time compilation, startup tracing, and introduced app bundle support. So you can reduce your not only startup time by 60%, but your final Android application size by up to 60%. I actually just released one of my latest applications, Island Tracker, which is a mobile application for Animal Crossing for the Nintendo Switch. And by using startup tracing, I shaved a few seconds off my startup time, and I shrunk my app size by 50%, which was absolutely amazing doing app bundles. But more importantly, we want to help developers iterate faster. So whether you're developing inside of your iOS, Android project, or going cross-platform with Xamarin Forms, we want the IDE to help you develop faster. So we've introduced a whole bunch of different pieces of technology to really help you be really productive. So I didn't want to have too many slides in the beginning. I just want to go into a demo. This is a brand new demo that I just came up with myself. I'm really excited about it. So what I'm going to do over here is just boot up Visual Studio. And I'm just going to create a brand new project. So here we go. Now there's a bunch of different templates in here. Specifically, mobile app is the one for Xamarin Forms. And I'm going to say create. Now we have some brand new templates in here, and these are using our brand new Xamarin Forms shell technology, which I'll talk about a little bit later. But for this, I'm just going to do a blank application and add Windows onto here. I find that I often develop on Windows, so I like to have sort of a Windows project to iterate fast on. So I don't have to worry about iOS or Android emulators or simulators, but I'm just going to go ahead and start this up here. So this is going to scaffold out my project. And if you've never done this before for a Xamarin project, well, this is going to give you specifically a few different projects. I have my shared code, my Android app, iOS, and Windows project. And this is based on Xamarin Forms, and it has Xamarin Essentials built right in. And this is nice because I can write all of my shared code directly into this project. So here I have my app file, I have my main page. And when I need to write platform-specific code, I can do that inside my Android, iOS, or Windows project. So here's my main page. We have a brand new template that helps developers get started faster. So it gives you some information of how to use some different colors and labels and formatting of text. So I'm just going to launch it. And Windows is the startup project. So it's just going to deploy a Windows application directly on my desktop. So that's going to go through just a normal Windows build process over here and deploy onto my machine. So here we go. And I have this beautiful welcome to Xamarin Forms. And it says that hot reload is enabled here. So that's really cool. This is a brand new feature we're releasing in the latest Visual Studio preview, which is right here. And what that allows me to do is come into my XAML that we see here. So we see this frame, this blue frame. I can just come in and get rich IntelliSense, make changes. I don't even have to hit save. It just updates automatically for me. If I have a typo, I get a little squiggle and tells me that that's invalid. In fact, I get a little error down here at the bottom. So once I say orange, or I like to do maybe like hot pink is one of my favorites here. And boom, I'm like ready to go. I can come in and actually add additional elements in here. So here's an entry box, which is nice. And the cool part about this hot reload is it's the second generation of hot reload. And it does a diffing. So if I say hello .NET Dev Summit, what's nice here is, let's say I want to change this over to orange again. Notice that it didn't refresh the whole page. It only modified that background color. It still left it all right here, which helps me be really productive. So it doesn't change the state of my application. It saves that state, which is really, really awesome. And I can change anything. In fact, sometimes we have really big XAML files. So I love this visual tree over here on the left-hand side. Let me zoom in here. This shows me every part of my application. In fact, you can see them basically mirrored: frame, entry, label. But sometimes it's hard to remember, I'm over here, where's this entry? Where is it at? You can just click on this button and it will highlight the XAML for you automatically. So no matter where you're at. In fact, this is very similar if you're doing traditional UWP or WPF, because we reuse all that great technology. Now, let's say we want to add a data binding in here. maybe in the code behind this is a brand new project. So we'll just sort of do a binding context here and we'll set it equal to this and nothing fancy. But let's go ahead and do like a public string. We'll say hello and we'll do a get set and we'll say hello .NET Dev Summit here. There we go. And I'm just going to go ahead and redeploy this here. Okay, so just made some changes in my code behind. Of course, I need to put a semicolon there and hit debug again. So this again will just sort of, it's already built once, so it'll be a little bit faster, this deploy around. But I changed some, C# code. So I'm going to redeploy that here and just go ahead and, oh, it got mad at me here. What did it get mad at me at? Something. Let's go ahead and try to debug it here one more time. There we go. I'm just going to go ahead and snap this over here and bring this up. So what's nice here is that I can now start using that data binding. So I'm going to say binding, and I'm going to say hello. Now, a few things happened, which is very fascinating. I obviously mistypoed this, but on purpose, okay? Because this hello should be 2 L's. But we have a brand new analyzer. You can see right here. Look at this. It's telling me that there's an error inside of my XAML, and it'll tell me that hello is not spelled correctly down here in this error message. Now, as soon as I go ahead and save that here, I can go ahead and look at my XAML binding failures and close that out, and I don't get any anymore. So if you are coming in and migrating projects, you can see all of your different errors or warnings that are happening, which is really cool. So that's really nice. But check this out. So I'm going to stop debugging, and I'm just going to set the Android project as my startup over here. And I'm just going to hit debug. I didn't change anything, right? I already have my new orange color. I have my hello binding in here. I start up my brand new Android emulator, which we've optimized to work great with Hyper-V on Windows machines, or our ARM, or also Intel, but also AMD processors. And of course, it'll work great on a Mac. So over here, it's going to package up that Android application. That's pretty cool. It's doing a bunch of nice stuff here. There we go. Cool, cool, cool. It's going to build this. So it's building up an entire Android package for me, and it's going to deploy it. So this will take, a second or two to deploy, but here it is. And what I love about this is that I'm going to get all the changes I just made over there. But if I come in, I can see that I actually have the same exact, look at this, same exact visual tree, the same tools from Windows over on Android. I get the same thing. So if I come in and I say hello, I can now change this back over to pink, right? And it changes and updates for me automatically, which is really nice. Now, I'm getting all that great XAML IntelliSense. I'm getting the same things. In fact, if I go over here and I mistypo this, I can still look at my XAML bindings and I can see them here. The same tooling, the same thing works. It's so nice. It's nice to see everything really work together super well. So one thing that's nice, though, is that we also not only have the ability to change XAML, but if I need to go into my Android project, like really into it and change some things in here, I can do that. So for example, there's this sort of this pinkish, this sort of, let me go over here and sort of look at it. Oh, the emulator, I can't zoom in on, but sort of this pinkish, little thing right here. If I wanted to, I could come in and, see that and change the accent color here. And maybe I just want that to be black for some reason. So I get all these great rich IntelliSense in here. Now this is inside of the Android application. So I'd have to usually stop, do a bunch of changes, but we've also implemented basically activity restart to apply Android resources. So I can go up into the toolbar and just hit that button. And what this does is it actually like looks for a diff in the Android application, and then it redeploys it. So now when I have this hover, it's black now. Awesome, right? I'm in my XAML, I'm in my Android project. I get this great tooling, rich IntelliSense, and everything works the same. All right, last thing, let's get out of this Android thing. Gone. All right, my Android emulator is gone. Last piece of the puzzle, my iPhone, sitting here, right? So here's what we're gonna do. I'm gonna set my iOS project as the startup. And what we can see up top, up here, right here, it says local device. It's awesome. There's a new piece of technology that's available today. It's instable, everything's there. It's a hot restart. It's a new type of deployment technology that we started rolling out for iOS that lets you to quick deploy to a physical device. So this is cool. I'm going to go ahead and do this here. It's a brand new project. Now it says hot restart. It's ready to go. What I'm going to do is it's not even plugged in. It's not, well, I just unplugged it. What am I doing? It's late. It's 10 o'clock. I'm going to plug in to my iPhone. I'm going to plug this into my computer, into my Windows machine here, into my desktop, into my Windows machine. Right? Plug it in there. Bump, bump, bump. All right, I'm going to go ahead and unlock my device. And what I'm going to do here, see it? It's just connected. I'm going to say next. And it's going to say, hey, we found your iPhone. Do you want to deploy to that? Of course I do. That sounds great. So I've logged in with my Apple developer account, and I'm going to select my personal team. This is my account. I pay for this personally. And what it's going to do is it's going to communicate to Apple right now. It's going to download and synchronize how I'm able to deploy and do everything to my device, and basically enable me to deploy to my iOS device from my Windows machine here. I'm going to say finish. Now, it's not an emulator, it's not a simulator, it's my machine. So I'm going to go ahead and reflect it here. I'm going to mirror my device. So I'm going to go ahead and use this little application I call Reflector. I'm going to enter a code. There we go. And what you're going to see is my physical iOS device here, right here. See, I'm doing it. See it? It's right there. So now what's happening is inside of Visual Studio, it's actually compiling up a special build, a developer build of my application. And it's going to say, please launch the app. So I'm going to launch it here. Whoa, check this out. I'm launching it right here. Boom, boom, boom. All the changes, everything I have. I get the visual tree, same exact thing. I can come over here and I can change that back to orange. I get the same hot reload experience. Amazing. Now, you may have noticed that it took a little bit of time to package up that application over here. But with hot restart, it enables you to hot restart your application. So check this out. Let's go ahead, just simply come in and make a hello 2, right? Now notice here that Visual Studio is telling me that I need to restart my application because I made code changes. Well, there's a little restart button here, just like I did for Android when I made changes in the actual project. I'm going to go ahead and hit the restart button. It's going to save my files. It's going to do a diff of my application, and then it's going to redeploy it to the device. Now, notice here, that took what, 5, 6, 7, 8 seconds to do. And now my application is ready to go. In fact, if I come over and I make a change over here and I say, let's get rid of this, get rid of this code change. It's a big code change over here. I'm going to say binding to hello 2. Get the same thing right here. All that rich IntelliSense, all that great data binding, all that hot restarting, all that stuff that you know and love. It's all built right in, like from end to end. Like how amazing is it? I would never thought 9 years ago when I started my journey with Xamarin that all of this seamless tooling integration works so well together to help you be super productive. And that's what we want to help you do. All right, so let me go ahead and tear some of this down here, because I don't know if you weren't impressed and you aren't saying that was the most amazing thing in the entire world, then I don't know. That's what hopefully you enjoyed it. So let me go ahead and stop closing this over here. Let's go back to some slides over here. Okay, here we go. Cool. So that's what I like to call sort of the new Xamarin experience, right? It enables you to be super productive and for you to get off the ground running super quick, whether you're developing on Windows, Android, iOS, no matter what you got, you're good to go. Now, what's really cool about Hot Restart is that it dramatically reduces all of those build times, right? So here's a cool graph with and without Hot Restart. Initial builds down. This is one of our large applications that we use, this Hotel 360 application, from 3 minutes to 22 seconds. The initial deploy does take a little bit bigger because we're deploying a big package that we're able to redeploy in. But what I want you to note here is the incremental build. 37 seconds down to under 3. You saw how fast it was, right? It's crazy. Same with incremental deploy. So down 50%. Now we're starting this. It's available today for iOS on Windows. And our plan here, the development team behind this, is going to then bring it to Android on Mac and Windows. Even though Android's pretty quick, we think it can be faster because why not? And then iOS on a Mac too, and really build it into sort of the F5 experience like you saw today, which is really nice. Now, Maddie, who's one of my amazing PM counterparts, she's the PM of Hot Reload, Hot Restart, all the awesome stuff that you just saw. I had nothing to do with it. I just hang out and on meetings all day on Teams. But Maddie, she's amazing. And she has basically helped build this up with the development team and the developers behind it. And we announced Hot Restart and Hot Reload for Xamarin Forms just about a year ago. And since then, we've added all these features. We collaborated with the Windows team. We've packed in all this great functionality. People on Twitter simply loving it. So it's right there. Now, I don't have necessarily details. Vishal is asking when it's coming. I am reading the YouTube comments. Don't you worry. It's there. And yes, Rakdesa, everything you just saw is available today. The only feature I showed you, one feature, which was the Windows Hot Reload part, that's in preview. That's in the preview Visual Studio. Everything else available today in stable, which is there. Just cool. Everything's there. So I'm not showing you magical bits and things like that, but it's all there. All right, let's talk about Xamarin Forms. I just showed you sort of the productivity that we're building in. And a lot of those features are also really helpful for non-Xamarin Forms development. Like if you were doing traditional iOS and Android, that sort of hot or that quick reloading of Android activities is also really helpful. But Xamarin Forms has really been our focus because developers love it to be able to build cross-platform native user interface. And, we've had an amazing year in Xamarin Forms. We first introduced Xamarin Forms Shell with Xamarin Forms 4.0. And it's a way of really structuring and streamlining your entire application. So instead of having to string along tabbed page, flyout pages, it does it all for you in one nice syntax. It enables you to do things like this in just a few lines of code, have nice flyouts, animations, gradients, all built in. We also the development team brought visual and material design to iOS and streamlined Android and really built that out, which is really, really cool. So that enables you to do things like on iOS, have a very similar look and feel to your Android application, which is really spectacular. So all of your buttons, all of your labels, everything's going to act and look exactly the same on iOS or Android, which is helpful when you're building an application. You want it to look relatively, similar to not have to test multiple times. And then finally, collection view, which is the evolution of list view. It enables grids, custom layouts. It's super performant, empty, headers, footers. It has optimized caching in it. It enables you to do all sorts of beautiful things and build beautiful applications. I wanted to take some time just to really talk about these features just a little bit more because our community, all of you have built amazing things with them. So this is Shell, right? Shell here is a simple way of building tabs, top, bottom, flyout, in very simple syntax. It does automatic URL navigation for you. You can pass parameters to it. And here, for example, is a beautiful news application that looks like Microsoft News, which is completely open source, this implementation of it. Over here, we have an awesome sort of look and feel of the collection view, looking at sort of like a WhatsApp type of messaging application. And this enables you, again, to do custom data templates, headers, footers, inline, everything that you would expect. Really cool. And these are all real apps. These are apps that people built with Xamarin that you're seeing on here. And you'll see the links down at the bottom to actually go to their GitHub so you can see these yourself. Carousel view is also an iteration of collection view, but it enables you to swipe left and right through collections of data, which is cool. So if you're over here, this is a burger application, you can swipe left and right on it. And they're even using the collection view to show that grid there. Swipe view also is really, really neat. This enables you to swipe things left, right, up and down, everywhere, iOS, Android, Windows, you name it. You can customize anything that's inside those swipe items. So they can be the default implemented ones or your own custom ones. Super great. You can use them in anything. Collection views, just a stack layout, anything at all. It's really, really nice. And then also Expander. This is built right into Xamarin Forms. You can collapse and expand any of your content, which is nice for something just like this. When you're looking to make a shopping list, you want to add those on. You can add all these animations which are built into Xamarin Forms too. One really fascinating thing that the community's been pushing really hard is this sort of building declarative user interface with C# or F#. So recently, in one of the most recent releases of Xamarin Forms, Vincent from the community, he did this amazing pull request to streamline what it looks like to do data bindings, style, do margins and padding and everything inside of a C# UI markup. So if you're interested in something like that, there's amazing new markup support that you can do to build, of course, beautiful UIs, which is great. So if you're not used to XAML and you like that code first approach, it's built right in. One of the most hottest things in the entire world that I simply love is the brand new drawing API built into Xamarin Forms. Native drawing, no dependencies. This enables you to do lines, rectangles, polygons, polyfills, paths, image clips. Here we're doing an ellipse geometry, cutting out a circle of an image. And what you see here, this entire sort of frame is this big data path that is being cut out, this background here. You can put SVGs in there. You can do anything. It's really, really neat. And it's fully native custom drawing. I just did a few shows with my good friend Javier, who implemented this API from the Xamarin Forms team. It's really awesome. So if you're really looking to do some custom work, it's all built in for you natively. Finally, of course, dark theme, light theme. It's now built in right into Xamarin Forms. Of course, Xamarin Forms will try to do the right thing for you. But here on this setter, you can see that on any property, any value, I can say on dark, use this color, on light, use this color. There's a bunch of nice things built in right for you, which is very, very cool. This is a great example of seeing that work in real time, that app theme API. Finally, I love not only stuff built into Xamarin Forms, but the amazing things that communities are building. This is an awesome plugin that you can get called Shared Transitions. You can see the animation zoom back and forth. This one here is neomorphism controls to get that cool pop out that you might want to see, which is really nice. Pancake view, allows you to get rounded corners, gradients, everything that you could possibly want inside of everything. So what you're seeing here, all these rounded corners up and down, left and right. Pancake view is great. And then also Sharpnado, which is this awesome, spectacular, really, really toolkit to kind of build anything, custom tabs, these really nice card views and frames and animations built right in. These are all real things that you can just go and grab and build today. Now, everything I just showed you is out now. Xamarin Forms 4.7 launched 6-7 weeks ago. We launch every single 6 weeks, a new version. 4.8 just came out. 4.9 is next, and 5.0 in November, which also coincides with our .NET conference, which is happening as well. So tune into that, which is really, really nice. That's an all-day, 3-day event. And I'll keep going and going and going. And in fact, some of the new features in that 4.9 and 5.0 will be some new support for gradient brushes throughout every single control and background color. So here we have gradient backgrounds and opacities and everything you want, even on the button here for confirm payment, all will be built right in. We also have support for a new custom tab view. This is really nice. It's a requested feature to be able to do basically custom buttons like you see here on the tabs, but also the ability to put tabs anywhere. So yes, they're on the bottom. Maybe you want them on the top, but maybe you want them in the center of your screen or more like a segmented control. You can do that as well. And finally, one thing, because why not, combine a few different pieces of technology. You can actually do a full app bar and put it absolutely anywhere. For years, it's been built directly into Xamarin Forms. It's now decoupled. And here's a cool app bar with a background GIF because I don't know, why not? So it's there. No. Now, our mission, our journey with Xamarin has always been to enable you to build these beautiful, fast, native applications, be more productive so you can write less code, have more time, and really integrate into this thriving ecosystem. Things built into the framework, but also this amazing community of libraries that you can go get whether it's from .NET and NuGet or Xamarin specific. But, as we necessarily look into the future of how .NET is evolving with .NET 5 and .NET 6 next year, we're of course looking to say, how are we evolving mobile development and desktop development here at Microsoft? And how are we going to enable all of you, our developers, to build more applications faster for more devices and share more code? And this is really our journey into one.NET. So traditionally, we've always talked about that .NET is your platform to build for anything. So whether you want to build desktop, web, mobile, gaming applications, IoT, .NET is always that base for you. And there's libraries and frameworks and runtimes that help you get there. And of course, amazing tooling like Visual Studio, VS Code, VS for Mac, or even the command line. And for years, the team has really iterated on how you share code, how the infrastructure is more shared between the different platforms. We really think a journey to a singular .NET will really aid developers. They don't have to learn multiple things. It's a single .NET. They know exactly where they want to go. So what we look at today, our journey here for our vision, is that today we have .NET Framework, which is 4.8. It's going to be 4.8, remain 4.8. We have .NET Core, and then of course we have Xamarin and Mono runtimes that are out there. For a new developer coming in, it's kind of confusing. They got a bunch of stuff to learn. They got, what are these frameworks, this version, that framework? What the team, the .NET runtime team and all the framework teams are saying is, what if we just kind of make it .NET? One single SDK, one unified tool chain, one base class library. We'll have cross-platform native user interface across mobile and desktop. And we'll have cross-platform web user interface as well. So you can create web applications, progressive web applications, WebAssembly offline applications on the desktop if you're a web developer. We'll continue our improvements in speed, size, diagnostics, and tooling, but just simply it's .NET. That's what it is. And with that, we are evolving Xamarin and Xamarin Forms into the next generation of cross-platform development. And we call it .NET MAUI, the .NET Multi-Platform App UI, .NET MAUI. And what's great about this is that it is the evolution. It's all of the amazing things that I just showed you, but re-architected from not necessarily the ground up necessarily, but basically taking all of our learnings, all of our optimizations, and removing years of legacy to give you a fast, streamlined, small, and super productive way to build iOS, Android, Windows, and Mac OS applications. .NET MAUI will give you that cross-platform native UI. It will give you a single project, single code base. You can deploy to multiple devices, whether it's mobile or desktop. Again, it's an evolution of Xamarin Forms, so you can migrate your existing applications today that you're building, and this will be targeting .NET 6. So .NET 5 will come out this fall. In fact, there's previews available today. And usually when a version of .NET comes out, the next preview comes out, and that's when previews will come out. So we're going to target a wide general availability with .NET 6, but previews around the end of the year. And I figured what I would do is show you what this looks like. And these are really exclusive bits. So I ahead of time, just to make sure I had enough time, I recorded a video because I didn't want to go between machines. But over here, I actually just have my Mac machine. And what's cool about this is that I'm actually starting right in the command line and right inside of the terminal, basically. And what I'm going to do over here is I'm just going to type in .NET New MAUI. And this is sort of our command line interface that will create our iOS, Android project and a brand new solution. I'm going to use common tooling like NuGet Restore to restore my NuGets here. And then I have the ability to, run the application, but I'm actually going to open up VS Code. I'm going to say code dot. And what this will do is open up VS Code as my lightweight code editor. And what I'll see is all of my .NET MAUI files. And in fact, we have just a single C# file. This is an MVU, model view update type of application. I have a little integer that I'll increment, and I have a label here. I have a button that I can tap on and increase that value every single time. It's a nice declarative user interface. I have a VStack over here. I have a spacer, so it'll space out objects correctly for me with my user interface. And what I'm going to do is simply hit debug, kind of like I did earlier. But here from inside of VS Code, I'm on a Mac, so it's going to show me all of my iOS simulators. So I'm going to go ahead and pick one here. And now it's going to compile my application right here, of course, on my Mac here. And then it's going to deploy my brand new .NET MAUI application over to my iOS simulator. So let me go ahead and bring that up. Here we go. And we see it install and launch. Now, this is kind of similar to what I showed you earlier. I created a new project, did a thing. But here, the difference is that I've built this entire UI with declarative UI, so just C#. But what's nice is that with .NET MAUI, we have hot reload built in not only to XAML, but also C# code. So for example, here, what I'm able to do is maybe let's say align this text different. It's kind of weird. It's in its left. So maybe what I can do is just say center here. I don't hit save. I don't have to do anything. It automatically keeps my state of 8. I've tapped 8 times, and I can continue to increment here, which I think is really, really neat. I can go ahead and change other things. So if I want to change the color to, I like to use pink a lot, even though it's a little hard to see, but it's all right here. I can change it back to black, which is nice over here. And then what I'm able to do is also change a bunch of the other code in this project. Like maybe I want to decrement this, so minus minus. I literally just change how the app works, and I'd say minus minus. And for good measure, I'll just go ahead and say minus, because that'll look a little bit nicer because I'm actually decrementing it. And now I have a full application written directly, all with declarative user interface inside of VS Code. And I could then open that in VS for Mac if I wanted to, or anywhere else I wanted to, which is really nice. And we're giving developers that capability to how they want to develop and the tools they want to use. Now, that being said, we still have a huge investment in XAML, Visual Studio. And in fact, with .NET MAUI, we're really iterating to say what that looks like. So let me show you what this looks like over here on Windows. So I'm going to create a brand new .NET MAUI application, similar to like I created a mobile application earlier. Let me bring that up. Now here I have a label, I have a button, it's all XAML. It's kind of similar to what I showed you earlier, but it has common data bindings. I have string format inside of here. So I get all that nice stuff that I just showed you, right? It's really, really nice. So everything that I know and love, the IntelliSense, the hot reloading capabilities, everything is built into the single XAML file. So if you already love XAML, love data bindings, hey, we got your back. We're right there for you. Now, I think what's cool here is that I can directly deploy, just like I showed you earlier, to Windows. And this is going to help you just, again, get off the ground running, deploy, get your application running. And we have a very similar look and feel to an application running .NET MAUI. I can increment it, can do everything that I did earlier, resize it because it's a Windows application, use hot reload, everything that you know and love. Now, at the same time, over here, what I'm able to do is not only deploy, just to my Windows device, but I could deploy to any of my different devices that I have plugged in. So if I plug in an Android device or my iPhone plugged into it, I can, of course, deploy there too. So let me go ahead and do that here. Here in the dropdown, I actually have my iPhone plugged in. I was doing this video for Scott, so it's Scott's iPhone. But over here, I just set it as my startup. I hit deploy. And what this is going to do is very similar to what I showed you earlier. It has that same hot restart technology, and it's going to go ahead and deploy that .NET MAUI application directly on to my iOS device. So whether I'm on VS Code, whether I'm on Visual Studio on Mac, whether I'm on Visual Studio here, whether I'm using XAML, whether I'm using declarative UI, you get all that great productivity that you know and love already. Now we're also at the same time not only building all that sort of productivity that you love in, but we're streamlining what the project system looks like. I showed you earlier, we had like 4 different projects. With .NET MAUI, a singular project. This is really nice. It brings together all of the old complicated stuff and simplifies it. Here I have resources and I have fonts and images. I can add everything into here, and .NET MAUI, when it's compiled, will figure out how to do the fonts, how to automatically resize all of your images for you, and make sure that they compiled up automatically for iOS, Android, Windows, or Mac. Just add it once. You don't have to add it to a bunch of different places. It's all right there, which is really, really cool. Now, what I also like is that I have this platform folder. This is what it will enable me to specify what platforms I want to deploy to, and also write platform-specific code in iOS, Android, Windows, or Mac. So here I can write an Android for the Bluetooth adapter, iOS, and I can open up those projects and files. I don't have to hop around into different projects, different startups. I just say, what do I want to deploy to? What am I writing? And it's all in one single file for me, which is really, really nice. Now, what this also means with .NET MAUI is that we're streamlining a lot of different development. I talked about that you can come in, create a single project. This is what this looks like here. I have .NET, which will be 5 or 6 in the future here. It'll be system MAUI, system device, which will be Xamarin Essentials. I can deploy to my iOS, Android, or Windows devices or simulators. I can write my custom code right here. And additionally, my platform code. And I know here, Rakdesa is asking about custom renders, and that's what you can put directly in your platform code. But more importantly, custom renderers and how renderers work are being built from the ground up. So you only have to write a few lines of code to access native capabilities instead of a bunch of different code. They've re-architected the rendering pipeline. It's super awesome as well. So it's really streamlined. I don't have any slides or demos of that today, but they basically think of it like, hey, I had a bunch of custom renderers. You can most likely get rid of a lot because there's a lot in Xamarin Forms, but also things are just sort of built in. System MAUI, evolution of Xamarin Forms. System devices, evolution of Xamarin Essentials. Brand new multi-platform app UI, and .NET New MAUI. Additionally, you'll sort of see some other changes. You'll see Xamarin iOS will just be .NET for iOS and .NET for Android. Now, in those instances, nothing will change. If you already have existing projects, everything's good. You can do .NET New iOS, .NET New Android. It's all good. We're really looking at MAUI and .NET MAUI as the way of going forward. And of course, we'll have migrations as well. What's nice here is you can go already to the GitHub page, github.com/.net/MAUI, and see exactly how everything is coming along. You can look at the platform differences, what's supported, what's not supported, and take a look and give feedback on what you would like to see. Now, that being said, you shouldn't just wait for .NET MAUI. If you want to build a mobile app, get started with Xamarin Forms today, and we'll have tools to migrate your application going forward, which is awesome. And here's what the timeline looks like. .NET 5 is set to release this fall in November 2020. And how .NET works is every 2 years is an LTS, a long-term support release. So .NET Core 3.1 last year was the LTS, and .NET 6 next year, when .NET MAUI launches, will be the next LTS support. And that's when you can see that coming out. Of course, like I said, you should still go off, create amazing Xamarin applications, and get ready for .NET MAUI. It should be a relatively seamless transition. I just started a new application the other day, so I'm pretty excited on that. And with that, thank you so much. You can go to Xamarin.com to find out everything you need. And I don't know, Nish, if I have any questions in the chat. I tried to answer a few while I came in there.
Hey, thanks so much, James. It's awesome. So I'm going to put in some questions from YouTube.
Sure.
Let's add something.
Yeah, lots of good love in there. Lots of people excited. So
there you go. Hi, is it possible to set up the Xamarin dev environment on an Azure VM, exploring this for a specific requirement?
It's a good question. Absolutely. We've done it before. You know, I think with the brand new like Windows UWP hot reload, that'll make you super productive. The problem that you'll have with like Android is like the Android emulator. So like the nested virtualization, that's not a Xamarin thing, that's like an Android thing. That's sort of a problem. But I have experimented with different pieces of technology that will like forward your USB ports to a VM in the cloud. So you can plug your Android device into your like Windows machine or Mac machine, and then it will like forward it over. So that's kind of a cool way of doing it. It may not be the best experience, but it's something you could do. Yeah. And you could just go in, install Visual Studio. And a lot of developers do that today. And they just, do a lot of Windows development. And then when they're ready to do local iOS and Android, they pull it down.
Cool. So I think you answered this already. When is Hot Restart coming to VS for Mac?
I don't have a timeline for it necessarily. It's just in the roadmap. Of course, you can plug in your iOS device and deploy it. It won't be necessarily as hot and fast necessarily, but you can still do it today. If you're on a Mac though, for iOS, simulators are great. Really get you off the ground running fast. So the team is working on it, and it'll come when it comes.
So since we are PMs, I think we should take this as a feedback. So there's another question. What will be your suggestions for TDD in Xamarin and Maui? Any insights and pointers will be of great help.
People test their apps? That's a great question. Test-driven development. We work really close with the community. So whether you're using NUnit or XUnit or MS Test, those are great frameworks. Of course, Xamarin UI Test would still be supported as well for iOS and Android, or you can use other testing frameworks as well. Just whatever you enjoy. I kind of enjoy XUnit. We use XUnit a lot with Xamarin Essentials, so you can definitely give that a peek. Yeah.
Another question: are custom renders gone?
I haven't written a custom render in like 3 years. So to me, they're gone forever. But no, you can still do them. You can extend, of course. And they, like I said, they've re-architected it. So it should be easier than ever.
Perfect. For hot deploy, do we still need physical Mac?
Not for development, no. You will need an Apple developer account, a paid one, just the normal $99 one there. And obviously an iOS device. That's only for development. You can't distribute the app. You can't get the app, onto different devices or deploy it. There are some limitations as well if you're using maybe your Apple Watch sensors or something like that and connecting. But for most use cases, it'll just work. But yeah, you can just do it. I don't even have a Mac. I don't have one here. So yes.
Perfect. So with this .NET MAUI, will this provide the capability to migrate the existing Xamarin Forms project to the new platform, .NET MAUI?
Yeah, great question. Yeah, so the idea here that the team has is that there's this tool called TryConvert. This is really popular converting WPF and WinForms apps from .NET Framework to .NET Core. And the idea is to extend that .NET convert to convert Xamarin Forms over to .NET MAUI. And it'll do its best. There might be, guides of how to do it, but that will be the try. No magical conversion is 100%, but it'll do its best.
Cool. Next question, the usual one, the performance. Everyone loves performance. So how is the performance for .NET MAUI compared with Forms?
Better. Everything's better. And in fact, if you haven't played around with Xamarin Forms for a while, definitely give, with Xamarin Forms and with a lot of Xamarin projects, things are off by default. So you have to go turn on startup tracing. You have to turn on the ahead of time compilation. You have to turn on app bundles. With .NET MAUI, all of the optimizations will be on by default. That's the difference. You know what I mean? So when you go and you're doing everything, a lot of that stuff will be on by default, and the team will continue to iterate on that.
Perfect. Another question, where is the app delegate class and main activity?
Hidden. They're in there. So this is actually a great question. So when let's say you have a web API and a Swagger definition, you can tell Visual Studio to generate all your classes for you. And what it does is it shoves it into like a bin in OBJ file. It's very similar. So it's hidden. You can just say, show me all files, and you would see it there. Same with your info plist and all those files. They're just sort of hidden for you so you can stay focused. Because most developers don't have to modify a lot of logic there at all.
Perfect.
Yep.
Any updates on the Bluetooth BLE API, UWP for authorization mechanisms?
Different team. I would probably, that's a good question for the Windows team specifically. We build on top of all of their tech. However, Bluetooth is something we're looking for for Xamarin Essentials. But there's also this amazing library called Shiny. I'll put a link randomly in the chat after we get off here, and it has a bunch of Bluetooth APIs built in.
Cool. How easy or difficult is to migrate to Maui if my apps are built with MVVM frameworks like Prism or MVVM Cross?
I don't think we're at that point to know, to be honest with you. If I'm just being brutally honest with you, we're not quite at that point. I don't think we know necessarily how smooth the try-convert tool will be. Just because, .NET Maui is still in rapid development, right? You can't even go test it. Like, it's only internal builds that we have. So it is things that we work very close with the Prism and MVVM Cross teams. And the nice thing about coming out in .NET 6 is that we sort of have a longer transition time. Yeah.
Will Xamarin gets connect with any database or big data? I think the question is, can it connect with the databases like big data maybe?
Yeah, totally. I mean, already we're actually really working super close with the Entity Framework team to really help and optimize that. I have a bunch of super secret projects that are happening at Microsoft for data specifically. So I'm really excited about some of those initiatives going into next year. Yeah.
Okay. I think this is just a follow-up to the earlier performance in terms of estimates. And this is something which is hard to always say because it depends, right?
105 billion times faster. I don't know, faster. That's a good question. And Sky's probably really wanting numbers. And, again, there's a few different, estimates. What does performance mean? Is that CPU cycle? Is that memory? Is that startup time? Everybody thinks of performance difference. And in fact, a lot of times what we hear is that developers they think of performance as startup time. And like I said, that startup tracing and ahead of time startup tracing can reduce your startup time by up to 70 or 80%. So if you're looking for some stuff already that you can use, it's already out there, and that stuff will just be built in. Yeah.
Did Shell support any built-in notification badges?
Not right now, but there is a pull request. I don't know if it'll land in 4.9 or 5.0 for Xamarin Forms, but there is a pull request that you can follow on GitHub that already has it there. And you can pull down NuGets from the GitHub pull request. I do that all the time to test it. So give that a look. It's open source. Yeah.
Cool. How do we handle the permissions in Maui?
Same to how you would do them in Xamarin Forms today. It's built into Xamarin Essentials, has 100% cross-platform permissions built right in for iOS, Android, Windows, and Mac. Yeah.
How will the handling of Android permissions as required to be declared inside manifest of Android?
Exactly how they're done today. So in today's world, you can declare those permissions with assembly export attributes. So you can do those. But again, you can always get to those files and add them manually yourself. But also similar, there'll most likely be some tooling. I don't know if it's final to have some UI to do it. But yeah.
What will be the future of the Mono framework?
Yeah, Mono framework's still open source. It goes strong. A lot of Mono framework is supported on a plethora of platforms that are out there today. So it's not going anywhere. And in fact, a lot of the Mono project has leveraged a lot of the work of the .NET core CLR and the other way too. So there's a lot of love goes both way in it. And the idea is to bring them closer together. But there are still pieces of Mono that will still be used sort of here and here based on the platform that it's on. But for the core platform, just sort of .NET going forward there. So many questions.
Perfect. Yeah. We are supposed to be in a break, but I think it's good that there's so many questions. We don't get enough of you. So, so there you go. Do Xamarin have any plan to support web development?
Yeah, check this out. Not Xamarin necessarily. I guess I have to open a new tab here. Check this out. I do Blazor mobile bindings. This is neato. Actually, no, let me go to dev blogs and then ASP.NET, because there was a new blog that came out here. So these Blazor mobile bindings, these are really neat. Alon from the ASP.NET and Xamarin team and Blazor team has been working on sort of bringing Blazor and Razor to mobile. This is really neat. He just put out this blog post of how you can mix and match native and web UI together. And this is sort of a first-class supported scenario for .NET MAUI. So we're working extremely close with Blazor to do that. Now, as far as bringing sort of .NET MAUI or Xamarin Forms to the web, we don't necessarily have any plans currently. I don't think, not to say that it'll never happen, but I think with the combination of Blazor and some also third parties that are doing that, it's a little bit tricky. But we want to make sure that, hey, if you're already building a Blazor application or a web app, you can sort of easily do that over on mobile as well. So that's a great blog.
Okay, the questions keeps coming. So, will MAUI be compatible with Tizen?
Yep. Yeah, the Samsung team supports support for Tizen. And when you go to the .NET, this one here, you can see it here. So you can see Linux supported by community, Mac OS by Microsoft, Tizen by Samsung. Windows will have WinUI 3, which is UWP by Microsoft, WPF by community. And then here you can see app models will be MVU, MVV, Blazor, and reactive extensions. So it's a great repo to go look at.
Cool. So I'm going to stop with questions. Probably you can go and answer some of that on YouTube directly.
Sure.
I'll just bring in Swami and Durgesh to the stream. So if they have any other questions, of course, they are the community people, so they can help with the questions as well. Yeah, anything else you want to communicate? Go ahead, Durgesh and Swami.
I don't have any questions, but it was an extraordinary presentation, James, as usual. You rocked the show. Thank you so much for joining us. Yeah, we hope to see you coming more in future events too. Yeah,
absolutely.
Yeah. I think a lot of questions for James for today, and let's, I think, probably re-welcome James in his own tone, right? Like, I am a fan of like Xamarin show, and usually like hope like you're all excited to meet James here. That's the community contribution we would expect from everyone, and hope it's a tiresome day for you and the app which you're working on for the back pain, right?
Yeah.
Currently hope this is helpful for everyone. Yeah.
Awesome. Well, thank you for having me. I super appreciate it. I'll hang out for just a little bit in the chat and try to answer a few more questions. But thanks, everyone. Have an amazing .NET Dev Summit. I can't wait to go rewatch. I'm gonna be in bed pretty soon. As you can see, like I'm starting. It's a little hot in here. I have all these lights on. Like if I don't have my lights on, check this out. It gets so dark. So I have like these. So I'm getting there. Just like Nish has those lights on too. So, but I appreciate it. Have an amazing Dev Summit, and thanks everyone for the awesome questions. And if you have anything, feel free to hit me up on Twitter at James Montemagno. It's right there.
Yep.
Yeah.
Perfect.
Cool. Cheers. Bye.
Thanks, James.
Yeah. Thank you so much, James. Thank you.
Thank you, James.
All right.
Hey, audience, please keep your questions coming. Like we mentioned, there is an AMA session in the end too, so please keep it coming, and then we'll get those answered for sure. All right. Otherwise, you have the Twitter handles of all of us. You can definitely reach out offline too. So with that, I think next would be, we just saw about how awesome it is to do mobile development with .NET. Next up would be on the web development on Blazor. So yeah, over to you, Ravi.
Hang on, I think we just have a few more seconds. Let me just bring in Ravi in. And all right, Ravi, take it away.
Hello, everyone. I hope you are enjoying your Dev Summit. And after I have very big shoes to fill, I think James has given so much about Xamarin. So I'll try to cover up as much as I can for Blazor. So my session is full stack web development without JavaScript. Uh, so before starting, let me tell me something about myself. I'm a certified Azure solution architect, community speaker, and founder of .co Techies. All my social handles are Techie Rathor. So if you just Google Techie Rathor, you can find me everywhere. So without further ado, let's get started with the agenda for today. So today, my first, we'll talk about full stack development decision confusions, what we have, what is full stack development, full stack web development, what are the confusions developer face during doing full stack development. Then we will talk about what is Blazor, how does it solve this problem. I'll show you something about the Blazor project structure, what are the controls, how it works, and all those things. Then we'll see the difference between various Blazor hosting models. And then we'll see some of the third-party libraries which are available for Blazor. And what are the future possibilities, or what are the possibilities with Blazor, what kind of applications you can develop, which what people are doing, and what we can do in future. And of course, at the end, we'll talk about how to get started with Blazor. And then I'll take some questions. So when we talk about full stack web developer, the official definition for full stack web developer is that someone who can work on both backend and front end. So someone who knows about all the backend and front end technologies. Usually the front end technologies are mainly based on JavaScript technologies, like you have Angular, Vue, React as a front end, and then you have .NET, Node, Java, Deno, these as a backend. So when we see in the form of a diagram, we can see here like this, that when we are doing a full stack development, we have a backend like this, which has Node, .NET, Go, or Java. And we have a front end like this, where we have Angular, React, Vue, or any kind of JS framework, which communicate with the backend. So this is fine, this is good, but the problem is, like, there is a lot of problems with this kind of approach. The problem is, the first one is, whole lot of people don't like JavaScript. Like it's not like that they don't like it, it's like they are not comfortable with it. Many people who are working on, who have worked on Windows application, who have worked on ASP.NET, regular ASP.NET web forms, or regular ASP.NET MVC, who has not done work much on JavaScript, they face a lot of issues, or they are not that much comfortable on learning JavaScript framework, because there are many issues behind that, like they are dynamically typed, they have issues with the browser support, and it changes too fast. Like you have after every year or so, you have new JavaScript framework with completely new changes and new features. So in that scenario, another problem is, like, most of these JavaScript frameworks follow the single page architecture framework. So if you see, for single page architecture, the problems we face are, we have two different teams, the front end team and the back end team. And the front end team is in most of the cases, they are on a different technology, whether it is .NET or Go or Java. They are working on a different technology, so they have different code base. And backend, it's almost like when we talk about native mobile development, where we have different teams for doing different tasks. Similarly, training to be a full stack web developer is a costly affair. And when we use different language than JS in backend, then sharing code logic is also a problem. And now, currently, most of the application have different backend than JS. They are either written in .NET, or they are moving towards .NET Core, or they are written in Java or other technologies. So there are a lot of these problems in when we follow this current approach of developing web applications using JavaScript as a front end and different technologies as a backend. Especially the problem is for .NET developers who are in the middle of their career, so they have to move. They are growing, so they think that what should we do? Which technology we should go on? So we have Blazor as a solution for this. So what is Blazor? Blazor is basically a free and open source web framework that enables developer to create web apps using C# and HTML. So you don't have to learn JavaScript for this thing. Yes, your JavaScript knowledge will be, of course, an added advantage, but you don't require that much JavaScript that which you need to learn in case of developing web UI using regular frameworks, that is Angular, React, or Vue, because they all have different approaches to follow. Even jQuery has a different approach. So even if you just know simple JavaScript or jQuery, it will work like it will work well. Another thing is it uses Razor syntax. So the people who are already working on ASP.NET MVC or who are working on ASP.NET Core MVC, it is very easy for them to learn because it uses the regular Razor syntax. And it uses the component-based single-page architecture. So it uses the same component-based single-page architecture which is used in all the new technologies, that is Angular, React, or any other front-end framework. So it uses this component-based architecture. There are currently two hosting models for hosting your Blazor application. One is Blazor Server, and another one is Blazor WebAssembly. So Blazor Server is like available. You can host it on the server using .NET Core base, and Blazor WebAssembly you can even host as a static site. So these are currently two hosting models available for Blazor development. So when we talk about now, when full stack development using Blazor, so you can see we have the same backend technologies, but for front end we have Blazor for doing all the tasks which we used to do. For that we have to do earlier using a couple of different languages. So we need not to learn so many languages. We can do everything with the same C# and .NET. So if you are a C# developer and you have a .NET background or .NET backend, you can very easily move to front end using Blazor. So why you should be interested in this? So the first is, of course, C# is a fantastic language. It's not like JavaScript is not, but yes, C# is very good language because it has more capabilities, it has more features as compared to JavaScript. Another one is that since Blazor is based on ASP.NET Core, the performance-wise, Blazor is much more faster. It is, as you know, like ASP.NET Core is number 7th on Tech Empower performance listing. It's 8 times more faster than Node.js. So when you host a Blazor server app on ASP.NET Core or .NET Core, it is available and it is much more faster than Node, much more faster than Django, and much more faster than any other server. And of course, the best benefit is that you can share logic with existing .NET background. Right now, I have developed a couple of applications where I have used the same code which I have used in my web application, and like you can share the same model, so you don't have to write the different model for client and server. You can use the same model classes as .NET standard library, and which I have done. Not only this, you can even share the code with your Xamarin application. So most of us people joining here are Xamarin developers. So you can also share your code with Xamarin applications. So a lot of code sharing is there. So you don't need to write new code for doing the for client-side development, also for client-side applications. And of course, it consolidates the front end and back end team together, and it's more of a one team, and you become a complete full stack developer who knows almost everything, almost end-to-end development. So let's with this, let's go to some practical implementation. So right now I'm in my Windows machine where I have Visual Studio 2019 open. So let's see how we can create a new Blazor application. It's pretty simple step. Many people have told you, but let me repeat the process once again. It's very simple. It will load all the Razor templates, and you can just select a Blazor app. It's already there in my recent application list. So I'll select the Blazor app, and when I hit next, I can just give the name .NET Summit, and I hit the create button, and we'll get the option to select the two options. So that is Blazor Server and Blazor WebAssembly. And you can see whatever features we have for developing our web application, ASP.NET Core web application, the same features we have that for Blazor also, whether you use Blazor Server or Blazor WebAssembly. So when you use Blazor Server, you have the option to implement authentication. You can use the individual user authentication, which is your identity server based authentication, or you can use the Windows authentication or Active Directory authentication. So you have the feature to implement authentication also. So whatever feature you have in regular ASP.NET Core applications, all those features are available in Blazor Server as well as Blazor WebAssembly. When we select Blazor WebAssembly, we also have options to either, by default, it is a static hosting. It doesn't support like ASP.NET Core. If you select this option, it will show you the ASP.NET Core hosted Blazor application. And if you select Progressive Web Application, it will by default give you the out-of-box or boilerplate code as your Blazor application to be a Progressive Web Application. So I'll go with the Blazor Server app. And while it's creating this thing, so I'll show. So this is our regular Blazor app. We see here we have our regular Blazor app, and let me show you the structure of this app. So as you see, I have used the server setting, ASP.NET Core server setting. So that's why Blazor Server app. So that's why it's asking for ASP.NET Core. And you can see that it has the same structure of ASP, that it has program.cs and it has startup.cs. So it has startup.cs, it has program.cs, and it uses the same methods and functions of which we have in ASP.NET Core application. So you can see this is like we are configuring the services here. We are adding the Razor pages and adding the server-side Blazor. So this is for server-side Blazor. And when we talk about the structure of the application, we have this thing. So this is the Blazor project structure. So we have one app.razor. So this app.razor is the base of the application. It is the complete base of your Blazor application, which loads the first page of the application. Even when the HTML is, when the Blazor code is converted into HTML code, this app.razor, you will see that there is a tag called app, and inside that all your Blazor code will be loaded. So let me run this thing and show you that source code, and you will be able to better understand that. So while running, while it is being run, let me show you the rest of the thing. So we have this shared folder. Yeah, so this is coming up. So in the meantime, let me show you. So we have this shared folder. So this shared folder has main layout, nav menu, and this survey prompt. So these are all components. So as I said, these are Blazor is basically a component-based architecture. So you have everything as a component. These pages, all of these pages are components. So this host.chtml, this is the first page, or you can say the single page or SP architecture-based page, which is which hosts all the controls of the Blazor. And then these rest of the pages are your separate pages, or you can say separate components which you can utilize. So when I run this, so you can see this is running here, and this counter application is running like this, and then we have this fetch data, which is showing this is the default or boilerplate Blazor Blazor project template, which has all the Blazor related features implemented. So it has this thing, and then we have this forecast code and this. So this is all component based architecture. So you can see here, this is all component based architecture. This counter page, this you can see here, this is a page component where we have this routing directive. This basically this controls the URL. So this is counter is this routing URL, and you can see here that counter is starting here like this, and you can see this one, that this is the route here. So if I want to change this thing, like for example, somebody wants to start the counter with a certain value, so what I can do is I can stop this thing and I can start this with counters slash. So we can give something like this. We have, I think, ID. So like this is, or we can set this thing. So right now current count is coming like this. We'll see this one. So, and this will be public. Okay, and we'll add this as an attribute as parameter. So when I give this public parameter like this, so by default it will be ID as, is giving me some error. Okay. So we have this. So I have done this thing, and what will happen, by default I'm setting this as 0. So increment count is this 0. So when I now run this application like this, so, and when I go on counter, here it's giving some error. So I think I have to set some parameters, and this thing, this will be probably, I have to give this as integer, I guess. So I'm forgetting the syntax here, but we can change this thing. We can give the parameters like this to the page, and we can do this. We can change the parameters, and we can change the page, what page we want to call, and which different pages we want to use. We can do all these changes. Not only this, let's say this is the index page, and I want to use counter here like this. So if I put counter here like this, and I run this code, yeah.
Hey, Ravi, just a quick thing. Maybe you want to increase the font size a little bit so that everyone can see it well.
Okay. Sorry. Can everyone can see now?
Yeah, looks good now.
Okay, so when I run this thing now, you can see here the counter is coming on the index page. So when I click on this, so this is completely component based architecture. Another benefit of this Blazor being component-based architecture is, as I showed you, this this sample application is basically a Blazor server application. I have another application here. I have opened this one. This is basically a an sample application which I use for my blogs. So this one. So this is basically a sample application which I use for my blogs. That is TR Blazor EX, and I have implemented all the examples here.
Ravi, if you're showing the Solution Explorer, maybe zoom in as well, because on the stream it's very low.
Okay, so let me see. Sorry. I think.
Do you have something like Zoom installed?
Yeah, Zoom. I'm just increasing the fonts and this thing here.
Okay.
Right. Yeah. So instead of this environment, and okay, I hope this is increased a bit. Yeah, so I hope you guys can see it now. So this is the Blazor server. This is the sample application, TR Blazor EX, which is available on my GitHub. I usually use this sample application in all my blogs. So we have this Blazor Wasm here, and we have this Blazor server here. Both of these are two different projects. And just like Xamarin, what I have done in our Xamarin application, what we have is one common UI page, or sorry, one common UI project, which is our .NET standard project. Similarly, we can create a Razor class library, which is again a .NET standard project, and we can do all the UI, or we can move all the UI in this Razor class library, and we can utilize this in both in Blazor server as well as Blazor Wasm. So let me show you this run this application, and this is the same project code, but I have moved it in separate UI. So if you see here, let me run right now. The default project is Blazor Wasm. Okay, so if I run this thing, it will show me. So the UI will be exactly same in both the scenario. So this is how we can basically change or yeah. So if you see here, it's loading. So see, this is Blazor Wasm. So it's taking some time here. And how we know that this is Blazor Wasm? We'll go in the tools. We'll see in the developer tools, and in the network section. If you see here, if I hit refresh, you can see here. So this is our Blazor WebAssembly.js is being called. This is the local host JS, and this is the same application. So it has counter. I have moved the counter here as a component. Then I have created one checkbox list example. So I have written a blog about creating a checkbox list in Blazor. So I have added this here in this project itself. So you can see this is our Blazor WebAssembly application. And now if I want, I can, what I'll do, I'll just stop this here, and I'll set this server as a startup project. So now I have set the server as a startup project. And when I run this thing now, so now you can see now that error screen didn't came, because now we are using the Blazor server. And if we see here, you can go in tools, developer tools, and network. Now when I refresh this page, you can see here we don't have the WebAssembly page. You can see this. we have Bootstrap, Min, and all those things. We don't have the WebAssembly page. So sorry. So we don't have the WebAssembly page. So this is how what we can do is like Blazor can give you the option to share your code between Blazor server and Blazor WebAssembly, and even the future implementations of Blazor, which will I'll tell you like what all further possibilities of Blazor are. Like you can even create desktop applications using Blazor. So for that also you can use the same UI. I am doing the same kind of implementation in a couple of my applications, and I have written a blog about this also, that how we can create this thing. Let's see as I was explaining the structures. So this shared section is your common. This is where you'll keep your common code. That is your like layouts and controls. So layout is this main layout is it uses this layout component base, which is basically used for, it's similar to your layout.razor in your MVC application. So this is where you can integrate your nav menu and other things. So this is main layout page. And as I have created this checkbox list.razor as the shared project. So this is shared page or shared control. So that's why I have kept it here. We can even move this Razor class library as a separate project. It's already a separate project, so we can create a DLL out of it, and we can utilize in another Razor application also. Similarly, this imports.razor is basically imports used for declaring all the common using statements. So when we declare all the common using statements here, we don't need to declare it in other pages or on the various pages or controls which we are creating. We don't need to declare this common here. So we can utilize it. All the pages can change their objects or whatever components we are using. We can utilize this thing. So using this, we can done. And if you see the implementation here in my regular Blazor application, in the pages, we have this host.chtml. Whereas if we see the Blazor WASM structure, so in Blazor WASM, we have host.index.html, which is there in www root. And in our Blazor server, we have this pages, and inside pages, I have this host.chtml. So you can see here in host.chtml, we have this Blazor framework, Blazor server, and in our index.html, we have this Blazor WebAssembly. So this is how the component-based architecture of Blazor works basically. Okay. So let's move to slides now, how we can share the logics and all those things. So now we can see I showed you what are the different hosting models of the Blazor server and Blazor WebAssembly. I also showed you what is the component structure of Blazor, how does Blazor works, and how we can achieve a implement a common UI to utilize in both the hosting structure. So when we should use which hosting structure, let me tell you that. So we have client side, that is Blazor WebAssembly. We can use for developing progressive web apps. You can see that while creating the project itself, we have the option to select the project as a progressive web app. So if we want to create a progressive web app with a zero latency UI, or we want to host static files, or we want to create a offline applications, in all these scenarios, we can use Blazor WebAssembly. When we talk about Blazor server, so if you want to use a thin client application or even a regular web application, and you want to utilize the full runtime support of .NET server or Blazor server, .NET Core, then you can use Blazor server. So if you are using Blazor server, you will get all the .NET Core support, all the features which are there in ASP.NET or .NET Core framework. You will be able to utilize those features on Blazor server. And of course, in some scenarios, like you are creating some application or something which is basically copyrighted for your company, in that scenario also you can use Blazor server because all the code is on the server. Another thing, another benefit of Blazor server is that you can move your your current web form application, because even Microsoft is writing a documentation and Jeffrey Frizz or C# Frizz is creating Blazor web forms control. So you can migrate your current web forms applications to a Blazor server application. So Microsoft is suggesting this thing, and many people are doing that, that you can convert your existing Blazor, ASP.NET Core web forms application to Blazor server application. So all the code is on server. So in this scenario, you can use the Blazor server. Third-party Blazor components. Most of the third-party Blazor components are available via NuGet, and we can use all the JavaScript libraries available for any web application in Blazor also using JavaScript interop. So JavaScript interop is a feature where we can call C# code in JavaScript and JavaScript code in C#. So all these features we can do in Blazor itself, whether it is Blazor server or Blazor WebAssembly. And the Blazor specific libraries are like open source libraries. Many open source libraries are available. Blazorize is one of them. Then we have Matte Blazor. Then we have Radzen Blazor controls. So all these three are like Matte Blazor and Blazorize are open source. Matte Blazor basically uses Material UI. So those of you who are fond of Material UI or material design, they can use Matte Blazor for that. Those of you who want to use Bootstrap based UI, Blazor by default support Bootstrap based UI, but I personally choose Blazorize to use because Blazorize is again open source and it supports more CSS library than Matte Blazor, because Blazorize supports Bluma, Bootstrap, and even your material design, whereas Matte Blazor is only specific to material design. Then there is Radzen Blazor controls. So Radzen Blazor controls I specifically listed here because these are of course free controls. So you can use these Radzen Blazor controls as free controls. But one benefit you have, so those of you who are working in companies and who want to go for low code or faster low code, no code development. So there is one Radzen UI generator or Radzen UI. So you can search for Radzen and you can get there is a Radzen UI generator using which you can create a whole Blazor application using a drag and drop feature. So that is there. So you can utilize, you can even implement no code or low code development using Blazor server and Radzen. So that is one of the benefit of using Radzen. Then our usual vendors of UI, that is your Infragistic, Syncfusion, Telerik, all of these have created Blazor specific UI controls, which you can utilize in your regular Blazor application. Now let's talk about the possibilities of Blazor, what all we can develop using Blazor. So when we talk about Blazor, we have right now client-side development available using Blazor WebAssembly and server-side development using Blazor server. Then there is, you can develop Blazor desktop application using Electron.net or using Web Window. So Web Window is another experimental framework which helps you create cross-platform desktop applications using Blazor or any JavaScript framework, just like Electron. It's experimental and it's also developed by Steve Sanderson, who created Blazor. So this is Web Window is also available as a NuGet package. So using Web Window, you can create cross-platform desktop application. The only requirement for using Web Window is that you need to have a Chromium-based browser on your machine. So if you have installed Edge Chromium on your machine, whether it is whether it is Mac or Linux or Windows, then Web Window will work directly. Whereas Electron basically ship its own Chromium-based browser along with the framework itself. However, Web Window, the footprint of Web Window is very smaller to Electron. So when you create a Blazor plus Electron desktop application, the setup or the whole footprint of that application would be around 150 megs or 120 megs. Whereas when you create a Blazor plus Web Window application, the footprint of that application would be around 20-25 megs, not more than that. So you can try that. It is not committed as of now that when it will be released, but people are of course using Blazor plus Electron very much. Blazor plus web window is used by people like me who are experimenting with Blazor. So those people use Blazor plus web window, but it is there. So you can create desktop applications also using Blazor. Another thing is Blazor mobile binding, which was announced in Blazor full day conference, which happened in January of this year. So Blazor mobile binding, using Blazor mobile binding, you can create native mobile applications for Android and iOS using Blazor itself. So not the same UI, you have to write separate UI for mobile, of course, but it has the controls similar and the structure similar to your Blazor application. So there also you can use the layouts, and then there are stack controls, checklist controls, and all the separate controls available using which you can create Blazor mobile application. So you can use the Blazor mobile bindings to create Android and iOS mobile application. Under the hood, of course, it uses Xamarin for creating the UI. So these are the possibilities with Blazor. So you can use Blazor in so many ways. Not only this, people there was one community presentation. I forgot the name. James know his name. I think Gordon something from Australia. He presented that how he has used Blazor and Xamarin to create a complete end-to-end application, whether it is mobile and web application using Blazor server and Xamarin, and he has shared the most of the code, the MVVM code, the code logic of changing the UI from the view model. So all those things can be done if you are using Blazor as your development framework. So how should we get started with Blazor? So to get started with Blazor, we have Visual Studio 2019. By default, when you install Visual Studio 2019 with ASP.NET, it will you will have the Blazor projects included in it. And you can visit the official doc site, that is blazor.net. There you can get the step-by-step guide on how to get started with Blazor. Apart from this, there are a lot of community docs available, like this Stephen Tree Kramer Awesome Blazor, and then Adrian Torres Awesome Blazor. Both of these GitHub libraries have list of all the Blazor contribution done by community as well as Microsoft. It has list of all the various tutorials available and everything. So these all this is using these all resources, you can get started with Blazor very easily. So I think I have completed on time. I finished it in almost 40 minutes, I guess, and we are done. So any questions? I'm ready for questions now.
That was super fast.
Yeah.
Add me and Durgesh as well, so that they're also watching the Twitter to see any questions. And okay, let me add some questions for you.
Yeah.
Okay. This is a question: can we use Blazor assembly to hit REST API like Node, Java, or Go?
Yes, of course, we can do that. As I showed here, I need to I can open, as I said, I have created applications using Blazor WebAssembly, and right now there is one client application which is running using Blazor WebAssembly. So yes, we can hit REST APIs using Blazor. You have that system.net.http available as a NuGet. So you can just use the same way you call REST APIs in Xamarin. You can use the REST APIs in Blazor also using the HTTP client. So I have done that, and you can do that also. And then there is, if you are using Blazor WebAssembly and the preview version of .NET Core, then you can also get one library called system.net.mvc Blazor HTTP client, which supports you, which has integration of HTTP client and your system.text.json. So you can use the JSON async and get JSON async, post JSON async. Those are methods you can use from Blazor WebAssembly, but that is experimental. I personally use system.net.http client, which is the default client for using or calling WebAssembly, calling REST APIs from your Windows or web applications in .NET Core. So using that, you can call the REST APIs.
Okay, so we have another question. what are the development options with Blazor in cloud?
So when we are using
Deployment options.
Okay, deployment options. So when we are using Blazor in cloud, we can deploy anywhere where we are using .NET Core. So if you have a .NET Core server, you can deploy it there. So it can be deployed on a Linux machine. It can be, if you are using Blazor WebAssembly, it can be deployed at a static site also. So you can deploy your Blazor WebAssembly code, Blazor WebAssembly application as a static site on GitHub pages, or you can deploy it on your AWS volume, your shared spaces, and then you can give a URL and you can utilize it. So that is for Blazor WebAssembly. For Blazor server, you will require a proper .NET Core server. So it can be a self-hosted .NET Core server on a Linux machine, or you can use app service, which is given by your Azure. You can even host in IIS. So like right now, my current project implementation, which I have done for my client, I have hosted the Blazor server on IIS. So you can also host it on IIS. It can be hosted on app service. It can be hosted as a self-hosted service. So whatever, so Blazor server can be hosted in all the different ways. A .NET Core or ASP.NET Core application is web application is hosted in the same way Blazor can be hosted, and Blazor WebAssembly can be hosted as a progressive web application or static site. So these are all hosting options available.
Cool. Does Blazor support single page applications and lazy loading features?
Blazor is based on single page architecture itself. As I showed you that Blazor uses single page architecture and everything is a component. So yes, it supports single page architecture, and it's based on single page architecture. Regarding lazy loading, I'm not very much sure about it, but I think it is coming up in with .NET 5.
Can you tell the main difference between JavaScript and Blazor?
JavaScript, you have to, like, the main difference between JavaScript and Blazor is like using JavaScript, you can access the, you can't, like you can use the UI, you can change the UI similar, but you have to use JavaScript for that. But in case of Blazor, you can write C# and Razor code to call your, to manipulate your DOM or to manage your component. So the primary difference is that you can use C# code instead of JavaScript. You can use C# code, and JavaScript is also available. So that is one of the added advantage, that when you are using Blazor, you have C#, Razor, and JavaScript available for your users. Whereas when you are just using JavaScript, then you have only JavaScript available for users. And for that, you need to know about JavaScript frameworks. That is your, whether it is jQuery or your Angular or React. So all these, you need to know about nitty-gritties of those frameworks. Whereas when you are using Blazor, you just need to know about C# syntax and like small JavaScript, if needed.
I missed some questions from before, so I'm just going to add it back. Does Blazor run on Kestrel?
Yes, Blazor of course run on Kestrel. Like I didn't show you the example, but Blazor server run on Kestrel, because as I said, Blazor server uses the ASP.NET Core hosting model, or whatever features are available in ASP.NET Core. Those all are by default available in Blazor server. So Blazor server runs on Kestrel. Blazor WebAssembly doesn't run on Kestrel. It's like it can run on Kestrel also, but it is by default, the whole code is downloaded on the client side. So like it run on the browser of the client, but it can be hosted on Kestrel, just like Blazor server.
Cool. One question: does Blazor support server-side rendering? If yes, do we need to do any changes on server-side, or will it take care from Blazor itself?
So if you are using Blazor server, it of course support Blazor server-side rendering by default. And there are a couple of methods in the host.chtml where you can use either server rendered or server pre-rendered or Blazor server. So these three methods are there. By default, it is Blazor server setup, and all the rendering is done on the server itself. So basically the way Blazor works is a Blazor server works is like it does a diff between the UI changes via a SignalR connection and update only those UI which is being changed. So these things are done very fast. So all the rendering is done on the server. This is only in case of this Blazor server. In case of Blazor WebAssembly, everything is done on the client side itself.
Sure. Okay, I think we answered that. Okay, let me add this. How Blazor is different from .NET Core MVC? Which one is better to use for project as, I think, as per performance?
Blazor is different from MVC is that because MVC is not a single page architecture based framework. Basically, MVC uses multiple page architecture where you move on different pages. Of course, routing is there and all those things is there. But Blazor server uses like single page architecture, component based architecture it uses. So Blazor component, you can reuse the Blazor component in Blazor WebAssembly as well as Blazor server. So of course, my suggestion would be that if you are going to use, like you are going to create a new ASP.NET Core application, then you should go with Blazor rather than MVC, because Blazor has much more, you can say much more versatility to be used at different places than MVC. So using MVC, you can just create web applications, whereas using Blazor, you can create different kind of applications also. But architecture is different. In case of MVC, you have multiple routed application. It uses MVC architecture, whereas in Blazor, it's single page architecture based application. So it's more comparable to, you can say, Angular React based application where you have components. So it's more comparable to that.
Okay,
Hey, sorry to interrupt.
Yeah.
Yeah,
But
right.
I think we're
Yeah,
seeing
sorry,
this
Nish.
speaking
Yeah.
again.
So, yeah, right. Great questions, guys. Please keep them coming, and Ravi would be there, and then he could answer on the YouTube comments, or also, like I mentioned, we have a dedicated AMA post lunch for 45 minutes. We could definitely go in depth in for all the questions. Okay. So thank you so much, Ravi. That was a great presentation. So up next would be Renuka on SignalR. Yeah.
Okay, so I'm gonna add her to the stream. All right, Renuka, you are live. Take it away.
Okay. Hello all. Good morning, good afternoon, good evening. Welcome to the presentation, Building Real-Time Web Apps with SignalR. So I am Renuka. I work as a Principal Software Engineer at Itron. So starting with the agenda for today. The need for real-time communication in utility industry and why SignalR, and what features that we get with the SignalR, and how do we scale the apps using the that are using SignalR. And I would take the question and answer in the end. Okay, so starting with the need for the real-time communication with in the utility industry. So Itron is a leader in utility industry. It has been providing smart metering solutions. So in the smart metering solutions, Itron's distributed intelligence system provides solutions in grid to the grid solutions, and then to the individual customer engagement as well. So in the space of utility and customer engagement, there are different apps that have been provided. So as we all know, at home every day we use multiple utilities, starting the day with a tea or coffee kettle, and then our microwaves, refrigerator, and then the washing machines. So as an individual customer, I would like to know the utilization. So instead of getting the bill at the end of the cycle, it could be a month. However, the provider gives an option to pay the bills. So instead of getting an heart stroke by seeing the bill, I would like to know as an end customer, what is my utilization? Which of my utility is taking the more power utilization, which is utilizing more power. And I would also like to know from the power grid provider, that means as a provider, for example, DESCOM as a provider for the electricity space, in the electricity space. So they would like to know where the utilization is more, and where there is a low power catch-up, and if there is any theft of, so the meter would send an alarm saying that there is a theft, that the bypass of the electricity is happening, so that the provider can take an action in order to control the theft. So these are all the cool features that are provided in the smart metering solution space by the ITRON. Then we'll look into, I will go through and explain how technology has been made, SignalR has been made in use here in order to get the real data exchanged between the provider, the grid, to the grid, or to the electricity power providers, and to the individual customers as well. Moving on to the system view. So here we have, this is the system view, how the application runs at the ITRON. So starting with the dashboards, which will help the providers to look at various aspects. It could be at the grid power, where the loss of the power is happening, whether it is at the transformer that is happening, or it is at the individual house where the power loss is happening, which will help to take the measures to avoid the loss of the power. And then there are specific outcomes that are built, since as a company it provides metering solutions for all the three utility spaces: power, gas, and then the water meters. And then we also have an application store similar to our mobile app store, which has a solution for a specific problem. Since we all are used to the apps utilization in the current world, and we would like to save our time, instead of going to the provider's office and raising a complaint when there is a power trip at the home, or if there is I would like to understand which of my utility is taking more power utilization, or during the peak hours, how can I save my power? All this can be done at the individual customer space. So for that, any provider can host their apps into this app store, and ITRON app store is compatible with not only with ITRON apps, but the other apps as well. So the application is deployed in the cloud, and we have the individual meters sitting in the customer environment. So this is an individual meter that we have, and the application, there are two components that run in the system, like a head-end system which communicates with the meter. So it is all in the form of the commands that it gets the data from the meter, and it also does a network and device management. So network and device management, this is basically a firmware software that runs over here. So we need to know what kind of commands, like the head-end system can be anything, and even the meter can be any, need not be ITRON's provided meter as well. So there is a standard data exchange format that has been defined between the meter and the head-end system, which is retrieved by the head-end system and even also sends a signal to the meter. Now we also have another component which listens to the instruction. So suppose say as an individual user of my house electricity consumption, I would like to know. So I have installed an app which shows me utilization of the utility, and I would like to know at the peak hour today at 12 o'clock what is my utilization. I just can ask for a utilization, or even for a last 10 days what is an utilization, why am I seeing more utilization, which utility is given. So in that case, I just go to my app which I have installed in any of my mobile or wherever these apps are supported, and I would ask for an report, that utilization report. So what happens over here is basically the commands are sent by those outcomes to the connector. So the connector sends the instruction to the one which is sitting in the customer environment. So the upper part, as it is mentioned over here, these are running in the cloud space. So we have dashboards, outcomes, and app stores, and there is a communication that happens in from outcomes to the connector, and connector passes the communication commands, and then it will get the data from the head-end system. So there are different features, cool features that are provided. Then how do I get the data? So we have now, what I mentioned now is about the apps that are deployed in the cloud, and I am talking to an air gap environment at customer site where these head-end system and then the meters are distributed across. It could be at the power grid or it could be at the individual house. So we have made use of the SignalR over here in order to exchange the data. Say for as an individual customer of electricity, I would like to switch off my meter. So every day I go to office and no one is at home, and I don't want my utilities to be using the power. I am okay to be switched off so that I get some benefit, and even I would support for a green initiative. So I would set a setting in the app saying that the every day at 10 o'clock it should get switched off, and then in the evening 5 o'clock it should switch on. So I can't do every day. When I go to office and when I come back, I don't want to switch it on. So I would like to this to happen automatically. So what I would do is in the app I would set this setting, and the instruction goes to the meter via connector. So anytime that I wanted to have the data that is exchanged between my apps and the real meter can be done. So for that, we want to achieve that. So for that, we have made use of the SignalR feature. So moving on to ASP.NET Core SignalR. So the cool features that are provided with the SignalR, it is an open source library, and the data can be exchanged between the hub and then the channel, and it also supports message pack and JSON data communication, and it uses HTTP based communication based on the available communication mechanism. It switches as well. So it also pushes data to specific client and group of client. So as I explained before, my requirement is I wanted to like there are thousands and thousands of houses who are using the electricity or water and gas. So each may not have the same requirement. So I cannot switch off power every day in the morning 10 o'clock and switch on by 5 o'clock. So my requirements are different. So for each of them, this communication is different. So for that purpose, should be able to communicate with specific client. In my case, it is a meter, and it is a group of clients. If there is any general communication that need to be done from the provider, say BESCOM wants to say that we are going to have a power outage, like say tomorrow 30th of August from 10 o'clock to 5 o'clock. So they would not come and do an announcement. So what do they do is they would send a message to everyone. So this is a kind of a broadcast message that they wanted to send. So, and they say in specific location, it is only say in JP Nagar they wanted to do the power outage, that can be messaged only to a group of people. So with these requirements, we have chosen ASP.NET Core SignalR, and then the SignalR scales out. Since we have multiple meters, it is not sufficient just to run one or two instances. So we should be able to scale out as well. So with that requirement, SignalR suits here. So it can scale out with Redis or service bus or SQL as a backplane as well. And bidirectional communication, that is more important requirement that we had. It is just not that the customer only alone should be able to communicate with meter. Meter also should be able to tell us, say in this case, meter theft happens. So someone tries to pull out the meter from the location at the individual house. So in that case, it will raise an alarm. So the provider gets a notification. So as there are apps get to know the exact location where the meter is been installed, so they can trace out to that place, go to the place and stop the theft that happens. And it is so generally you would have seen SignalR with our chat applications as an examples, but here our requirement is not from UI communication. It is between the apps and then the devices, or it could be between the devices as well. So with that reason, with all these features, SignalR was chosen as a requirement, as a solution to provide for our requirements. So in SignalR, the components, the main component in SignalR is a SignalR hub. It is a pipeline that defines the methods that can be called by the client. So you can expose as per your requirement in the SignalR hub. Clients, whoever is connected to the hub, can get the, they can call the specific method in the hub. And it can connect to a number of clients. You can increase the number of clients that can be connected in your SignalR configuration. And as I mentioned before, we would like to have a general broadcast message from the provider in my example, what I have mentioned. So it solves, it can send a broadcast message, or it can communicate with a specific client as well. So there are notifications, the standard APIs that are exposed by the SignalR. There is on connect and on disconnect. So we can, as soon as the device gets connected, we can keep a bookkeeping of the device, and then when we want to send a notification, we can send that as well. So as I mentioned before, we have multiple clients that are connected. So the client here is a meter over here, meter, the device that is really doing the operations related to the utility space. So I should be able to communicate with the meter individually, and the meter at the same time the services running over here should be able to send the commands to perform at any required time. So for that, if the meter, say suppose my meter first, when it sent an instruction, it was connected to connector instance 1, and then later, due to some reason, the instance which is running over here died. I mean, the instance is no more available. We have spinned up a new instance, say. So in this case, if the information that is related to my first meter is lost, then we will not be able to communicate with it. So what we have done here is we made use of Redis as a backplane. So as soon as I mentioned before, whenever the on connect or on disconnect events happen, then the meter information, the agent information is captured here. So even my instance, the connectors, if they die off, the new instance comes, it will be still able to communicate with the meter. So here, going to a little deeper on how the communication is happening at the agent side. So I have an on-premise connector over here, which is nothing but a SignalR client. So the hub is nothing but the connector instances which are running in the cloud, and the Redis as a container image they are running, and even the connector instances also run as a container images in the AKS. So the on-premise connector, which is nothing but a SignalR client. So for each of the customer environment, we have this setup. So here it can be multiple meters over here. So this is one customer environment, this is another. So along with the meter, we have an agent which talks to head-end system, and whenever I want to make a communication from the server, I can make a communication to the on-premise connector, that is our SignalR client. So I'll go into the how we have to initiate the hub, and how the client sends a message to the server, and how server can initiate the communication to the client. So first, let me start with my SignalR server. So the main component over here is a hub. So how do I tell .NET Core that please use this is my hub method, and I should be exposing, because my client should understand my endpoint, the hub endpoint, right? So for that, on startup of the service, I'm doing an injection of my interface, hub interface. So here I call it as a config hub, and so this name matters here. What is the name that I would like to get it exposed? And then as a backplane here, I'm using Redis. So I have to inject the Redis connection string as well. So for the demo purpose, I'm using a Redis service, Azure Redis service, and I have hosted the server in Azure Web App container, the Linux app service. So little moving on here, as I mentioned, this name matters, right? So when my client has to communicate, so this service, this API which I am hosting here does multiple things. So my client should be able to say, know what my hub is. So for that reason, we have to say, map the hub to what is the implementation, where this implementation exists. So the config hub is a class which implements the hub methods, and I'm exposing it as a /config hub. So this is at the startup we'll have to do, and then moving on to the hub class. So I have the methods from the hub exposed from config hub. So in the config hub, I have a cache, and then the config hub I have in dependency, through dependency injection I have injected these methods, and I wanted, as I mentioned, I wanted to do the broadcast to all my clients. So how can I do that is, so hub has a method called clients.all. So here I'm not saying to specific client, I wanted to do broadcast message, so I can do that send async, and it will go, the message will go to all the clients. So this receive message matters. When I come to the client part of it, I'll explain how this receive message matters as well. And then I wanted to get a notification to the specific client if I want to notify a specific client. So as I mentioned, Redis as a backplane, it is being used. As soon as the agent comes up, that is a meter comes up, and it will say this is my unique identification. So agent ID is the unique identification which I am registering. So I have a method which I have exposed by the name register agent. So my client will make a call to the hub, this method in the hub. So I'm putting the unique identification of my agent here, and there is a unique connection ID that is given to the each client by the SignalR. So using this connection ID, I'll be able to make a call to the specific client as well. So how do I do that specific client notification is? So here, just going back to the previous method, register agent. So as soon as I get a call to the register agent, I have a structure defined, my custom structure this is, wherein other information to uniquely identify the agent is there. But the most important thing here is when the client starts, it gets a unique connection ID. So that connection ID has been provided to the Redis server. So I am adding to the Redis server here as a value, and my key is my internal logic of identifying the agent. Now, when I wanted to notify a specific agent, how do I do that is, I'm getting an unique identification ID from each customer saying that I have all this information. So whenever from the app, the customer wants to shut down a meter, so we have this information internally already. So I get that unique ID from my cache, and which is nothing but the client unique identification given by SignalR. And then I have a method on the hub to call specific client. To it, I have to pass the specific connection ID. And then again here, the receive message. So this is the method to which the client would listen and gets a notification. So I'm saying that it receives a message to send a message to specific client, and it is listening on this receive message and the actual message that I wanted to send. Okay. So as I mentioned before, I have hosted this service in Azure into web app. Then moving on to the client. So this is again a .NET Core service, is also a .NET Core web app, and these are .NET Core console applications. So here, purposefully, I'm not reading from my application setting to show how to inject the value. So here, if you see, there is a connection builder which we need to provide the hub URL. And if you have any requirement for auto reconnect, you need to provide automatic reconnect as well. So this is my hub URL locally when I wanted to run. Since I have hosted in Azure, I have my service hosted. As mentioned before, the SignalR server is running in this address. This is my web app name and then config hub. So in the hub, startup.cs, I showed this one, config hub. This matters because my client only identifies by this name. Okay. So to the connection builder, once the connection has been established, I'm going to check whether it is connected. So if the hub connection state is connected, so whenever the agent goes to the connection state, there is a method in the server which will get called, that is nothing but on connected. So I'll go back to the config hub one more time. So if you see here, I have two things, on connected and on disconnected. So these are, I'm overriding these methods on connect and on disconnect just to print a message. So here you can do anything, even in adding the to the Redis cache or to your backplane can be done here. And whenever there is a disconnect event happening, you can even remove from your cache. That can be done as well. But I have my own methods which are doing. My client calls them when it shutting down, it will make a call. So I have a business logic to be performed. So I have provided other methods for doing it. But these would get called as well. In the demo, I will show them what happens when the client starts up. Now moving back again to the client. So once the connection is established with the server with the above address that has been provided here. So the connection agent, if it is successfully able to connect, it will go to the status becomes my client status becomes connected. The SignalR client status is connected. And after that, I have some details to be sent to my server. So as soon as I connect, I wanted to send some details. So for that reason, I have my custom logic, but the main important thing are then what I wanted to perform is I want to invoke a method which is there in the hub. So register agent. So going back to the hub here, I had mentioned whenever my agent starts up, I wanted to add that information into Redis cache. So my client is calling this method, which is nothing but a register agent. Okay. So that's how the communication happens between the SignalR client and the server. So I have my service hosted over Azure. So this is the URL. So this is my controller, configuration controller. So in the configuration controller, as I mentioned before, I wanted to do broadcast message and I wanted to do communication to the specific client as well. So for that reason, first I will start my client. My hub is running. I have, for the demo purpose, I have created two clients which are exactly the same, but only for unique identification. I have some different information put, the agent information put here. So I will start my client to 2. I have put a breakpoint to show the status of the connections. So here my connection status, hub connection status should go to connected. Then I'll be able to see the status of the agent and what is the unique identifier that I'm expecting as well. Today my system is running a little slow. Sorry for that. So meanwhile, I'll also run my client 3. Okay, so my client 3 could get connection with the server and it got a unique identity. So which is nothing but 5D. If this is given by SignalR and it could get a registration. So now I will send a broadcast message to my agent, to my all agents. So I should have received a message from the server. Okay, sorry, there was pointer was there, mouse pointer was there. So twice I did a refresh. So notify agent I called, so it got a broadcast message. So third time I'm sending, so it gets a broadcast message. But my client 2, due to some low network, it could not get connected. Let me run it over again. I would remove all the breakpoint just to show the status. I had put these ones. So to a specific client also I can do. So I would do this one. I have a specific client call that need to be done. So just that I'm putting the ID of my unique identifier of the client, and then I'm making a notify agent. So this is not the agent ID which I wanted to communicate. So that's the reason it did not get the notification. So my agent ID 2 is the one which I wanted to communicate. So since it is not up, it was not delivered to the client. So you can send the messages. Going back to the example, you can send a message to a specific client. You can send a message to the group of clients. All this is possible. So going back to the hub, so if I just go to my hub method, so if I see here, if I wanted to do a group, say suppose in my case, I wanted to send by the location. So here I can do clients dot. If you see here, you can do all except. So that means you don't want to send it to some specific clients. You can do that by using all except. Or you wanted to do to a specific client, as I showed here, to using connection ID, we can send it. Or we also have a something called group except. So for the group communication is also possible using the SignalR. So .NET Core SignalR is very cool. Not much of the implementation, if you see here, not much of the implementation that I have done here, but I'm able to communicate with the services which are hosted in Azure and with the services which are in on-premise in an air-gapped environment. That means in a secure environment as well. So going back to the presentation. So this is the requirement that we had. So the SignalR with this requirement, SignalR was the right fit. So SignalR was chosen. Okay. And as I mean, if it is your user choice, you can also alternate to the Redis. You can also use service bus, or if you would like to go for an Azure service bus, you can use that one, or SQL Server you can use. In my case, I am hosting the application using the self-hosted SignalR service. The hub is a self-hosted hub, SignalR hub. The reason is we also have a requirement to run the entire setup in the customer provided cloud. So it could be their own data center where they would like to host us. In that case, we don't want to have a binding with the provider. That's the reason these services connectors, which I have shown here, instances, they are running in Kubernetes. So they are Docker services, containers, basically. And then Redis as an image can run as well. So the Redis was chosen here. And then I would like to also explain the differences. Today we have multiple technologies or multiple solutions available. So it is not so easy to come to a conclusion when we have a requirement which one to choose. So as I mentioned, SignalR is chosen when you wanted to have a real-time communication between the client and the server. So both the way communication should be possible. That's the reason SignalR I choose. So coming to the differences, I tried to give a difference over here with the gRPC. So SignalR works with HTTP, and the advantage part of SignalR is it chooses the right communication protocol based on the environment where it is running. So it can fall back to the server frames as well. But whereas in case of gRPC, it has to be HTTP2 protocol. So wherever you can run HTTP2, so then only you can go for the gRPC based service implementation. And then coming back to the message pack is a protocol that is supported by the SignalR, and gRPC would do a communication with the protobufs. And SignalR can be used where you can have the client and server can initiate the communication. So as I explained, we should be able to do communication both the sides. That's why we choose SignalR. Or you only want to have a communicate, only clients only want to communicate. There is no requirement of a server initiating the communication. Then you can very well go with the gRPC. And in case of SignalR, as I showed in the example, I just have to tell in my interface what is the method that I'm implementing in the hub, and nothing upfront contract I have defined here. But whereas in case of gRPC, you should have the contracts defined in protofiles, and you have to generate if the gateways are Go-based gateways, then you have to generate the gateway files using the pb.go and pbmain.go using the commands. But here there is nothing like that. If the advantage part is if I don't have to generate these files. I wouldn't say this is a disadvantage of the gRPC, but as I mentioned before, based on the requirement here, things are very simplified in SignalR. But people who would like to have the communication HTTP to the fast communication, that is, so then gRPC can be chosen. Otherwise, in case of gRPC, I only see generating these files as an additional overhead that comes. I just would like to explain one small thing. So for that reason, I will go back to my example again. I will run my server locally just to show what happens when I start the server on startup of the server, what it does. So for that reason, a small change I need to do. So if you see here, I'll stop my client so that I will use it. I make my client to point to the local server. To show the hub behavior, I'm running it local so that we just can see in the console more information. So I go back here. Meanwhile, my system is on low resource. Sorry for that. So Okay, so my service, it is, so here the port where it is listening. And then as I mentioned on startup of the service, I have the config hub is my hub name that I have exposed. So now I would start my client. So if you see here, sorry for that, I'll restart my client. I still think that my client is pointing to the server which is hosted in Azure. So this is a unique connection ID. So you might be observing as soon as I start my client, every time I start my client, I'm getting an unique identification for the client. So that way each meter is uniquely identified and we will be able to communicate between the agents. That's about the presentation for the SignalR. So I think I'm ready for the questions.
Cool. Thanks, Renuka. I just got Swami in and Durgesh in as well so that we can track all the questions.
Okay.
Yeah.
Um,
Thanks for the good session, Renuka. That was more of the real world use case you tried to explain, so which is good. Yeah.
Thanks, Swami.
okay, I'm just Is there any interesting question that you saw that I'm not able to see here? Because I see some of them are already answered by Durgesh, so I was just trying to find a question that. Okay,
Yeah.
let's
So
put
one
this
of things. Yeah. Okay. Go ahead.
Okay, that's the feedback.
Feedback.
That's a good
Yeah.
feedback.
So one thing, yeah, where do you install this client? How those are connected with your app is one of the
Okay, so
questions.
the client is a Windows client. So as I mentioned, as I showed in the presentation, the meter is a firmware device, and the head-end system is again a Windows service or Windows software that runs, and the connector is nothing but our SignalR client. It's running on a Windows 8 machine.
Okay.
Okay, there's another question. Can you please clarify how the physical devices such as voltmeter can be interfaced with client SignalR app? Will there be any adapters?
Okay, so in the presentation, I have been saying it as head-end system. So head-end system is the one which understands the communication and talks to the meter. So there is a standard mechanism for the head-end system to communicate. So it is all in the form of commands.
So another question, can you clarify what application types are created in Azure to host the SignalR server app?
Okay, so in the example which I showed now, I have hosted in Azure Web App, but in the product that where we are using, they are hosted in containers with the requirement that we should be able to run in the any cloud space. It could be in the customer environment. So that's the reason they run in a container. In this case, they are in a case.
Cool. Another question, any idea how to implement SignalR with Bluetooth BLE?
Sorry, I'm not aware of this Bluetooth BLE.
Yeah, I can take that if
Okay.
required. Yeah. So yes, SignalR can be integrated. You can think of it as like if you have APIs for Bluetooth BLE. So I'm mostly like related to Xamarin, so I could answer that. Like you could still use the Shiny APIs in order to integrate with SignalR. You may use Bluetooth BLE for the device native capabilities, but still on top of that, if you want to sustain that real-time communication in your apps, then definitely, yeah. So both works like complements each other. Yeah.
Okay. Thanks, Dirgesh.
Great. Another good feedback. This is my colleague John. If you've seen .NET community stand-ups, you would know him. So it's a feedback for Renuka. He says you have a good comparison slide and explanation. So
Okay. Thank you. Thanks, John.
thanks, John, for staying around. All right. So is it lunchtime? What is it like?
I think there is one
Yeah.
last question. I'm not sure if we have taken that on the clarification on the application types that are created in Azure. Have we taken that?
I think we did.
Yeah,
Yes.
that's taken.
Okay,
Yes, we
sorry.
did.
Yep.
No
Yeah.
problem, Durgesh.
Sure. Any other questions? Any other questions from Twitter, if you have it?
Yeah, I'm watching that. So far, so good.
Okay.
I
All
haven't
right.
seen
So
anything.
we should break for lunch then.
Yeah. Yes, I'm on time.
Yeah.
Yeah.
We are
Thank you so much, Renuka. Very
Yeah.
informative
Thank you so
session.
much.
Yeah. And audience, we are going to break for lunch for a while. So it's about 12:30. We'll be back by 1:15. So you can be here in the connected to the live stream. Yeah. So 1:15 you would start with microservices from Nish. That's going to be yet another interesting session. Yeah. So just quickly grab your lunch and then get back. Yeah.
Yeah.
We'll see
And in
you
the
all soon.
yeah. And in the meantime, if you would like to stand a chance to win prizes, do submit your feedback about these sessions at b.net.in/feedback. Right. So go have this quick grab a lunch, fill in your tummy, and we'll see you at 1:15. Yep.
All right.
Yeah.
All right, so I just got notified that I was muted. Is that right? Okay, so let's see. This is the reason why I wanted one of you on the screen. So the thing is, we are right now doing the production, and only I have the producer licenses. So so right now we are not able to have other people in. So is it all good? Just give me a thumbs up. All good now? Perfect. So we'll go back to where we started. So microservices in .NET. My name is Nesh. I work on the .NET team. I'm a PM. I work specifically on the architectural reference guides and cloud native apps. So if you haven't checked this website called .NET/architecture, I encourage you to go check that out, because we have a bunch of resources out there for you to get started with microservices, cloud native. If you're migrating from your existing monolith to modern cloud native apps, or if you have scenarios where you're porting a web forms application to Blazor, you have scenarios where you want to move from WCF to gRPC. There are a bunch of resources out there. We work with a lot of customers, understand how .NET is used in production, and we write these guidances based on those feedbacks. So you have all these things for you to grab it for free. So I will, as part of this, this session, I will show you where to grab all this information, and I'll also show you how to get started with microservices from scratch. Right. So let's get started. What are microservices? Well, microservices, generally referenced as microservices architecture. It states that the app is structured as a collection of smaller services. Most importantly, they focus on a specific business, and they are defined by business boundaries and a bounded context, and they're independently deployable. They are loosely coupled, and most importantly, they are focused by smaller teams, and that is the autonomy you give the microservices get, so that you can iterate quickly. So if there's some business requirement for a particular service to add a feature, they don't have to depend on other services. You can actually ship it to production within no time, so you iterate faster, right? Another thing about resource utilization when it comes to servers is if you look at monolithic applications, generally we have these layers of web, server, there's a UI layer, there's probably a data access layer. They're all actually packaged into a deployable unit, and then they are scaled into the VMs. So whenever you want to scale up, you basically spin up multiple VMs. You probably have a load balancer in front, which is kind of like taking the traffic, looking at the traffic, and diverting those things to particular VMs. But in microservices, because they are really small and they're very focused in nature, they don't have to really understand what VMs it needs to run on, or any of that sort, because they are loosely coupled. So it can be actually scaled across multiple VMs, or when you scale, you can scale it within VM, or it can be scaled across VMs, right? It doesn't, because they are independent. So you get those advantages as well. Now, talking about monolithic applications, is it bad? I mean, this is a common question people ask us, like, should I just convert everything to microservice? So I'm starting new. Should I start with microservices? Absolutely not. Many successful apps that exist today were created as monoliths. So you don't have to move if there is no need for you to move. For example, there are certain criteria where you look at. For example, if you have a larger team and you are able to have smaller teams, focus groups out of it, and if you're able to define boundaries correctly and provide infrastructure for that, then it makes sense. But if you're a smaller team, you want to be having a perfect focus, you still can go with monolith applications. Absolutely no need to migrate. This is not old versus new. This is just an architectural choice that you're making when you're building application. And a lot of people actually start monolith if they're starting small, and eventually migrate to microservices when it is absolutely necessary for their teams to adopt that. All right, talking about microservices architecture, and this is the kind of architecture that you see here is just a reference sample called eShop on Containers. We took the e-commerce application to show as a reference sample because it's easy to understand. That's the only reason, but it could be any application that you want to build. It can adopt this architecture. If you look at this on your right side, you have multiple services: identity microservice, catalog microservice, ordering microservice, right? They're immediately, you can understand, they're defined by a bounded context, and they specifically focus on their scenarios. Now, one thing you probably would have noticed is, like in the previous slide, when I go back, if you look at the monolith world, you probably would split up into modules, and you may still have services which are APIs, but then there is always a bottleneck of relational database. So, for example, if you, in this case, relational database, it could be any other database for example, right? So If you want to change something in, let's say, in catalog as an and if it has relational tables that is referencing, you may have to even update the schema of the other tables too, right? So situations can happen because the dependency is very high, and that is where the bottleneck happens. So you have to really wait for a lot of tests and a lot of integration tests to be completed before you can actually ship this in production. Now, when it comes to when it comes to microservice architecture, you can immediately see the database itself is separated. So every service owns its own database, and that is the key point, and that is what helps us scale, right? So no two applications can actually go and no two services can actually go and reference another databases. It can only communicate with a specific contract or an API endpoint, usually done as a HTTP or gRPC. Or in many cases, there are also asynchronous communications that are preferred. For example, you have an ordering microservice and it has completed one of the order creation, and it can just raise an event saying, okay, order created, and the payment service can actually look at that order based on the event that was published by ordering microservice. So, ordering doesn't have to know that payment needs to do the next thing. The payment just, subscribes to this event and acts accordingly. So that way, you really don't have dependencies on other services. And the way you implement event buses, there are many ways. I mean, RabbitMQ is just one example. In productions, you probably want to use Azure Service Bus, or if when you go to the cloud, you want to use some of the other things. It's again a choice that you can make. And similarly, when you have service-to-service communications, for example, when there is a web client and it needs to connect directly to these services, all these services doesn't have to expose itself outside. It can go through something like an API gateway and implement a backend for front-end pattern, so that only certain APIs are accessible to this client, and the API gateway can kind of decide what services to be called in, and they become the point where you want to control the security as well. For example, simple example is HTTPS, right? You can actually terminate HTTPS at the API gateway itself, so the internal communication between the microservices can be HTTP for faster reasons. And these kind of choices can be made. Another important thing is, like, if you look at the coupon microservice right there, it uses MongoDB, right? Baskets uses a Redis cache. So you also have the technology choice. So if you're a small team, you're focusing on the technology for whatever makes it work for your business, you can also choose the technology as well, right? So there are a number of things out there, and this is all detailed in the book, but I will briefly touch upon a few things today. Talking about what are containers, right? If you look at traditionally how you deploy application is you have a VM, and that's where you package your app and your binaries and host it into the VM. The VM will have a guest OS, and when you want to scale up, you scale up these multiple VMs. Containers, on the other hand, basically have your app binaries and also the operating system dependencies packaged into a small image, which can be run on containers, right? So that way it is loosely coupled, it is immutable in nature. So you can actually ship multiple images if you want to. You can have multiple versions of your services, and make your API gateway make the choice. Do you want to direct it to a new service, or do you want to go back to an older version of the service and other things, right? You get a bunch of advantage with containers. Now, the other important thing is, like, once you package the image, you also save the operating system layer that it depends on. So that way, you really don't have to worry about if your VM has these drivers installed or not. You just package into image. If it works on a dev system, it will work on a test system, integration system, and eventually to the production as well. And that is a great advantage that we have. Now, do we need containers for microservices? Absolutely not. And I mean, this is always debated. Like, whenever people talk about microservices, they talk with containers. The reason is containers definitely gives the benefit of making it smaller, packaging it all together, and it gives you a lot more advantages. And that's why that is spoken together. But you can have microservice architecture. Again, that's a design pattern. You can implement it without containers. And the other way also works. For example, if you have a monolith application and you want to containerize it, you can do that. And a lot of people do that. Like, they start with taking their existing application from their infrastructure, take it to the cloud in a VM, and then eventually containerize it because they want to make use of this Kubernetes and orchestration engine. They kind of package them into containers, but that does not mean that is microservices, right? Microservices is an architectural design pattern, which we'll go into a little bit later. All right. Talking about traditional virtualized environment, this is what I was talking about. There is a hardware host operating system. There's a hypervisor, just it makes the guest OS respond to these apps and other things. And it could literally be like some apps may need some resources. Some apps literally do not need resources. So for example, if you go with a containerized technology, in this case, we're saying Docker engine, but it could be Kubernetes or Kubernetes orchestrator as well. Like, it can kind of decide if I don't need that kind of infrastructure, I can bring my VM down, and it just helps you save a lot of cost. What we see is by 2022, more than 75% of the global organization will be running containerized application in production. What is the reason for that? The main reason for that is the Kubernetes, right? Which is a community-supported open source project. And the big benefit of Kubernetes is vendor neutral, right? Every cloud provider provides its own flavors of it, but then it still is Kubernetes. So it is vendor neutral, so you can scale across the cloud. You can also host it maybe within your hybrid infrastructure, or even in the private cloud for that matter. And it's also used today in production by all these amazing companies like Spotify, SAP, eBay. All these guys use it. So it's a proven technology. And if you're getting started with microservices today, you might as well look at Kubernetes for that matter. All right, so sometimes it may be intimidating to get started with all these things, and that is why we have a bunch of resources to get you started with, and they're all free. Go to this website called .net/architecture, and feel free to grab all the resources out there. They're all free, they're all updated, they're kept relevant. And if you have a feedback on this, I'm the guy. You have to let me know that this is something which we are looking for. We didn't find it here, or there's something we have implemented and we would love to have this in your book. Contact me and I would be happy to take those feedback in. All right. So with that in, I want to focus more on the demos, and depending on the time that we have, I want to build a microservice from scratch, just to show you what are the things that you would use today for building a containerized application using .NET and Docker tools. We'll also explore some of the Visual Studio tools that is available for Docker. I will show you some of the free learning resources. So if you want to get started with Docker and Kubernetes, you can go step by step. Yeah, there are resources where you can just go hands-on within an hour's time. So we have those bunch of resources which are totally free, and I'll show you how to get started with there. And also, which is very exciting, Project Tie, this is from our team, and we want to make easy development of .NET when it comes to microservices. So we want to give you a tool that is more like an orchestrator, but for a developer scenarios than that is going to be used in production. So you will see some of those things. These are preview features, but you can check that out. And we're hitting full gas to add more and more features to the Project Tie, and we will see some of those things in a demo. All right, let's go to the demo. So this is my screen. Number of ways to get started with .NET. The one way that I like it so much now is basically starting with the command line, right? So I can do a .NET new, and these are basically the templates out there. So if you're starting with a console application, you can start with console application. And this is one of the things about .NET, right? It gives you those templates to get you started. So you don't have to write a lot of things from scratch. So in my case, since it's a microservices, let's stick to something like an API. So I'm going to use something .NET new web API. 3 fingers today. Managing too many things at one side. So, all right. So I'm just going to say I want to use something like hello microservice. That's the name of the directory that I want to give. I just want to make sure I'm spelling it right. Hello microservice. All right. So this is going to create this application. And if you look at, basically, it has this hello microservices directory, and we'll navigate into that. And then I can just open this up in Visual Studio Code. So there you go. So I have this program.cs and startup.cs, which will set everything up for me to just run an API. And for this, so it'll ask me, do you want to add C# extensions? Yes, of course. And this will help me, run this application. So if I want to run this, I can go into the run and say, okay, go ahead, run this application. So as it runs, you can see my terminal window. And it just started on one of the other tabs. So here you go. So if you look at localhost 5001, there's absolutely nothing on this page, right? So if I want to see what exactly it has, is basically I have to navigate to weather forecast, because that is the code that it gets defaultly generated. For example, if you go into the controllers, there's a weather forecast controller. Let me push this down a little bit. And it has these basically some random values. So every time you just hit it, it is going to send you some random values and put these things here, right? It's a very simple thing. Now let's add something to this. Now, the first thing I want to add is basically I want to know where exactly this application is running. And for that, I can simply go ahead and magic of, again, ASP.NET with all the dependency injection. I have the logger also there. So I'm just going to say logger.log information. Logging is very useful for microservices, so remember that. So I'm going to say environment.os, I think it's OS version, and I'll just use the version string. So this is basically goes, in this case, it's going to be console. It's going to just log it into the console saying, where am I running this up in the thing, right? So let that be there. And then let's go add something like Swagger. Now, Swagger is basically helps you kind of like, you saw how I was navigating to the weather forecast to know what is the services available. Swagger can add this definition by itself, right? So I can just go and say add the NuGet package, which is responsible for this, swashbuckle dot, I think I'm writing it right, ASP.core, let's see. Okay. The add package, I think. There you go. So it's going to add the swashbuckle. And if you want to see what it did is basically it just goes and adds into the CS project. This is where I can just type this in here, but I just wanted to show you how to do that in .NET tool, CLI. All right, that's done now. So now there are a few other things that I need to take care of. For example, I need to add my dependency injection and also add the middlewares that is necessary to run this. So let's say services.add swagger gen to this, just one line of code. And I'll also just copy another line of code that I already have written it here just to make it easier. So, okay, let me just go and say app.use. Okay, there you go. And one more line of information called UI up and running. And so this is by default, this is the endpoint that it's going to point to where the Swagger is going to show these available APIs for us. But I can just go and say root prefix in this case to be string empty so that, by default, the page that comes up in the Swagger page itself. All right, so then I go back and just say, okay, now run this thing. And it's going to run it again. And again, it opens on the screen. So let me just bring that back and oops. Okay, there you go. So now I have this Swagger. So you can see that by default index.html gives you, and also it gives you like, what are the available APIs for you to work with. So just a few lines of code and we're ready to go. So I'm just going to click on get, and there's something called a stride out, and click on the execute. So this is basically going to give the same things that we saw already with the weather forecast, but the important information that I'm looking for is where exactly is this running, right? So if I go back to VS Code, and if you look at my logs here, so there you go. So it's running on Windows NT 10.0.1904. So it just tells me, okay, this is running. This is a .NET application running on Windows. No big deal, right? Now let's take this to the next level. Let's take this to the Docker. So if I want to containerize this application, all that in VS Code, this is another beautiful tool. Control-Shift-P and say add Docker files to this workspace. As I do it, I want to show you the Solution Explorer. So add Docker files to the workspace. It'll ask you what platform this is. Obviously, there's a .NET code, so you just say .NET. And you can choose if you want to build a Windows container or a Linux container. In my case, I'm interested in the Linux container. Does it require Docker Compose files? Not required, because we may use Kubernetes for orchestrations. So I'll just remove that, and it'll ask me for the default ports. That's it. What it does is it basically goes ahead and adds this Docker file to our application, which is pretty cool, right? All that it needs is basically, okay, what is my underlying image that I need to rely on? In this case, I'm using the .NET 5 preview, so it's using the ASP.NET 5.0. And it also, we can also bring in the SDK so that we can copy all these files from the local, put it into the Docker container, compile it right there, and then publish it. So the advantage that you get is basically you have this entry point, and your app will be called whenever you want to run the service. You're basically going to call .NET hello microservice.dll, and it's going to bring up your application. That's it, right? So in Visual Studio Code, I can just go ahead and instead of choosing the .NET Core launch now, I want to run on Docker. So I'm just going to say docker.NET Core launch. And here's another beautiful thing about VS Code is that, or if you're using Visual Studio, you can actually debug these things directly. So I can just put a breakpoint here, or maybe here, and then run this, right? So let's run this. While that is running, I'll quickly. Okay. So I keep getting this UI onto the side, so that's okay. Get weather forecast, try it out, click on execute, and you see that my VS Code is saying, oh, hey, you need to debug this. So now if you look at the version string, and as I go into the details, it's basically Unix 4.19.104. So basically, we just took a .NET app, containerized it, and now it's all running on Linux. This is the beauty, right? .NET works everywhere. So you can go ahead and debug this. That's good enough for me now. So now let's take this to the next world, which is the Kubernetes. Now that you have created this Docker, you have these images ready, you want to go and publish this. So for example, in my case, since I was running Visual Studio, it probably would have created something like a dev tag for it to run. But if I want to compile this myself into a Docker image, I can just go ahead and use this Docker build. My mouse, get me back my mouse. Okay, build the context set where it is, and then where the Docker file is, and then provide the tag. And I can just say hello microservice, and I can say this is my latest version. So this is what I want to publish it. So I want to rebuild it. So now I can see that it just goes ahead and does the same thing what VS Code was doing, but now I'm actually compiling as the latest tag, not the dev tag. So now I have the image ready. Now, how do I let this go into the Kubernetes world, which is the orchestrator, right? To do that, you need something called as container registry. Now, predominantly, if you want to build and deploy applications in VMs, you probably have a FTP site open. You will copy those files into that, or you will have a VM site open and you will install something into that. But now, when it comes to Kubernetes and things, it needs some place to pull the image. Now that it's packaged into image, it's immutable, and it's just going to work the same way how it works everywhere else, right? So for that, what you need to do is there's one more step that you need to do is basically you have to go and tag it with your, I'm not typing this correctly, but you basically say your I think it's this latest, and then say, what do I want to tag it as? Now I'm using niche UNL, and I can call this as anything. The idea about this one is this is your container registry. So by default, if you just give your username, it basically provides you, it thinks, it assumes that you are using the Docker Hub. So in my case, I have this thing already on my Docker Hub because I pushed this earlier. So if I go back to the hub.docker.com, this is my login, and this is the username that is needed for container registry. So I have these things. So I have these hello microservices, which was published around 4 days ago. It's pretty much the same code that you saw right now. And I can technically pull this image. So it's already there in the container registry. So I just need to make a pull. So now I need Kubernetes, right? So I have Kubernetes running on my machine. So I'm using this Docker, and this is beautiful in DOS. And just going to pick Docker. So a lot of people can use are using Minikube, which is good, but I'm just going to use Kubernetes that came with the Docker. It just works, and it also uses WSL2. I mean, if you used Docker in the past, you probably have to go and set the VM. Like, I want 4 gigs and I need so much of resources, and I think that's all gone with WSL, because now WSL2 in Windows, there's a Linux baked in, the kernel baked in. So basically, when you say WSL2, it's going to use the same kernel and it's going to run on it. So that's the beauty. So I love that. And because I have that, all that I need to do is I say kubectl and get pods. Right now, I'm just going to see what are the so the context is set to basically the Docker desktop, and I'm just seeing what are the things this is running. These are for my later demos, so I'm just going to leave it there. There's absolutely no hello microservice running. That's what I want to show you. So I want to run that, right? I want to deploy that. So I need to provide a deployment file for it. So I go back to my Visual Studio Code, and I'm going to create a new file called deploy.yaml. You can call this anything. In production, you may not be doing this way. You probably will have a YAML scripted into some kind of DevOps, or you may use Helm for that matter. So, but just let's keep it simple for learning purposes, right? So I have this config file already, so I'm going to just go and paste that here. So basically, it just says, hey, Kubernetes, we have a deployment that needs to be taken care of. And the important thing about this thing is you need to get this image from this hello microservice latest, and that's what we needed, right? So it has nothing to do with the code here. It basically is just referencing the container registry, and it's just pulling that image from there. And the good thing about environment files is, like, there are some convention that you need to follow, but you can actually send in all these configuration settings as well. This is for your .NET application to pick it up and start working on. For example, I'm setting the environment variable. So if you don't just give development, it's going to run it on production. So I'm just reconfiguring it so that I get more log information and other things, right? So I have this deployment file. This is good enough for me. Now look at this. What I'm going to do is Control-Shift-P again. And this time I'm saying Kubernetes. And I'm going to say, okay, go and create this cluster for me. And I say create. So this goes and actually goes in, looks at this and says, okay, this microservice is created. Now let's go back to the Kubernetes and just go to kubectl get service. There you go. There's a hello microservice running, and this is of type load balancer. This is again for local testing purpose. So load balancer is the type that you use so that if you want an IP that can be accessed from outside, right? So in this case, so right now, if you just go in and say kubectl and get pods, just to make sure the pods are running. There you go. So the hello microservice is running. Remember, we just set the port as 80. So now if I just go into my hello microservice here, localhost, and do not, battery fingers, localhost, and no 5107, and there you go. So it's the same app. It just pulled in and it's running right inside the Kubernetes, right? So now we can just go and say try it out and say click execute. Now, if I go back to my Kubernetes, I just want to look at the log file, right? Because I compile it on Unix, I want to make sure that is what it's running on. So I can just say kubectl and logs of, I just want to get the logs of this hello microservice. I'm just going to copy this pod and put that in. And you can see that when it was running, it also runs on the same image that we copied in. And this is the beauty of this, right? So whatever you compile in, all the operating system dependencies, they're all going and deployed into Kubernetes. Pretty good. All right. Just quick check on the time. Okay. So we just took this and uploaded into Kubernetes, but let me show you some resources to get you started. So for example, if you're starting for the first time, you didn't figure this thing out yourself, you want to get started from scratch, there are great resources. For example, you can just go to this site called .NET. That's what you need. And once you go there, you will have this section called Microservices. Click on that. And the moment you go into the microservices, it will obviously tell you a lot of things. There are some videos that you can try, check it out with Docker. But I want you to try this out because it's called Get Started. If you go there, now this will guide you through the entire process of, maybe you're starting with .NET for the first time, right? Installing the .NET, creating the service, all that I showed you right now, this is all baked in. So you can choose if you're working on Mac OS, there are steps for Mac OS, Linux. And by end of it, you also have the step called, deploy to Azure. So if you, right now, what I did is I took the deployment and deployed directly to the Kubernetes that is running locally, but you can go ahead and deploy to any Kubernetes. So in this case, AKS. So if you want to go and build it for AKS, what is the Azure resources that you're going to do? There are a few steps that you want to, and everything is in command line. So you can just get started with that, right? Now, this is all getting started, and this is the easy part about microservices. In reality, microservices are much complex than that, and that's why you probably need more documentation, more context, and more understanding of how this needs to be done. So if you go to the same site .NET, and then there's this tab called Architecture, and this is what I PM on. And so I'm very proud of these documents out there. That's really amazing content that you should check out. So here you can get started with microservices, right? So there are a bunch of books that you can start downloading and read right away, or you can just go to microservices. And then if you want to see how this is done in production, you want a production scale application, get started with something called Z-Shop on containers, right? Explore the sample on GitHub. Basically, it takes you to this .NET architecture repo. And you can look at this. This is the entire code out here. Now, this is a microservices reference application. It's a very fairly simple application. I'll just execute this and show you right now. But the important aspect of this is, they all are independent services. Now, a lot of people argue that it is an anti-pattern to have a single repository for a microservice and putting all the microservices together. We do that for the reason that it becomes easy for you to get started. But the CI and CD pipelines for each individual microservices is different, and that is possible because Azure DevOps gives you the trigger. Like if you just go and change code in one of those subdirectories, I can just execute that pipeline. So that's how we have done it. So it's still multiple microservices running. Okay. So let's what you do is basically you can go to this site and just click on code and then say clone this locally. Once you have that locally, let's go shift gears now. So this is my eShop and containers. If I just list all the things here, you'll see something called a source code. If I navigate to the source code, and you will have a lot of things. So let me open that again in Visual Studio Code. There you go. None of this is important right now. We don't have to look at all of these things because it's complex for a reason, because your microservices, they're split into multiple business functionalities, and they work with each other either through a service endpoints or the MQ. So we have so many things out there. Now, if you go into services, this is where all the stuffs are there. All the services are there. So I'll just ignore this. What I generally do is I will go and look at the code that is most relevant for me. In my case, I want to first run this. So all that I need to do is, as long as Docker is running, you just take care of writing this command correctly, docker-compose, and say up. And this is going to create all the images out there. So remember, all these images were compiled earlier. So you can do a Docker build to compile everything, Docker compose build. It'll go and build everything for you. But in this case, I'm just saying up. So basically, it's going to run this application. And right now, you can see that there are a bunch of microservices here, and they're all logging all this information, and that's what is coming into the terminal. The first thing that you want to do right now, once it is run, is not basically go to the main site, but look at something like 5107 port. This is where we implement health check. And this is a key feature when it comes to microservices. Because there are multiple services, you need to know if that service is healthy so that you can drive traffic to that, right? So we implement health check. And .NET has this built-in feature for adding health checks. And we also use this NuGet package called ASP.NET Core Diagnostics Health Check, which actually adds beautiful UI, and it also gives you those checks that you can do. For example, your service has some dependency like a database or Mongo. So if you want to connect to Mongo and see if that dependency is working fine, you can write those health checks. So if you use this NuGet package, it's already written for you, so you just add it and then this works. Now, the other thing about health check is there is an important aspect in Kubernetes called liveness and readiness probes. What liveness probe does is basically Kubernetes is going to ping your application time to time. You basically write that in your configuration saying this is my URL to ping, and Kubernetes goes and pings every few seconds to see if you are good. And for some reason, if you don't send a status code, which is successful status code like 200, it will go ahead and restart your service. And that's what Kubernetes is good for, because you don't have to, you don't have a human to go and look for these things. It will, as long as your service is good, it will do nothing. But for some reason, you're not able to send status code 200, it can be crash, it can be hang, it'll go and restart this service for you. So that's why it's important to specify that. Now, there's another probe called readiness probe. Which is what you would generally use if you want to go and deploy. If you want Kubernetes to drive traffic to that, right? So you may be healthy, but then you also want the dependencies to come up. So your readiness probe can actually say, okay, don't send traffic now. So until you say true, the Kubernetes will not drive traffic to. So this is why these health checks are important. We have this nice UI dashboard. So if you look at Basket, it all depends on a Redis. So it also makes those checks and everything. So this is all baked into .NET, and these NuGet packages help you do that. So once you do that, basically you can go to 5100, and then this is a simple app. You click on login. This is a very advanced e-commerce application, so you don't have to register for any username and password because we just give it to you right away. So you just have to make sure copy and pasting. We are all developers. We are good at these things. So you just have to go ahead and do that. Click and log in. So now I have the add to cart. I go to the cart, check out, and place order. And there you go. So all good. It just makes sense. It's really fairly simple, right? Why do we have such a complex code? The reason exists because in microservices, we split them. And the idea is individual teams take care of the services. And that's why that complexity exists. And we use a bunch of patterns like CQRS, DDD, and other things. So go check them out. There are a lot of things that is explained in the wiki. But by the way, if you want to do hands-on this, if you go to this site, eShop on Containers, there is something which say, hey, are you new to microservice and cloud native development? Just go click on this thing. So there is this beautiful MS Learn module out there where it will give you step-by-step guidance on how to build microservices, right? So in this case, for example, what we do is we looked at how easy can we make to help you build microservices. So we took a scenario. Let's say you are for the first time getting into a company where there is already microservice architecture, and your job is to add a new functionality. That's a perfect example of to learn microservices, right? So we do that. So we explain the solution architectures and other things, but the task that you have in your hand right now here is basically, let me see if I can find that thing. Yeah, basically go ahead and add this discount code into the existing production app. So that's the code that you do. Now, the good thing about MS Learn is the way we have architected this is all running inside of, let me go to the right link, running inside of Azure. So you don't have to set up anything locally. If you have an iPad, for example, have a browser, just go to the browser, have an Azure subscription. And if you don't have it, we also tell you how to get the free subscription. Just sign up for that. And you can literally use, it doesn't cost much to just start with it. You can try this out yourself. And everything is being deployed in AKS. And you'll also, instead of Docker Hub, you'll be using Azure Container Registry as well. So how do you secure your images as well? So those aspects are covered here. So it's just very straightforward. So I'll share these links at the end of it, or I'll share it with the community who will be sharing all these links with you later. Okay, I think we don't have enough time right now. Let's see, quick time check. Okay, we have only 5 minutes. Let's go and try Thai. 5 minutes is not good enough for Thai, but anyway. So you saw this how it becomes extremely difficult when you work around with microservices. But wouldn't it be nice if, as a .NET developer, if you can just run all these things together without really worrying about containers and other things? So that's what Thai does, right? So for example, if you look at this directory, I have this. Let me maximize this. So I have this backend and front end. Generally, typically how you write these services. So you have a front end, you have a backend. So if you want to go and run this application, you go to CD backend and .NET run, and it is going to run the backend. And if you go to front end, so let's go to front end. Let's see, and then add .NET run. And there you go. You have the backend and the front end running. So you have this port running on 5901. You have this port running on 5903. So this is my front end. This is where I want to see. So if I just Control C and go into my browser, look on it. Oh, there's an error. What is that error? So it says it is trying to reach weather forecast, but it's not available. And the reason for that is basically you have written hard-coded a wrong string into it, right? So let me go fix that. Let me go back to the terminal. Let's go fix that. So if I just go one step up and do code dot, and basically, if I go into the front end, and if you look at my modified file, okay, I was supposed to not use this, but this was a hard-coded string that was supposed to be lying there. But I wanted to show you Thai. So what Thai does is basically, if you just simply, you don't have to do this .NET run multiple times. And instead, if you're on the main folder, you can actually say Thai run. And this will go into your solution, and it will go detect all these projects that's available to you right now, and it is going to, give you a dashboard where you can just see what are the services out there. So I'm going to go and hit on these services. There you go. So it will tell you that I have a front end, I have a back end. In my case, I even have a zipkin running because I have a Thai.yaml, which I forgot to clear it, but that's okay. But we don't have time either. So so let me show you. If you do a Thai run, what happens is it just runs your services. But since I have this, this is not the code. Since I have this YAML file, basically you just go and say Thai init, and then it's going to create this YAML file. What I did is I went ahead and added one more thing called Zipkin, and Zipkin is a nice thing for distributed tracing, like tracing those things. So once you add this extension, what it does is basically it goes in and adds the services front end, back end, and now you see Zipkin is not installed in my system, so it detects, all right, let me give you a container. So as long as your Docker is running, it is just going to pull in the Docker container, and it is going to host it for you. So now if you just go into this thing, so this is basically the same thing, weather forecast. It just has a nice UI. So if you keep refreshing, it just refreshes all these things. It's connecting the backend. And because we have this beautiful code out here, it does the service discovery automatically. Apologies for that. I should have just rolled back these things when I was testing this. Let me show you that code quickly. Startup. Okay, this is the thing. So if you just go and say configuration.get service URI, it is going to look up what is that name that you're given for your service backend. It will pull the port automatically. If you look at the dashboard, it basically gives you this port, looks at your system and automatically assigns this port. So you don't have to really worry about this port at all, right? So you can also look at the view logs and that kind of things. Pretty good, pretty awesome. You should give it a try. So talking about Zipkin as well. So one quick thing. I only have 2 minutes. Just want to be sure. Going back to Zipkin. So since I enabled Zipkin, what it's oops. Something is messed up. Let me see if I okay. Let me stop this. I don't know what exactly happened there, but Docker PS. So, okay, we have the Zipkin running. We're good with that. So this should actually work. I don't know why it's not working, but I don't have time to debug that either. So I'll just leave it for that for now. But I would encourage you to check the sample out here. So if you go to github.com/net/Ty, you can see there are a bunch of samples inside these docs. There are recipes. Within recipes, you have these recipes of how do you start with Zipkin, and over here you have this, like, what are the YAML file configuration that is needed for it, right? Okay. And if you are working, okay, this is the markdown file. So this is the one which is the Zipkin. The important aspect is we support OpenAPI tracing, open telemetry. So you need to enable this so that in the tracing is seen. So once it is running, you basically, what you're going to see is basically you're going to see this back end and front end. How is it? How much time it's taking? All those things are just with the one line of code. It's all enabled for you. All right. So on time, so we can look at questions now. I'm going to bring in more people. Swami.
Anish.
Yes.
Yeah, so we tried to answer a few of the questions of the chat itself. And I know we're running out of time. It's already 2 o'clock and we need to get started with the next one. So can we have them answer during our AMA session too, if that's okay?
Yeah. I'll be around for the AMA session, and you can just shoot in any questions. Sure. So if you want to see any other samples, how do you do gRPC or something like that, I can go ahead and do, because microservices, it's never enough time to complete it. All right.
45 too late.
I feel bad that I was not demoed properly. Anyway, I'll send you some other session links where you can just give this a try. So we're going to bring in Amresh here.
Right.
And
so for the audience, please keep your questions posted in the comment section. Nish could answer there. Otherwise, we'll definitely pick it up after the DAPR session. We're going to have a dedicated 30 minutes to answer all the queries. Yeah.
Yeah. Oops. Sorry. Oops. Thank you so much. Over to you, Amrish.
Sure, Nish. Good afternoon. Thank you for staying for the session. And first of all, I also want to thank Nish for setting up the foundation for this session, right? So because this session is more like a follow-up of the previous session, like where we want to learn more about microservices and how can we build the distributed systems. So I'm going to talk about a DAPR. It's DAPR, and it stands for Distributed Application Runtime. So DAPR is again open source. It's a portable, and it's called runtime for writing distributed systems on cloud. And you can also use DAPR on your virtual machines. So yeah, in previous session, like Nish was talking about what are microservices and how can we develop one and all that stuff, right? So I don't want to spend time on that. What I want to quickly do is, so what is happening in the current world? Like people have started writing microservices and it has become like a mainstream for the development. And I also want to take and share my personal experience, right? So in my team, we are having a project where we want to kind of migrate it into microservice. And the moment we started splitting this monolith into microservices, right, there are so much of questions that is coming up from the team. Like for example, where do I need to store my images? I also saw some of the people posting the same questions, right? So similar questions comes in every team, right? So we have to kind of have a registry, and sometimes I have to go and manage the configs, and sometimes I have to go and manage the secrets. So these are some of the questions that is coming for the developers, right? And whatnot. So we have other teams, and we have got architects, managers, and they come back and ask like, what will happen to the security of your application? So you are telling your application is going to be a distributed system. What will happen to the security? And how will you measure the performance of your application? So these are some of the questions that we all get, right? And as a developer and as an architect, if you go back and try to kind of put a checklist against all of these things, and if you start writing some of the tools, there are so much of tools and so much of features that is available to solve almost all of these problems. But what has also happened is when you kind of started analyzing what is the feature sets available and all that, what you come to know and what you come to realize is there are so much features are out there. And what has happened is some of these features, some of these tooling systems, right? It is so kind of got some tight coupling with the language of your choice. For example, I'm a Shisha developer and I want to use something some of the features that I want to use from Cassandra. It is definitely possible, but I have to go back and learn the SDKs. What do they provide? And what has also happened is with so much of features and so much of frameworks available right now, it is kind of totally coupled with the environment that you are going to run your system. So what I mean is today I'm going to kind of have a monolith. I want to kind of break it into microservice. I kind of host it in a cloud or in a managed Kubernetes system. Some of the decisions, some of the choices of the tools that I have to take kind of depends on the final state where I want to run, right? So even before I kind of develop, even before I think of writing a microservices, I have to kind of understand the complete infrastructure where my service is going to run, right? So that as a developer, what happens now, right? So my primary aim of all of the developers is to go and solve the business problem, right? We all here we are writing code to solve the business need, right? And what happened is kindly we have to understand what is the kind of tooling system we need to have, what kind of system that we need to run, what kind of configuration we need to use. So what happens is for the developer, right, all these kind of thoughts is kind of become so much on the developers to even focus on writing the business code. And out of all of that, right, we also have some of the existing code, and we want to port this code into our system, right? So I want to use some of the features that I've developed in my current code. So these are some of these are very hard problems to solve, right? So starting is very easy, but if you think of microservice running it at a scale in a cloud environment, it becomes really, really difficult if you have to understand all these problems in depth, right? And we have also done, so there are so many companies which have done like microservices, and what's been given like a prescription, I would say, right? So when you even think of writing a microservice or a distributed system, so you should go and understand like what are the building blocks of my system. So like, similarly, if you're writing a monolith app, you don't really care about where is my application is going to run. So it is pretty much, if it is an web API, you could probably go ahead and host it in IaaS, right? But if it is becoming like a system which is a distributed system, and if you want to deploy it in say in a Kubernetes, right? So you need to understand some of these concepts out there. I could probably again explain with an example, right? Somebody asked in the YouTube channel, right? So how can I call one service into another? So like in the example that we just saw, like in e-commerce application, right? Let's say I have an order application, order microservice, and I also have payment microservice, right? And order microservice needs to call payment microservice for me to complete any order. And assume this order microservice and payment microservice, if it is like a system which is like a service which is going to run in my local system, I could definitely call using localhost using HTTP. But what if it is going to run in a container in a managed Kubernetes system, right? So what happens then? Right, so my order system will be somewhere running in some pod, and my payment service will be running in a different pod. I don't even know the endpoint of the payment service. Then what is the way like my order service can talk to the payment system, right? So these are some of the challenges that we have, and we definitely have tools to solve these kind of challenges at this moment, right? We have got something like Console, Eureka to do the service discovery. So all that tools are available. What happens is, as a developer, I need to understand what are those tool sets are, and if it is definitely going to solve my need, and how is it going to come and work together in the final state. Like after I deploy my application, how is it all going to come together? So these are some of the difficulties and the functional problems that we have, right? And another thing Nish also touched upon, like distributed tracing. So what is tracing mean? Like logging and tracing is really an important aspect of a distributed system. So assume you have a monolith application, you know all your logs is going to come into one place, and you can always integrate with some tools like Splunk, Grafana, and you can have a view. But imagine if your application is going to kind of be like a microservice, like a application is going to run in Kubernetes. What is going to happen, right? So there are different instances of your application running in Kubernetes, and you also need to know when any request is coming into your application, how is this request getting tied to each of the services? Like if I kind of submit an order, it first goes to the order service talks to payment service, payments internally talks to inventory, and so on, right? So you need to know a mechanism. How can I go and trace back these orders, right? Because the problems are definitely can happen in a microservice environment, and if that happens, you need to have a way to go back and check how can I go and address that, right? So you should be able to kind of quickly go and trace it. And some of the other mechanisms where microservice can talk to each other is something called pub sub model, right? So I have my publisher and I have my subscriber. I want to publish a message, and I have kind of set of microservices or a set of systems running in the background who want to subscribe to that message and act on it. And again, secret management, right? So I have my microservice and I've got my connection strings. I cannot just have it as an open in web.config. I should have something like a secret management who can provide these kind of feature sets to me. So all of these are kind of building blocks to write a microservice, and we need to know, understand what is the tooling system that we are planning to use, even before we kind of think of writing a microservice, right? So this is not easy problems, right? So this is where the developers on the current state are. So being a developer, I myself need to understand all of these systems, all of these tools, and kind of have my answers ready, and also understand, do some proof of concepts to kind of understand how this all works. So this is the current state, right? So now DAPR is here. So first I want to talk about some of the issues that we have currently, so that when we kind of complete this demo, we will be able to be appreciative of some of the tools like DAPR that is coming into the world now. Right. So DAPR is called distributed application runtime, and it is going to solve, or it is going to help us solve some of the problems that we have seen in the previous slide. Whatever we saw it, like these distributed tracing, secret, and whatever be it, right? So DAPR is going to give us a mechanism through which we can kind of solve the complexities that we have for the developers in today's world. And these are some of the goals of DAPR that you could see. And one of the prime features are actually the right extreme, right? So which is called pluggable architecture. So it's more like a component. Again, I will explain with you an example so that we understand it better, right? So assume like today, I'm starting my development in my team. We are going to write a microservice, and we are starting development right now. And during my development, say I want to use some database, right? So we all use database, and say if I want to use Redis as my database. So Redis is a key value pair database, right? So I want to use Redis as my database during development. And tomorrow when my application is ready to go to production, right? If I want to deploy it in Azure, and say if I want to use Cosmos DB, right? In current world, what we will have to end up doing is, as a developer, I need to understand what is the Redis extension for C# and consume it in my application. And tomorrow, if I have to kind of use Cosmos DB, I have to go and understand what is the Azure Cosmos DB SDK is going to provide, make code changes in my application. So that is important, right? So I have to go and make a code change so that my application today, which is going to talk to Redis, can talk to Cosmos DB tomorrow when it is ready for production. But this is a pretty normal use case, right? We all face, right? Because I don't want to pay for Cosmos DB when I'm kind of doing my development. I want to use something which is free, something which can run in my local. And once I'm ready for production, I just want to go and deploy. So this is a pretty simple use case. But unfortunately, at this point of time, we don't have a component or tool which can kind of provide me this plug and play kind of a thing. So what DAPR is going to do is, which we will of course see in the demo today, what is going to do is I will be using Redis as my development. And once I'm ready, what I can do is I will just plug out my Redis, like I will just plug the Redis component out, and I'm going to bring Cosmos DB with no code changes to my application. It is just going to look like a magic, and it's just going to use the Cosmos DB, and all my data is going to be going into the Cosmos DB. So that is a beauty part of DAPR, right? And what has also happened is DAPR is kind of adopted to the open standards, which is called Open Application Model. OAM. So you could search for Open Application Model. So it's more like a specifications or standard given by the multiple cloud providers, so that your application is kind of becoming agnostic to any of the cloud providers that you may take. So DAPR by nature is kind of adapted to it. So DAPR can run in say any of the cloud systems that we have today. And the best feature of DAPR is it is going to integrate with our application through HTTP or gRPC. So there is no SDKs required for DAPR. And of course, there are SDKs part, but that is something that the community has developed. But DAPR by itself can run with just HTTP and gRPC. So what it means is, if your application is going to talk HTTP or gRPC, you are open to use DAPR today. So that is the best feature of DAPR, I would say. And the next slide, this is more like a representation of what DAPR is. And you see the center part, right? So the center part, if this is already been talked. So this is about the DAPR and how DAPR is going to provide an abstraction for all the microservices building blocks that we have seen so far. And when I say abstraction, what it's going to do is in DAPR, I will go and say, today I want to use Redis, and DAPR is going to understand that. And tomorrow, when I say I want to use Cosmos DB, I just want to go to DAPR and say I want to use Cosmos DB. So all my kind of components, all my kind of interaction, I will let DAPR know. And what DAPR has done is given an abstraction, basically an API on top of all these problems that we have seen so far. And it is going to give an interface by means of HTTP and gRPC. And at the top, you see the application code, right? So since I've already told, it could easily relate to any application which is going to talk HTTP or gRPC, you can go and use DAPR. And at the bottom part, you see like it can run on any cloud and on any of the infrastructure that you have, because it is actually adhering to the open application model, right? So open telemetry and all that stuff. So DAPR can run in Azure, it can run in AWS, it can run in Alibaba and whatnot. And it doesn't mean that DAPR can only run in any cloud system, right? So currently what has also happened is in our company itself, right, we have got so much of a virtual machine, so much of data center out there. And what if I want to kind of run DAPR out there? It is definitely possible, right? So if you have got a bare metal virtual machine, you could go and host DAPR in there. It doesn't mean that DAPR should run only in a cloud managed system. It could definitely run on your virtual machine, where you can go and run the DAPR runtime, right? So all that is possible. So once that is done, DAPR is going to kind of provide an abstraction to all the building blocks that we have seen, and you can consume the DAPR runtime. So yeah, I also want to talk a bit of architecture, so then we can go into the demo part, if that makes sense, right? So DAPR, as I said, right, it can run on bare metal, like on a virtual machine, and it can also run on a Kubernetes managed Kubernetes system like AKS, right? And this is about the architecture or representation of DAPR itself. And it is called self-hosted because when DAPR is going to run in, say, in bare metal on a virtual machine, we call it as self-hosted. And when DAPR is kind of hosted in a Kubernetes system, we call it as a Kubernetes hosted architecture. So first I will talk about the self-hosted. And I think DAPR basically uses something called sidecar architecture, right? So people who are new to the sidecar, maybe I can give an analogy, right? So this entire sidecar architecture basically came from the motor world, right? So I've got my motor scooter, and I'm like a developer. You can imagine like you are a developer who is going to ride a scooter. And in previous days, what we also used to have is there is something called sidecar that is attached to my scooter. Basically, if you remember, like in Bajaj, in India, the Bajaj scooter is so famous, right? Which used to have a sidecar attached to it, and that it could carry so much of goods to it, or even a person can come and sit along with that, right? So that is a similar analogy. And if you have to drive it back to my system, you could think like application, the gray blocks that you see in this diagram, right? It is more like an application code, and DAPR is a sidecar to it. And application code is more controlled by the developer. So I'm going to write all my business logic into my application code, and DAPR, which is like a process that is kind of attached to my sidecar, it is going to manage all of these things what we just saw, like be it a bindings, be it a state store, be it a pubsub model, right? Whatever we have seen, like so far as some of the complexities in developing application, DAPR is going to manage that for us. And this is called sidecar architecture, right? So when we say sidecar, you have your application code and you have DAPR also running alongside as a process with each of your application. And when I want to kind of save some data, it is as simple as, hey, DAPR, this is the data that I want to save. For example, let's take, I want to save some feedback form, right? I have a form in my application code and I want to save it in, say, a Redis database, right? I will just say, hey, DAPR, please go and save this through HTTP or through gRPC. That is as simple as that, right? And again, if my application, like if my business logic wants to talk to a different code, like different component, which is called service code B, all these communications can happen through DAPR sidecar. And if you see, DAPR sidecar is internally also connected through mutual TLS, and that way it is also secured. My security is kind of inherently taken care by DAPR itself, right? And at the top and bottom, you see there are so much of tools out there, right? You see like something like Cosmos, Redis, Cassandra. So those are nothing but my database systems like key value pairs, and there are so much of expanding now. Dapper is by default, it is already, when we talk or when we speak today, it is going to have all these kind of state stores and features available as abstracted as part of Dapper APIs, and it is definitely expanding, right? And in case of observabilities, like Nish was showing, like Zipkin, like earlier, probably Nish would have used the Zipkin SDKs or to integrate with the application, right? And with Dapper, all that is kind of solved. We'll see if we kind of have time, we will go over that too. And this is again a high level representation. Like my application code is going to be there, and it is going to use HTTP or gRPC to call Dapper. Internally, Dapper is going to manage whatever I want to do, like be it state management to whatever be it, like we just saw, right? So this is more like a high level representation of what Dapper looks like in a self-hosted mode. And Dapper definitely can run in Kubernetes too. And maybe I can split this up, split this diagram into two parts, right? So if you focus on the left side part, at the bottom you see there is something called pod, and you also see a container and also Dapper sidecar. So this is nothing different. So in the previous mode, if you are running in your virtual machine, you will just not have this Kubernetes and you will just not have this pod. But if you want to host Dapper in a Kubernetes mode, it is going to run your application by default. It's going to run inside a Kubernetes pod. And next to your application, we will have Dapper Sidecar, which is going to do the same thing like what we saw earlier. Like if I want to save in Cosmos DB, my application is going to talk to Dapper, say Dapper slash save slash my payload, and Dapper internal is going to talk to Cosmos DB and it's going to save. And later, if I say I want to kind of bring down Cosmos DB and use Redis, I just want to tell Dapper, I just want to kind of put Redis component into my cluster, then no changes to my code. Dapper, it is kind of inherently understood that now Redis component has come, so I will go and use Redis and save the state into Redis. This is at high level. And at the top, when it is running in Kubernetes, you also see like 4 different containers being injected into our runtime, like actor, sidecar, sentry, and operator. So these 4 containers are called something like Dapper runtime. And I will go, and when we show the demo, I will kind of explain what these sidecars are and what's their job is, right? So we will see over that time. And this is again a high level representation of how the Dapper looks in a hosting model when it is hosted in a Kubernetes mode. Only difference that you could see from the previous slides to this is it is just going to run inside one pod, right? And there could be multiple instances of your application, and each of that application will also have a sidecar brought up. When you kind of bring your application, even this sidecar will also come up, and it is going to abstract whatever functionalities that my application needs. Right. And so far we have discussed about the architecture part and how Dapper is going to solve some of the problems. And before we get into the demo, just want to kind of spend a couple of minutes on this slide as well, right? So there are basically three components is what we need to understand Dapper. One is API. So API, we know that Dapper is going to abstract what is my state store, what is my secret, what is my tracing. So that is one part where API is basically, if you see, API is going to contain one or more components to it. And what are components, right? If I have to define components, maybe if I say like I want to use a Redis database today, I will go and create a Redis component. So that is one of the component. And if I say if I have to use Cosmos DB, I will go and create a Cosmos DB as a component. Again, that is called a component. And for each of those building blocks that you see, you can go and create a component for that to be used by Dapper. So these are the primary 2 things, like API and component. These are the 2 things that you need to know. And at the bottom, you see there is something called configuration policies. It's more like advanced concept for Dapper, right? Like if you want to understand how Dapper is going to kind of put telemetry across all your Dapper containers, and how can you kind of configure your pipeline, how can you do change the pipeline which the Dapper workflow works, you could focus on that. Maybe that is not part of the demo today, but we will definitely talk about API and what are components too. And this is demo time. Interesting. So Nish also showed about Docker for desktop, right? So in my machine is Windows 10 machine, and I'm using Docker for desktop. So Docker for desktop is available for Windows 10. I think it got launched somewhere in March time. So if you have not explored, you can go for just Google it for Docker for desktop, and you can install it. And the beauty of Docker for desktop is it is going to give you the managed Kubernetes cluster, like your local machine. It is going to bring up for you for all your learning and troubleshooting stuffs. So I'm going to use this. And what I've also done is I've also enabled WSL for Linux, basically my Windows 10 machine. But I've also, what the command prompt that you see is now, right now it's called WSL, like Windows Subsystem for Linux. And I've got Ubuntu running in my Windows machine. So this is the environment that we are going to see. And what I've also done is, you see 4 tabs there. So let's not think about these other rest of the 3 tabs. Let's just see about the first blue color tab right now, and then we will definitely go into the rest of the tabs during the further part of the demo. So to install DAPR, DAPR needs a DAPR CLI, like what we have CLI for .NET, we have CLI for Azure. Similarly, we have CLI for DAPR. And quick, it's like how do I install DAPR CLI? So there is a quick command here. So if you see, you just do that Windows Gate, and then there is a URL that is available right there in the DAPR website. You can go and grab it, and once you're done, DAPR CLI is installed. So it is going to kind of install the DAPR command line, so you can use DAPR commands in your WSL. Right, so I have already installed DAPR CLI, so DAPR is already available in my machine. So once DAPR CLI is installed, I can go and check if my DAPR status is healthy, right? So I will go and check DAPR status -k. So since I'm running in Kubernetes, I have to kind of put a switch call -k. If your application is running in your local VM, you don't need that switch call -k. All right. So if you see, since I'm running in Kubernetes, as you have already seen in some of the examples above, previously in the slides, right? It is a DAPR by default after it's installed. It has kind of got me 4 sidecars: operator, sidecar, sentry, and placement. Right. I think I missed one point. Like after you install DAPR CLI, you will also install DAPR runtime using DAPR init -k. This is a command that is going to get this sidecar. And once this sidecar is available, and you can go and check if my sidecar is healthy and all that using that command. Right, well, that is done. And if you see my DAPR sidecar, it is installed in a namespace. Namespace is very specific to my Kubernetes system, so you can have multiple namespaces in a single node cluster too. So I'm going to run my DAPR in a namespace called DAPR system, and its status is healthy right now, and I'm using version 0.10.0 of DAPR. Right, so this is done. Now we also talked about something called components, right? So let me see what components are. So this is my Kubernetes system. So I want to check if any of the component is available in my cluster. Let me go and check DAPR components list -k. I can kind of zoom in. So if you see DAPR components list -k, it is going to tell me what are different components available in the cluster. So any of the APIs that I'm going to put into this cluster is going to use these components, right? So I have installed Redis. Redis I have installed in my cluster, and I have defined components like message bus, state store, and of course Zipkin. So how did I install Redis? Again, there are 2 commands. You can install Redis through Helm chart, right? So there is, I'm going to add Redis in chat, and if you just do these 2 commands, it is again available out there in DAPR website. You can go and grab it, and once it is available, right, so you can go and install you can go and create a component. So right, since we talked about the component, I will quickly explain like how can I go and create a component. What does it look like, right? Because you're talking about components for so far, but I also want to show you how will you go and create one. So for that, you can see I'm going to open my Visual Studio where I've created the component definition. So forget about this Visual Studio, this code. We will come back to this in a moment, but I just want to focus on this part, which is called Redis local pubsub.yaml, Redis local state store.yaml, 2 files out there. So let's see that what does it look like. So once my Redis is installed, I went and created this YAML file. So people who are kind of following, who kind of worked on Kubernetes, it is something similar. Like I want to create a custom resource, what we call it as a resource in Kubernetes. This is something similar to that custom resource. But instead of using Kubernetes APIs, I'm going to use DAPR APIs, like API version. And I'm going to say, I want a state store. I want to base state store is nothing but an alias for a database. You could think of that sort. So I need a database, and which name is called state store. And I want to connect in my development phase, I want to use Redis. So I'm going to use state.redis, and some of the metadata is name and key value pairs. And I'm going to say what is my Redis host and where my Redis is configured and what's my password. Currently, if you see, I have put my open password, but ideally in prod, you will not be supposed to do that. So you will go and manage it through secrets, but that is too much for the demo. So that I've kind of opened it here. And similarly, if I have to use for Redis PubSub, I go and create. I want to create a component, and its name is called message bus. And again, I want to use PubSub to Redis. This is the API definition for PubSub. and then again key value pairs. So Redis, which is installed in my machine, right? So the two commands that we just saw, right? So Redis is going to act as a pub sub, and it is also going to act as a database for me. So that is what Redis can do, right? And similarly, I will also show you how I created a component for Cosmos DB. Let me open this. So this is nothing but if you see there is no difference between this state store and this Cosmos DB. I've been given the same name state store, but this time instead of state.redis, it becomes like state.azure.cosmos DB. So this is the definition. And again, there are metadata which says like where my Azure Cosmos DB is running and what is the key and what is the database and what is the container name. So this is how you go and create a component. So after you create the file, what I will go is something similar to how you kind of apply any Kubernetes definition, right? I will go and show you that. Since my component is already available, I'm going to delete the component state store which I've created, or maybe I will delete Cosmos DB. If it is not there, I will go and create Cosmos DB. I don't think Cosmos DB is there, so I will go and create it. So you will do Kubernetes apply NSF. This is where you see my Cosmos DB's definition is located. It is nothing but referring to this file over here. So if you see component.dapr state store is configured. I will go back to this and click. So my state store, which was like Redis earlier, has become Cosmos DB right now. Right. So if at all, if my application was using Redis as my database, it will start using Cosmos DB from this moment. Let's see like how is that going to work too. Right. And this is a bit definition about how will you install DAPR and what is runtime, what are the components to it. And coming to it, like so far what you have seen is getting DAPR ready into our cluster, right? Now next is going into the application. So we will get into that demo also. Like I have an application, like I want to use PubSub or I want to use service invocation, right? So what am I going to do now, right? So this is how it looks. So I have my cart, if you imagine cart as my application code, and it is going to talk to DAPR and it is going to say publish some command. And in my publish, I can use any of these components. It could be Redis, it could be Azure Event Bus, it could be anything, right? Today and tomorrow, it can change. But all I want to do is my application as a developer, I just want to kind of do a publish subscriber model. Or if I want to use just that pattern, all my developer needs is to just kind of publish whatever be the state store, whatever be the PubSub component at the background. I just want to give a payload to it. So what I do is I go and make call like HTTP localhost. I'm sorry. So I just want to call localhost 3500. This version 1.0 is the DAPR API version, and publish is again what DAPR has given for PubSub. If you have to use PubSub, you go and use version 1.0/publish followed by your payload. So this localhost 3500, it is called localhost because if you understand DAPR as a sidecar, right, it is going next. It is going to run next to your application. It is always going to be localhost because your application is always going to identify the DAPR sidecar through localhost because it's all going to run in a same pod in a Kubernetes system. And the port is 3500. 3500 is the default port exposed by DAPR for HTTP. And we have got similar port. I think it is 5001 for gRPC. So this is done. So I want to kind of publish my message. And at the receiver side, I also have similar message. Like DAPR is also need to identify my application to kind of pass this message. So my application is again going to talk to DAPR, and whenever message is posted, I'm going to receive it. And since it's a PubSub, I can also have more than one person or more than one service listening to my published message. And that is example for PubSub. So this screen is basically going to talk about service invocation. Like again, in a Kubernetes way, we saw like how difficult it is to kind of do a service discovery by using some tools like Console and all that stuff, right? But with DAPR, it is going to become much simpler because if you think of front end as one application, right? If I want to call something in my cart, which could be like my backend, all I do is I go and say DAPR. Again, if you see, follow the semantics of the URL. It's localhost because my DAPR is running next to my application. Port is 3500, which is the default port DAPR has given. Version 1.0 is the current version API of DAPR. And this invoke, like in the previous slide, we saw publish, right? That is for PubSub. And if I use invoke API of DAPR, this is to call my another service. So I am going to use invoke API exposed by DAPR. Cart is my name of my next microservice. Like each of your service can have a name, right? So I'm going to say cart and then followed by method and followed by the method name itself. So this is how a front end can call a backend application, right? If you don't have DAPR, like how it looks like is, if you are developing or if you are deployed in Kubernetes, it might be probably front end will be talking to somebody like a service discovery, and then say like, wait, what, give me the IP of my backend service, which is called cart. And then that service discovery mechanism, whatever you have in your cluster, is going to tell you the current active IP address of my cart, and then front end will again go and consume it, and that way it is going to call it. It is so much of configurations that we need to do to kind of get into that state, right? So you have to understand what tools you have to use and all that stuff. But with DAPR, if you understand, it is just going to be a localhost port followed by some kind of semantics which DAPR has given, and followed by cart and the method name, and pass the payload. So this is as simple as that, right? So this is like I have shown example for pubsub and service invocation, but DAPR is going to provide the same kind of interface like through localhost for all the building blocks that we have seen in the first two or first couple of slides, right? So that is the kind of beauty of DAPR. And let's get into the demo also, right? So before kind of getting into the demo, I will show you quickly like how I will show and execute this application so that you understand how it looks like. So this is my DAPR demo app. This is a Blazor server app, and I kind of just extended and developed an application for this demo, right? So if you see, this is some of two questions, a couple of questions I have put for just to kind of interact with my viewers. And this has also got some form. So basic idea is I want to go and develop, I want to give some data into this form, click on submit. And this is one app, DAPR demo app, which is my front end. And I want to publish this message, use some Redis states, Redis publisher, Redis, which is already installed in my cluster, to kind of publish a message to my backend, which is called DAPR demo API. And from DAPR demo API, I also want to save the state into Redis. And I also want to kind of quickly change it to Cosmos DB. That is what I want to show. And again, a bit of architecture diagram I have put. So I've got feedback UI app, which I just showed you, and it is going to do a publish subscribe into Redis through DAPR. And again, I've got a receiver API, which is again going to subscribe to this message, do some massaging to the message, and save the state into either Redis database or to Cosmos database, whatever be it, right? We can quickly change, play around with this so that no code changes being made to my pod. I can quickly change my data, which is getting into Cosmos, into Redis, and vice versa. All right. So I will go and before going to the code part, I will just go how it works also. So I'm going to give some form name and some test message. So once you've done that, it is going to kind of, now what has happened in the background is whatever data that I filled in this form, it got published into my backend API. Backend API is also able to save the state into my state store. All right. So let me go into the code part. So I've got Visual Studio. Again, there are two solutions I've opened. One is DAPR demo app, which is my front end, and this is my backend, DAPR demo API. So let me go to the front end part. We have always seen that DAPR kind of uses a localhost and HTTP, right? So to show that, I will quickly show. Like I want to show like I've not installed any dependencies, any packages for that fact, right? There is no dependencies over here. So if you see, it is a pure Blazor app, starting app, which we saw in the morning demo as well, right? And what I've done is I just want to focus more on this feedback service, because that is where we do the pubsub model. Rest all you can ignore it. It's more like a Blazor app. All right. So what has happened is when the moment I kind of click submit in my previous screen, this is a method that is going to get called, and user feedback is basically an object that gets binded. And I want to post, right? So if you see, when I want to kind of post it to my Redis component, this is how it looks like. If you see, I'm just doing localhost 3500, which we already saw, like 3500 is the default port, version 1.0 of DAPR, and I want to publish the message because I want to use publish subscriber pattern here. And I'm saying message bus. This message bus is nothing but the name of the component that we created. I can show you that. So this is a message bus. If it could be any name here. I could even give it like DAPR demo message bus or something of that sort. But this name should kind of match with what we give here, message bus. And feedback is my topic. This topic, if you were kind of used PubSub in the past, you could understand like topic is basically different queues that you can create, right? Like to which topic I want to kind of publish this message, right? I've created a topic called feedback. So this is what I'm doing, like nothing fancy in here. I'm just calling DAPR localhost and kind of post this message. And right now, probably some of you might have a question like, how will my system, which is running in Kubernetes, kind of resolve this localhost address, right? We have been telling that it is a sidecar, but who is responsible to bring that sidecar and make this localhost available for my this machine, right? So that part is kind of involved in your YAML definitions. So Nish was also showing a Kubernetes deployment, right? So he was able to create this and show you that how can you deploy an application to Kubernetes system, right? Basically using a custom resource or YAML files. So this is no different. Rest all is same. Only different that you see is these annotations, which you could see now is kind of what it kind of makes that magic come happen, right? So if you see annotations like DAPR IO enabled, so I'm saying when this pod is coming up, when my application is coming up, I am instructing DAPR to kind of let DAPR know that it is kind of enabled, that DAPR's runtime is going to be enabled for that. And then I go and say my ID, what is my application ID? And then I go and say port 80, like port 80 is the default port which my application is running. So any request that is coming to my application, if DAPR is going to receive that, it is going to port to that port. And I also say that config is an optional attribute there. Like if you want to enable distributed tracing, DAPR gives this way of enable tracing. So these 4 lines is going to kind of make that magic happen. It is going to bring the sidecar, right? So let me go and see, since I've already deployed and I've kind of applied this definition, right? I will go and show you like how it looks. So if you see, I'm just trying to get what are different containers that is running in my local machine. And if you see DAPR demo app, it is already up and running, and DAPR demo API. So these two are already running. And let me also open a dashboard, which is given by Kubernetes. So sorry, which is given Docker desktop. I want to show like how it works. So if you see DAPR demo app, if you see this is my container where my application is running, and for each of my application, right, I've also got a sidecar running which is next to it. So if you see DAPR demo app, I think it is not sorted. I think my machine is becoming slow too. Basically, I just want to show like whenever my application, when my container is running, it is also kind of bringing a sidecar next to it, and I could also show you the logs of that. I think that UI is becoming slow. Dapper D is again a Dapper daemon. I just want to show you the logs of how it looks and how this, whenever I deploy my application, right, how is Dapper knowing that it has to inject these sidecars? And if you say, I just want to show you, highlight this part. So now, whenever I've deployed this application, you could clearly say that it has brought in something called state.redis, exporters.zipkin, pubsub.redis. This is nothing but the component that we have created in this part, right? So my cluster already has got this component created. And my system, when I kind of bring my application, it knows that it has to inject these sidecars. So if in my application, if I'm going to refer pubsub, Dapper daemon is kind of going to kind of interject that request and use the Redis state store that we have. I think that that's pretty much the demo that I want to show, and we will go and submit. Like we submitted something, and let's see if that got saved, right? And what I did is I kind of changed my state store to Cosmos DB. Earlier, I've configured it for Redis, and since I've kind of changed my state store, what I'm going to do is I'm going to bring down my Kubernetes pod and bring it back again, so that it is going to kind of push all the data into Cosmos DB. Basically, I'm going to kind of delete the deployment and bring it up. You don't have to do it. You can do a roll up deployment, but this is much easier than that. Sorry for that. It's so slow. I'm so sorry. I think my machine is becoming so slow now. Just give me a moment. I just want to kind of navigate to that path. So sorry about that. I think the live sharing is kind of taking a strain on my machine. It is so slow. All right. Basically, like I will just go to the complete my demo part. So let me go, and since I've already submitted it, so it has come back. I'm going to just say Amrish, Chris, test, submit. It's say it should be supposed to be saving in my Cosmos DB. Let me go and verify that. I think it has already come. So this is my resource which is running in Azure Cosmos DB. So I think since I have kind of already saved it, you could see that state has come. Basically, what I want to show is bring down ready state store and bring up my Cosmos and show. But for some reason, my system is running so slow. I think it has come now. But nevertheless, what I can also show is I've also deployed this application in AKS. So I can probably, if some of you can kind of try it out, right? So this application is already deployed, and this is a URL, short URL. I can show you that. So it is short url.at/amr45. So if you could try it, right? So what is going to happen is in my Azure cluster, I've kind of by default made my data store as Cosmos DB. So it is the data is going to get saved into Cosmos DB. So for basically what I want to show is like in my local system, I was using Redis, and when I was ready, I will just port my application into Kubernetes cluster with no code change to my application, just bringing down my Redis component and bring up my Cosmos DB. It's just going to work as it is. So if you can free to try it, so maybe you can go and try it like short url.at/amr45. So this is my application which is running in AKS, and it is all going to do the same steps. Let's see if this is going to work. Maybe I will give a different name. Quick time check. It is saved. I'm going to see if my data which I've saved is coming here. So if you see, I just did another save like a BDotNet, right? So if that has come. So all right. So if anybody wants to use it, try around. You can go and see. There are some couple of questions just for fun. You can go and see if you can answer that. If I was able to at least explain some of the basic concepts of DAPR, right? I just want to see if people have understood something basic. So I've just given some questions. Please feel free to kind of go and access this URL, short url.at/amr45. That way we could see live feed coming into this. All right, thanks. Somebody has done that, which is good. Thank you, Sumit. So yeah, this is how it works. Like basically, in my local environment, I was using Redis, and the moment I'm ready, I kind of go and bring down my Redis database. I can kind of bring up my Cosmos. And what I also want to show is a DAPR dashboard. So DAPR has also got a quick dashboard of how it looks. And again, the command for this DAPR dashboard -k, because my system is running in Kubernetes. This is a switch I'm giving. Let me bring up localhost 8080. So this is how the DAPR dashboard looks like. So basically what it is going to give you is a quick view of what are the different sidecars that is running and what is the configurations, what is the different components that you have. Like if you are more like a GUI person, you could go and use this to kind of see. So see, currently if you see, there are two applications which is running in my cluster in which the DAPR sidecars are running. and what is my version, what is the different components that I've installed. Like if you quickly want to say, like currently I'm using Cosmos DB and I've also put Zipkin there. So let's see how Zipkin use. Like Nitin, Nish wants to show that, right? Let me see if I'm able to bring that up. And it's going to run at port 9411. So Zipkin is basically a distributed tracing machine system, which is so this is how it looks like. What has happened in last 15 minutes in my cluster, if any of application has been worked, right? So we will come to know what has happened, right? Clearly you could see again DAPR demo API and DAPR demo work, how much of connection that went in, because we kind of did 3 times pubs up and 1 time state stave. You could go and check, and it is also going to give you click a good overview of what is the connection that has gone right. So I've used pubs up, I kind of got the state, I kind of saved the state. So this is called distributed tracing. So now I've got my UI application, I've got my backend. Tools like Zipkin is going to kind of help me trace what has happened from my front end to my back end, like what has happened in each of my state, how much time it took, and all that. So with DAPR, I didn't do any of my Zipkin integration with my code. By default, we are able to kind of use because of that one line that we saw in our YAML file, right? DAPR tracing enabled with that line, and by installing Zipkin chart into my cluster, I'm just going to bring it like such a magic thing. Like no code change, no code was written kind of to make all this happen right now. That's pretty much about what I have. Let me go back to my slide. So we have seen this like ready state, so I could quickly kind of bring back my Cosmos DB and kind of use it. And what has also happened is it has got DAPR language SDK. So what happened in our PubSub, we saw the code. We saw like we use localhost. Let me show the code how I've written my API. That is an interesting part too. So if you see my controller, this is a controller which is going to receive the message. So we saw like from my app, I'm going to port it to message bus, and this is my topic name. So yes, this is a .NET Core Web API, and DAPR with this, because of it has got so much of integrations with tools like .NET Core, and it has provided native SDKs. Right, I can feel like I'm writing a .NET Core app. It doesn't feel like I have to go and use always the localhost part. There are language specific SDKs. Once if that is injected through this command, like I've kind of put my services called add DAPR. The moment I do that, my application is kind of understanding what DAPR is, what is the kind of events that is going to come, and it is going to unwrap any of the messages that is going to come, like user feedback, right? So this is a message that we kind of posted into our publisher, and this application is now going to understand uh, uh, this endpoint, like from services. This is a from the SDKs, which is going to unwrap this user feedback message for me. And once that is unwrapped, I kind of understood what is my user feedback. And here, if you see, I'm instead of calling state store name value, instead of doing this, I'm using now language specific SDKs, which is .NET Core SDKs, to save my user feedback. This line, right? So it is going to understand what is my state store, which is defined in my cluster, and it is going to use that and pass the feedback and going to save that. And before saving, I'm just saying if that data is already existing, like if first name already exists, that is my key. If my first name is already existing in a data store, I'm just going to pick and update the same value. That way I can limit the number of users in my system, right? And this is a simple line which is going to save it in the state store. So this state.save as something equivalent to call like this. You can do a post to this URL and it is going to get saved. This is kind of a low level, like if you want to kind of like if you are using a Node.js, Python, whatever be the language, right? If it has got HTTP, you could just post to this and your application data will get saved. But since I also wanted to use and show people like how is the language SDKs have come up at this point of time, it just kind of showed you like you could very well go and use it. And this is what I've
Okay.
come like DAPR language.
I'm told by Swami that time is up.
Hey, sorry to interrupt
Sure,
you, Amrish. You overshot by a few minutes already. So yeah,
sure,
just wanted to.
sure. I think that's all I have, Swami. I think we are good. I just want to show it as a one last point is it is in preview currently. It is not available for as a general release to be used in prod. And of course, I kind of attended some of the community calls where I heard like by this year end, it'll be out most likely. We should kind of expect it to be available for GA. and there are some resources which you could go and have a look at that. Thank you.
Cool. Thank you so much, Amrish. That was very informative. Yeah, a lot of things to learn from DAPR. Yeah. And I think we could start the AMA with the questions around DAPR session, what are there, and then we could, take up the other ones. Yeah, let's bring in the other folks too.
Okay, let's bring in everyone.
Hey guys, welcome back.
All right. Everyone, this is the team that brought you this event today. Amazing people, the community make this happen for you. We are trying this for the first time. We're using a new tool called StreamYard, and thanks to .NET Foundation who gave us it. And unfortunately, I only have that login where I can use this, and because of that, my session I had to go unmuted for a long time. But I think overall, I felt good about this. We were able to do that without any glitches, too many glitches, and great sessions out there. So thank you so much. Post your questions in, and we will take one by one and start answering those. So we are starting with the DAPR one. Is that right?
Yeah, that's right.
Yep, we can start.
Okay. There is one from Libin. If you use DAPR, does it mean we have to use the same across all microservices? You could pull that in, Nish. Do you see that?
Trying to search that.
Yeah.
I'm sorry, I'm not seeing the questions out there.
Yeah, so I'll explain it for you, Amrish. So the question is, if we use DAPR, does it mean we have to use it across all microservices?
Oh wait, not this one?
Yeah, just one about that. Yeah.
One about that. If you use DAPR, does it mean we have to use it across all microservices?
No, definitely not. Yeah, I could see the question now. Thanks, Swami. Definitely not. So DAPR friendly, right? So DAPR is made for developers. So it doesn't mean that we have to use across all microservices. Like if you have already got a microservices system running, and if it is using some of the system, doesn't mean that you have to port all your system into DAPR. You can slowly bring, like for example, if you want to just address the state store, you could just bring the API in your microservice and use it. You don't have to kind of go and make a full-fledged change of across all of your services, all of the building blocks. Definitely not the case. You can only create a component. For example, I can only create my Redis component and use it in my microservice.
Okay, I think if I have to add, right, and the question is more around, let's say if I'm DAPR as a sidecar in one of my microservices, does it have to be available in all the dependent microservices only? Then would DAPR be able to work? Or is it like I can pick and choose only few microservices where I want to use DAPR, but other ones can directly work without any kind of sidecar? Is that combination possible? I believe that's what you would like to understand.
Leaving the technical, I think I'll just take that up. I mean, leaving the technical possibility aside, it doesn't add any value, because the advantage of DAPR is DAPR acts as a sidecar container and solves all your cross-cutting concerns problem. For example, you may have situations where you have resiliency, you want to have a connector directly. So the DAPR will take care of all these things. So the idea is DAPR kind of has a runtime. I mean, there was another question like, what do you mean by DAPR runtime? Right? It's not something which is sitting inside the code. It is outside of it. It's running as a sidecar. So the advantage is you have a Node.js app, you have a .NET app, they all can run the same configuration that you define in the DAPR, and they can interact with each other. So it's kind of like someone else on in terms of Kubernetes, another pod is going to exist with your pod, and then it is going to do all those cross-cutting concerns taken care for you. So that's the advantage you get with DAPR. All those things that you need to do as in the code, it just goes away because it's all code in DAPR, and it becomes just the configuration values that you can just change. That's the big advantage of DAPR. So technical possibility, whether you can make it work, I think possibly yes, but then that's not the approach that you want to take. You want to take it in such a way that have DAPR for all the microservices that you're connecting with. You can have external services, right? Can your service connect to an external website? They're not part of your DAPR. Yes, but then you won't be able to utilize any of those DAPR related cross-cutting concerns that are implemented in the runtime. That's
yeah, absolutely, Nish.
I think there's another question, which is in your slide you showed that front end talking to a DAPR directly. Does it mean that when we use DAPR, it does not go through the API gateway. You want to take that up, Amish?
Amrish, do you see this question?
Can you hear us?
Yeah,
Looks like
Dapper is more like, yes, Nish, definitely. So yeah, Dapper, as you said, as more like a side.
I think there's a trouble with this internet connection. We were just saying we went through without an issue.
Yeah,
you
I was
spoke
just
to
trying to answer
Amrish.
for me. So Dapper is through the gateways. Though what happens is you have gateway.
Okay, technical glitches. Sorry, guys.
So I think
So
I have to
I'll take that. I'll take
connect
that question, Amish.
back. What I was trying to say is probably
Okay, go ahead.
for Dapper also with that you your action. So Dapper is of
Until you stop your cam.
sure.
It looks like network. Okay, maybe we could go on to the next question, and once he's back, we can take up that.
Your screen sharing. I can see that you're sharing the screen as well. You can just remove the screen share. Anyway, I can answer that question. I mean, the thing is, again, I don't know how it integrates with API gateways right now. Again, it actually boils down to the answer that we gave earlier. Uh, with Dapper, it directly works, like it does the service discovery and other kind of connections. We are doing a project called eShop on Dapper, which is very early stages. We will be porting the eShop on containers, which has API gateways, and we will take into the Dapper. And right now, there is we have done some kind of POCs, and we do have implementation where it is working with the Envoy proxy, so which means it does work. But then we are not yet sure if that is the way we want to, write the guidance and kind of recommend. So we're still in the POC phase, so we will have more details very soon. So stay tuned for .net/architecture website for more details. Okay, so let's. Okay, I think there is a feedback. I think we need to take this feedback. This is a good feedback, Swarna.
Yeah.
It says please limit the topic and provide more info about single topic, as microservice and Dapper are good, but a bit fuzzy. I understand. I mean that's a challenge we had. Like we were actually debating whether to keep the lunch or not, because people can grab their lunch when they're at home, and still keep it going so that we get more. Like instead of 45 minutes, we can go maybe 1 hour, so that you get more information there. So as you said, and as we were saying, this is the first time we are trying this thing out. So stay tuned. We want to do this monthly, and we will get better for sure. Thanks for that feedback.
Yeah, it's an excellent feedback, Swarna. Thank you. So we will do more focused events, maybe focus on microservices and then on client-side development, like web development, etc. This we just want to give a glimpse of what all are possible with .NET. So now I think we can go deep from here one by one. Yeah, very good feedback. Thank you.
Feedback, yeah. Okay, I have another question. Amrit, are you back?
Yeah.
Okay, it's slow for him.
Is it better now?
Not exactly.
It's breaking a little. Yep.
Yes.
Yeah.
Okay, will Dapper improve the performance? It's very hard to say.
Yeah.
I think what Dapper is trying to do here is basically taking care of all the cross-cutting concerns. Under the hood, what VM you provide, what capability you provide, that would matter. And Dapper is just a runtime, which is going to run and take care of all the things, right? So you will get rid of a lot of code from your own applications. That's the key feature with Dapper. And performance, I think you have to give that a try and see, like, what you're comparing it with the same VM, comparing the performance between with Dapper, without Dapper, and what is the advantage that you get and other things. That's something which you have to compare yourself. Okay. And I think there's another interesting question, which is, are Dapper and Ocelot are same? No, absolutely not. Ocelot is basically an implementation in .NET for API Gateway, and they basically just gives you reroute configurations and where you define it. Dapper is more like a runtime. So in Ocelot, you basically add a NuGet package, and you create your .NET application in Dapper. It's running along with your application, so it is running as its own runtime. It has its own services, so it's totally different.
So,
Sorry.
Nish, sorry to interrupt. So before we go for, I think the DAPR related questions are done. Before we go further, right? I kind of parked one of the questions on Service Fabric earlier during your session. We got a question on Service Fabric. What's the future of it, and then what's going to happen?
Oh,
So I parked it for AMA. Maybe you or Mohit or anyone could answer take up on that.
Yeah, I mean, okay, let's put that question back on the screen. Good question. I understand those concerns, and I'm not able to find the question. Okay, what happened to Azure Service Fabric? If I remember correctly, Service Fabric was Microsoft's foremost solution to implement microservices. Yes, I'll tell you the reason for that. Service Fabric is still great. It is a product in production, and it is proven technology. A lot of Azure services that you see today on, if you go to portal.azure.com and choose any service, a lot of things run on Service Fabric, by the way. Okay, so it's a proven technology. You can go start with it. The only reason why we speak Kubernetes more now is because Kubernetes has become the de facto standard for orchestration technology. And the advantage you get is vendor neutrality. So you can choose a vendor, and Kubernetes is the same. It's like, having a Linux and then choosing a flavor, right? So that, because we have that advantage, a lot of people are interested in Kubernetes. And we, the new Microsoft, we don't want to decide for you and say this is what you need to go. Instead, we want to be best in whatever flavors that you want to choose from. So if you want to choose Kubernetes, we have the great AKS. If you want to choose Service Fabric, you still can go ahead and choose it, because Service Fabric has a lot of things like the actor model and the things, which is now available in DAPR as well. And then also there are distributed things like Orleans, which is another thing that you can try. So there are, it's again, it depends on what you want to choose.
Right. Just to add to that, I just posted a link in the comments section that gives you a good idea about what kind of workflow you're working on, and then what offering you can choose on Azure, right? So it's Service Fabric is pretty much there too, right? So it's not like it's dead or anything like that. But that gives a good guidance about if you're starting new or if you're migrating from monolithic application, or so. Depending on that, you can take a choice, and then you can use the right service offering.
Okay, to add on a point to it, Nish, we run the production workloads on Service Fabric, and over a period of time when we are moving the services to Kubernetes, I understood it is possible to run the content applications in Service Fabric, and in fact, we started deploying one of our services as well. So that way, whoever wants to move to Kubernetes, it doesn't go waste. Whatever you have built, you can deploy them to.
That's great.
Good.
Good information.
Yeah, that's a good input.
Yeah, just to share my experience as well. So I started deploying my services to Service Fabric, and later then we figured it out that okay, Kubernetes is the de facto solution for running microservices across the different platforms. So we decided to not invest more on Service Fabric front, and then we started migrating the code that we wrote that we initially wrote for Service Fabric SDK, but then we started moving it to Azure Kubernetes, and today it's paying off because now our microservices are running in production, and then it's more production ready, and we can move it to any platform as well. So having said that, I'm not saying that Service Fabric is not production ready. It is, as Nish mentioned, that most of the services that you're using in Azure is basically backed up by Service Fabric. But again, if you go with Kubernetes, I think that is where the future and the present lies as well. So if you're bringing something from scratch, or if you're migrating something right now, my personal preference would be Kubernetes going forward.
Yeah.
Cool. Okay, there are a few more questions. Let me add that. Is containerized service as fast as service deployed on a VM?
So faster.
Yeah. So, see, I think in one of the slides I showed about having a containerized service, it gives you the advantage of seeing what is the resource that you need, and you can also define this is the resource that you need, and you can run that. So what Orchestrator will do, like based on the availability of VMs, it will assign you that resource so you can run on that resource. So performance is what you define. Like if you say I want 5 gigahertz or 4 gigahertz processing power when this is running, once you define that, I think you will get that, and that is what it is. Okay, now the next question is Xamarin Forms. Durgesh, you can take this up. Payment integration Xamarin Forms is a bit lengthy. We have to write code natively. Do you have anything to add?
Boo or Lokesh?
Yeah. No, I had I had the
No,
same experience, but to be honest, like not even Xamarin Forms, but even in web application also, this has to be gone through. I mean, the process needs to be followed, provided by the different payment integration. This you need to take concern about the security parameters as well. I would say there is no easy process, but since there was whatever like custom renderers were involved in order to support the native features, which probably mostly in payment integration you won't find, because most of your either web form or like a PWA version will be integrated as part of the payment integrations. But yeah, so with effect of like my I would say moi. It's always confusing. Yeah. So yeah. So with that, like most of your custom renders, will yeah moi. So most of your custom renderers will not be there. So since you have mentioned that, right, that you had to while integrating you had to write your own custom renders. So if you notice from last like couple of years, the Xamarin Forms evolvement, or more of like integration is towards reducing that need, and more of like making it feasible and user friendly even for the developers as well. Yeah. Mhm.
so moreover, more providers are not providing the direct SDK from mobile development. Actually, we done with help of web UI only, web-based payment only. So
Yeah.
even Android and then iOS, actually they're not supporting direct SDK, both Android as well as iOS.
Mhm.
Yeah. Yeah.
Okay, another question there. Talking about the cost, how can I reduce the cost of deployment of whole architecture on cloud? I can take that, but I will let one of you who have already done this take. Maybe Renuka, I think you may have this
Yes.
experience.
Yes. This is very, I mean, whoever moves to the cloud, they come back and say that the cost in the cloud is higher than compared to on-premise. It is not true. It all depends upon, you have to first understand what is your requirement of the resource. For example, like we are going to store the data. There, in case of Azure, for example, Azure storage is there. And you have to understand whether you want to keep the data forever, and due to say some requirements you have to keep for longer time, you can move to cold storage. And if you are frequently operating on the data, there are different options like hot air and all. So that way you have to understand the resource, build your services around it. Just that anything uh, that you cannot deploy to cloud without knowing the cost impacts of it.
Cool. Anyone else wants
Hey,
to
I
add?
can add one more
Just
point here.
one more last point to add. I mean, when I started, there was no APIs to give you the cost estimation. It was really tough to understand. Now there are cost management APIs which will tell you, and there is a built-in advisory recommendation for the cost, so that they all help us to minimize the cost as well.
Yeah, Amal, you were saying
Yeah,
something.
hello. So while calculating the cost, right, what we normally do is that we only take into account what's the cost of the machine, so hardware, etc., and all those stuff. Normally, one thing we are not taking care of the actual how many people are actually working there, how many support people are there, and all those stuff. So one point is that while calculating the cost, you need to take all those into account, prepare the sheet, and compare that with what Azure calculator gives you, compare that, and then only determine which one you want to take, either for on-prem or cloud. Normally in the
Cool.
scenarios I see that a lot of times.
Mhm. Cool. This is a question. Can anyone explain the role of Azure durable function with respect to microservice and some use case of it to communicate with .NET and Azure component? Does anyone here has experience doing Azure durable functions?
I
Yeah,
think
I can give it a shot.
yep, yep.
Yeah, Amrish, are you there? Or I can start and then you could add on to Amrish. See, the durable function is more like if you want to orchestrate your calls with multiple different activities, so that's where you kind of go with the durable function. Otherwise, the single Azure function is more like stateless, correct? You fire and then you kind of you get your code executed and then it's done. But what if you want to orchestrate? Let's say when I'm making the payment, I want to do A, B, and C things, and then I want to get the result out of it, and then I want to then do the further next step in that. In that particular cases is where you can use Azure durable functions. And some use cases to communicate .NET Core. Yeah, you can write definitely the durable functions in .NET Core is what you're going to write. So it's like you can think of it like any other Azure functions, but just that mention the state. So wherever you have a need for orchestration, you can think of Azure durable functions. That's the short answer, I would say.
Okay.
Yes, right, Swami. So am I audible now?
Yeah.
And if I want to answer or add a couple of more points, right? So durable functions is more like an orchestrator, like what Swami said. And if you see, like Azure function has got its own lifetime, right? It's like 5 or 10 minutes based on the tier that you want to use in Azure. But with durable function, you're kind of able to kind of manage the state. Like your Azure functions is more stateful now. So that is the kind of power of the serverless model that you get using durable functions. And what can you also do is it is having so much of models to run, and there are probably 6 to 7 workflows that you can create with a durable function. And what more, like you can do fan in and fan out. Like one function can call probably sub functions within that and kind of aggregate the results. It's so powerful add on for the Azure functions that I would say. And what is also happening is with DAPR coming in, with durable functions coming in, there are something called DAPR workflows that is coming up in the future with DAPR, where all of these tools that we have in Azure, like DAPR, Azure durable functions, logic apps, it's going to kind of create a serverless mode for you. Like you don't even have to kind of, basically these are like serverless features. So you kind of bring down your cost to a great extent, and you can still write powerful apps on cloud.
Yeah.
Cool. Okay, there's another one. Can you provide how effective these tools help us reduce the cost? Tools probably reflects DAPR, maybe. I'm gonna assume DAPR.
Yeah, if it is kind of related to DAPR, right? I could probably say like in the example that we just saw, right? So we kind of didn't use any of the Azure until we kind of ready to kind of even go to prod or pay for Cosmos DB. So in my local, I was trying to use same state store, ready state store, like in the example, right? So we could kind of switch back the components, and that way, if you are planning to use DAPR, it is going to kind of bring down the running cost for you. That is one of the part, but I'm not really sure if these tools is kind of referring to something else.
Yeah, and just to add to it, right? So I think like Amal was mentioning, it's also about the operational costs and managing and everything. Correct. The moment you add additionally sidecars and everything else, you also need to see how much of complexity in the management overhead it is adding to your Kubernetes clusters. So you need to be mindful of that fact. Though it helps a lot in our development perspective, you also need to see what kind of overhead you're trying to add on your management perspective. You just keep an eye on that too.
Okay. Okay. There's another interesting question. Is DAPR wrapper on Docker container in pod? If yes, why it's required that wrapper? Because as per diagram, we need DAPR to connect with any component container. Amresh, you want to take it up?
Yeah. So if I kind of understood this question correctly, so DAPR can run in Kubernetes mode, right? When it is running in Kubernetes mode, and if your application definition is going to have those 4 lines, which is called annotations, right? It is going to bring up this DAPR sidecar. And if you don't have this annotation, it is as good as like in any of their other containers. But in that case, your application has to manage use some of the language specific SDKs or toolset SDKs to kind of do what it's supposed to do. But when you kind of put that annotations, the runtime, right? DAPR runtime is going to automatically bring that DAPR container for you. You don't have to kind of do any of separate coding for that. So is the DAPR runtime which is going to manage the DAPR sidecar. And that is when it is running in Kubernetes mode. Like when DAPR is going to run in a self-hosted mode, like if you have your own VM, if you want to run there, then the DAPR can run as a local host, as a process alongside your application. It need not run always inside a container.
Okay, another one related to DAPR. Is it a good practice to have few microservices on one cloud vendor and rest of the service on another cloud vendor for the same application? That's one first question. And the second question is, will DAPR support this kind of multi-cloud scenario? I mean, the first, I'll just respond to the first one. it is. I don't know what scenario are you looking at where you want to go with multi-vendor. If there is any specific scenarios, like maybe a particular product or something that you want to use on one cloud and other things, yes, it is doable. But also make sure how you're going to connect with each other's things. And the when it comes to microservices, right? As I think when you talk about architectural pattern, between the service to service communication has to be really quick. And if that is in one cluster, and if it is closer to each other, it would be much faster and your performance is going to be high. But the moment you move it outside the cluster, then the whole dependency on the external factor comes in, and you have to account for, as it is, microservices are hard with managing resiliencies and other things. So you're going to further add complexity to it. So if there is a situation where you can avoid it, don't do that. Start with Kubernetes, and if you are not liking one of the vendors, you can move to another vendor, because you can take the Kubernetes the deployments, and move it to another vendor. Those things you can do it. Will DAPR support this kind of multi-cloud scenario? And I think DAPR again is going to sit on your application, like your deployment. It is going to create another pod, and it's going to sit with your thing. So it will run, but I don't think it is going to be a straightforward approach doing that.
Yeah.
Which-
So, Nish, if you kind of go to the DAPR roadmap, I think I have seen this kind of thing which is being coming up in the DAPR roadmap. DAPR in its current state, right? Since it is in preview, we don't have this feature. But I see this enabling this multi-cloud in their roadmap, in DAPR's roadmap, and I've just picked the link in YouTube, so you can go and check what. And it is definitely going to be exciting, like when it is going to support this multi-cloud scenario.
I see. Your YouTube link has not come into this dashboard yet, so I'm going to just look at the. Can you post it on the private chat?
Sure.
All right, I think we can take another question in the meantime.
Yeah. Okay. Too many things to do. Wait. Okay, there you go.
It's just overloaded.
My CPU can multitask, but sadly it is bottlenecked by capabilities. How easy it is to scale containerized application using Kubernetes? Any code changes required to enable auto scaling, or can be done using minimal configuration through Azure UI? So Kubernetes totally depends on the on the configuration file you set it, right? You can set the that. Yeah, go ahead if you want to.
No, sorry to interrupt, Anish. Please carry on. I just mentioned it is in the YAML definition files. We can define them.
Yeah. So
Yeah.
Kubernetes goes with this declarative configuration approach. So whatever you declare is what Kubernetes is going to run on. So if you say I want 4, the scale replicas is 4, then it will run 4 at any cost. So if one goes down, it will try to bring that back, right? So that is what it's based on, that declaration. So if you want to scale it up, I mean, you can manually change it, but that's not preferred approach. And the way you want to do that is basically maybe a DevOps pipeline where you change the configuration file, the YAML, using probably Helm. In most scenarios, people use Helm for that, and then make those changes, and Kubernetes will go and increase those replicas. So you don't have with Azure UI.
Yeah, Mohit.
Just to add on that, so it's practically possible not to the Azure UI, but Kubernetes has its own dashboard that you can deploy. So with the help of Kubernetes dashboard, you can scale up and scale down, but it's not recommendable. I highly unrecommend it to do it from the UI and make it part of your whole configuration process, in your CI/CD pipelines whenever you're deploying, so that the new configurations that you want should be deployed through that. And it's with the help of Git, it will be manageable, and you will be able to identify what kind of configuration that you have deployed to the servers. So it is practically possible, but not recommended.
Yeah, that's true. And just talking about auto scaling, right, just to give an additional information here, there's something called CADA, Kubernetes event-driven auto scaling. So if in case you're doing an event-driven architecture, so let's say you are listening for events on Azure, Service Bus or Kafka Topic, or etc., right? And then if you want to scale your listeners, depending on the number of events, what's available in your queues are, so that is possible. So that's done using a different framework called CADA. So you can check that out. KEDA.sh is the website. I'll post that link in the chat window as well. So that's pretty interesting. That's more for the event-driven architectures, not for your API kind of an architecture. So yeah.
What are best practices to scale a containerized application? I think, we spoke a little bit about that already, and I suggest you to go to the .NET architecture. There is a book on cloud native apps. I think we briefly talk about this. Take a look at that and see if that explains those best practices. If not, let me know. We'll figure that out. Okay, the next question is, could you use something like Akamai in case of multiple cloud? It uses the edge gateways and reduces latency.
I believe that's more like an feed or comment for the other question on the multi-cloud scenario, if I'm not wrong.
I see.
We were having a discussion on multi-cloud, right? I believe it's for that.
Oh, okay. So next one, I understand microservices. Hey, Libin, thank you for joining with us. Libin is one of the XHackers leads of Kochi at one point, and he is now, I think, chatting with us from New Zealand. Really appreciate that. Okay, the question is, I understand that microservice is not really advised for smaller projects when getting started due to additional technical complexities, but one decides to do it. Is there a huge cost difference? As I mentioned, I mean, it's basically the cost is going to even out if you really plan this thing well. The initial cost, more than cost, it's the friction of getting started with microservices, because there is too many moving parts and they all have to come together and you have to manage these things well. So for a smaller app, it is not suggest. I mean, you can take some basic principles, like start containerizing it, use Kubernetes for deployments and other things. And if it's really small, I think you can still stick with logic apps and functions and other things and make it work, right? Or you can even stick to Azure app services, or anything that is as a platform as a service. And the moment you decide to go beyond that, then you have to think through, where is it heading to, right? So start with, we've seen customers starting with basic strategies where they start with a simple monolith, but with having proper modular approach to it, that eventually they can make it microservices if they want to. So split those things, and then I think the cost will even out only when you really make use of the cloud. I mean, think about this. The whole idea is to save. I mean, these things help you save cost in a lot angle. When it comes to thinking about they say the unlimited infrastructure with the cloud, right? So you can kind of literally go up and down based on the business need, and that flexibility comes in when you just break it down and smaller teams can focus and deliver value. So if you're not looking at that kind of a scenario, you really don't have to really add complexity to your app. It is pretty unnecessary. That's what I would say.
Yeah. Just to add on that, like microservice is not the de facto solution for everything you want to do, right? So microservice is in trends for sure, but it's in trend for a reason that it provides you a lot of flexibility and scalability for your application. But having said that, you can also scale your application, which is monolithic as well. So the idea is you have to identify your application and see all the scenarios that whether you need to go for microservices or not. Because the moment you do microservices, yes, there is a cost factor associated with it, because you need to have multiple teams associated with it, and you need to have multiple CI/CD pipelines, and all have to be integrated together. So yes, there would be some cost factor associated with it. But the thing is, you have to identify, is it worth it for you? If you have a very small application, I will preferably say no. If you have an application where you have multiple teams and you want to go to the market faster and you want to scale those services individually and manage those services individually, if you have that kind of application where your business requires you to go and have that kind of flexibility, this is where the microservices helps you a lot. But if you have a very small application, I don't think so there is a requirement of going to microservices. So the answer to this is identify your needs, understand your application, understand your business, and then take the decision.
And again, I think just to add to that, I mean, if you're looking at using modern tools like containers and other things, you still can use your monolithic to use containers and other thing and make
Right.
use of these.
Exactly.
It's you don't have to move to microservices.
Exactly. Yeah. So Nish, sorry to interrupt. Just before we pick the next question, quick note to the audience. So there's going to be a raffle at the end of this AMA session. So please go ahead and submit your feedback if you haven't. So we'll be picking few people from the feedback and few from the people who have asked the questions. So yeah, so keep them coming. Yeah.
Get licensed today.
Yeah. So you're gonna get a JetBrains license. Yeah.
Nice. Okay, the next question is, can we integrate DAPR and Azure Event Hub? Amrisha, you're on?
Yes, Nish. So definitely, when you say like integrate Azure Event Hub is one of the pubs app store, you could definitely do that. So you can go and create an Azure Event Hub component and provide that key value pairs into DAPR component, and you are all set. You could definitely do that and interchange with any other event mechanism too, like Kafka, RabbitMQ, and whatnot.
Okay, it's a very interesting question. How TIE and DAPR are different? I mean, it's totally different. For example, I'll tell you,
for you.
TIE solves the. Sorry. Okay,
I think
I'll just
you
go ahead.
said it's for you. Yeah.
Yeah, I looked at the question. It was for me. So I basically solves the developer in a loop. I mean, when you work with large services, like have multiple services, you have web applications and 25 different services working with each other. You want to kind of like to test them all together in a developer machine makes it even harder, and that's why TIE is more like it's a tool that is actually doing that work for you in the developer machines. Like it's going to run up all these projects and other things. By the way, when I was showing the demo, I was on the eShop where we are we're actually testing the TIE altogether, because eShop and containers has so many services, and we're testing those things with multiple things. So it becomes easier, so that you don't have to use. I mean, Docker has its own learning curves and other things. To avoid that, for .NET projects, you just use TIE, and it will go figure all these things out for putting, a service port and other things. Gives you logs information, gives you a dashboard. Everything makes it easy for development. And whenever you need containers, as long as you specify this is a container, it's just going to bring in the container, and it'll do all those connectivity between these things seamlessly, right? So that's for the developer in a loop. Now TIE has features like okay, TIE deploy. And if you suggest that, it will just go and ask you, okay, where do you want to deploy? Give us your container registry, so you can provide an ACR or Docker Hub or something. Provide the credential information, and then eventually it can push to the container registry, and then it can go and deploy to Kubernetes. So it depends again what is your kubectl is configured to, right? If it's configured to your current context, which is your the Kubernetes local, you'll go and deploy to that, right? So you have these kind of inner loops are really good, just work seamlessly. But when it comes to DAPR has nothing to do with the dev environment. It's all about the runtime. It's taking the cross-cutting concerns of your app and then putting into another. Think of it like another app running with your app, right, in production. And this app that you asked to take care of, hey, take care of my networking, take care of my dependency that I have with Event Bus, take care of this kind of component that I want to work with, right? So you just tell that, and that will take care of all those configurations. And your app, you basically focus only on the business logic only. And tied to a large extent, that's what we do in terms of development. Like when you're developing, focus on your service, right? And then debug it, and rest other services TIE will take care of running it. In DAPR, it's more like a runtime running. So that they're two different concepts. And think of the DAPR is a situation that a scenario that you need to pick when it is for production. Do you want to use DAPR in production? Do you want your cross-cutting concerns to be taken care? Then DAPR. TIE is simply a choice to make. If you are, at the development time, you want to use a tool which will make it easy for development and testing all these things. That's just that's what TIE does. Yeah. Okay, another question: will the platform coverage for Maui be same as Xamarin Forms? Durgesh, or
Yep. Anvu, you can proceed. I can add some information. Yeah. Mhm. Can you hear Anbu?
Yes. Can you hear me?
Yep.
Yes.
Yeah,
Good.
actually, my supports whatever the Xamarin Form supported, it's my supported.
Yep. Yep. And that's yeah,
Yeah.
just to add some more information, that's the beauty of it, and that's why it, the evolution happened, because the name itself suggests that multi-platform app UI, right? So what since there was a growing need of supporting Xamarin Forms across multiple platforms, so that's why it is now getting embedded as part of the system namespace itself. So that you'll find a new namespace like system.my, and then you could start with your like if you talk about mobile platforms, then android, iOS, and your UWP. Good news, there is a lot of things happening with UWP, and recently I think last week also, because there were some concerns related to UWP, so last week also there is a new release on hot reload, which is counts to be a faster on UWP. So yes, so if your concern is around the number of platforms, so yes, the evolution of Xamarin Forms, aka MOI, will address those concerns. Yeah. Mm.
Okay, I think one last question we can take and then move to the raffle.
Yep.
Azure functions have time limit, right? Like let's say 5 minutes. Yes. Do we have time limit for durable functions? Swami?
I believe it is. Yes, I guess it's 10 minutes if I'm not wrong. So let me just look at the docs to confirm that I don't want to give a wrong number. But yes, there is definitely time limit for any of the functions what you want to execute, right?
I think it's for 7 days, if I'm not wrong.
But see, durable functions can probably run for days together, like what Mohit said, right?
Yeah,
So it is going to maintain the state for you. So there is no like a specific time bound. It depends on the workflow that you create.
yeah, but I think the highest the state
Yeah.
can be only be maintained for maximum of 7 days,
Okay.
if I remember it correctly.
Yeah,
Like
yeah.
yeah. So it's again it's a function, right? So it's not going to hold for like months for you. If you want to maintain that state, you need some sort of database, right? Uh, so the one function which can be basically run is, I think it's for 7 days in one shot for the web functions.
Okay. So one last thing about before as I do the raffle for the audience, right? I think one of the questions which was coming up during this session is on the inter-services communication in microservice, right? There are different ways you could do or establish a communication between microservices. So do you want to talk about that a bit, Nish? Meanwhile, I'll go grab the winners of this particular event. Yeah.
Yeah. So what is the question on? Say that
So
again.
how do we establish communication between multiple microservices? It's a service A wants to talk to service B, and service B wants to talk to service C, and etc. Right? So how do we establish those communication? What are those recommendations or the best practices in establishing communication between microservices?
Okay, so let me just share my screen and I'll start with that. But this is the DAPR roadmap that we were talking about earlier.
Yeah.
I think this is what he wanted to mention, which is the universal namespace and routing access for multi-cloud and edge. So anyway. Okay, so talking about microservices communications, right? So I encourage you to go check this out. There's this .NET architecture, each open containers, and within that there is something called as a wiki. Okay, there are like bunch of situations here that may be useful. For example, how do I use API gateways? So service-to-service communication has this impact as well. For example, giving you something like this, right? So API gateway, in API gateway, it's also a good reason to have aggregators or the backend for front-end implemented. So this is the production scenario for eShop and container. So if you're using something like Service Mesh, like Linkerd, so we have that implementation for it, and API gateway for routing, we use the Envoy for the routing. And now when you say service-to-service communication, for example, in this scenario, we only have the service-to-service communication from the event aggregators to the service, that is a synchronous service communication, and we use gRPC for that. Okay, that's also one of the reasons why we use Envoy, because Envoy can take HTTP requests and convert into gRPC requests when basically when the gRPC request is made from the aggregators, it is all gRPC, and then when it is receiving it, it's basically receiving the rest, right? You can do gRPC for higher performance when you want to do service-to-service communication synchronously, but there are situations where you want to use asynchronously because you want to say, okay, hey, so this service has completed this action, so you just publish an event, and the other service can go pick it up and then do the rest of the things, right? So for that reasons is when you will start using something like a event pass, or let me share. So there is this option called asynchronous messaging. You can see this. So you click on that, and it will go and explain you what are the things available right now, like the Azure Service Bus, and eShop containers have code for implementing Azure Service Bus, or for locally you can also use like RabbitMQ. The other place to get this information more detailedly is if you go to the .NET and /architecture. You can, of course, you can go and download this whole book and read it. But if you click on view on the web, and here you can actually, it talks about, let me search for, implementing event-based communication in microservices. So it talks about the event bus, and it details about how you want to communicate, and basically the microservice architecture principles and how it is implemented using something like an event bus, right? So those are the information that's available. We have this doc called API Gateways with Ocelot. We don't use Ocelot anymore for the reason that when we moved to gRPC, we had tough time supporting it. So we moved to Envoy, but then we still have these things remaining. So if you want to use Ocelot for your communication from the API gateway to other services internally, you still can use it. It's a great tool. So that's one there. Anything else? Okay, that's all. So I'll just take this off. There's one more question, maybe. Okay, there's another question. Will microservices architecture by default cloud agnostic, or what should be kept in mind to make a microservices cloud agnostic? This session was a good starter for me, though. Okay, so making a cloud agnostic, I mean, Kubernetes is the moment you choose for like an orchestration platform like Kubernetes, you're cloud agnostic, right? You can just go and implement the same thing in some other services as well. But microservices generally is an architectural pattern, so it just tells you a few things how you need to take care of how the communications have to work with each other, and how do you loosely couple. When you loosely couple, what are the challenges? How do you mitigate those challenges? So yeah, the moment you pick up Kubernetes for your deployments, you're cloud agnostic. So that should be your way to go. You can also use there's I don't want to tell that. I don't know if it's a end product or a preview product. Anyway, what else? There's another question. Does native HTTP client handlers, not the managed one, support gRPC in Xamarin? I think so, right? It's a straightforward .NET code. Durgesh, Anbu, do you know?
I haven't played with gRPC yet, so I'm not sure, because the question specifies not the managed handler. So yeah.
So it's not the managed handler. Okay.
Yeah,
So question
not.
is for the not. I'm not sure either.
Yeah, it's at the platform level, the client handlers. So, yeah. Mhm.
Yeah, I think you should use the managed handler. There's so much of performance optimization that has gone in the managed handler, and you can use that, unless if somewhere it is stated that native handlers is giving you a much higher performance, then probably you can think about that. But I am not very sure of the Xamarin scenario though.
Yeah, probably there was what I remember is from last .NET conference in last year 2019, there was a sample probably that could help if you can take a look. And also like apps related to the streaming, so that's where most of the gRPC is used. So probably a good place to start with. Yeah.
Yeah. So are you ready, Swami, for giving away a raffle? Prizes. You're muted.
Suspense.
Yeah. I'm getting it. I was just looking at all the avenues to choose the right persons. Yeah, looks like our audience are more active in the YouTube and not on Twitter much. So yeah, guys, get onto Twitter.
Swami's cap looks good. Wins a raffle.
Sorry,
I
what is
said,
that,
like,
Nish?
whoever says Swami's cap was wonderful will win the. Okay.
No,
Go ahead.
not really.
Let's close this thing
Okay.
so that everyone can get back to.
Okay. So, yeah, absolutely. We have picked up like 5 people today. So we're going to give away 5 JetBrains licenses. So what you will get is an JetBrains toolbox license. So you can choose the favorite tool of your choice, be it Rider or if you're on Python, PyCharm, whatever the tool you want, you can just pick it up and then you can apply this license. So whoever has given the feedback, I've just pulled from the attendees who has given the feedback, right? And yeah, so time to announce the winners. So Anbu, do you want to do that? Do the honors. I know he's been silent and doing a lot of things from the background, so I thought it's good.
The name, right?
Yeah. I've pinged in the chat here. Yeah.
So first one is
about Ajay Kumar.
Yeah, Ajay Kumar, first one.
Yeah.
So
yeah.
Next one, Vishwanath. It's continuing name or?
Oh, sorry. I think I didn't give a line break. I'm sorry. He's like a programmer now.
So those of you watching the
it's
stream,
You can announce it.
I'm sorry about that, Anbu. Yeah, I thought it was. Okay, so yeah, first one is
watching the stream and why we are laughing at it. So we have a private chat where Swami has pinged us all the names, but he has not put a comma or semicolon or anything to divide between the things. So we have
my bad. Yeah. I'm sorry, guys. Yeah. Yeah. So let me do that because I think I kind of pulled the names. So one is Ajay Kumar, and second is Vishwanath Pulla, and Vani Koganti, and the fourth winner is Bhagat Gopinath, and the fifth one is Chanakeshav Dadamani. Okay, congratulations, guys. So I hope the email ID is what you have given in the feedback form is correct. So I'll send out an higher test email, and then once I get back the proper response, I'll be sharing the codes with you. Okay.
So don't waste the coupon. So please activate as soon as possible before the expiry date.
Yeah, absolutely. So every coupon has an expiry date. So the moment you receive the email from us, please acknowledge it. And then if you're able to acknowledge after you redeem the coupon, that'll be really helpful.
Yes.
Okay. Yeah. All right. I think we had a good time since morning. It's been close to 6 hours. We've been streaming a lot of .NET content. Yeah.
Yeah.
Thank you so much, speakers. Thanks, Mohit, Durgesh, Renuka, Amresh, Anbu, Amal, and Ravi. Yep. I keep getting confused with Ravi or Rathor because of his the name.
Yeah, I just kept it for separate. Like to be unique, I just named it as
good.
And it from my title also, so that's why. But yeah.
Good, Rathor, not a problem. Yeah. And thank you so much, Nish, for doing a lot of things together, putting this show with .NET Foundation's thing. Yeah. I hope you all enjoyed it as we did.
It was a great day.
Yep.
Yeah.
Thanks to everyone and to our participants also, because this really inspire us to bring most of these events. So thank you everyone for your active participation. I hope these sessions are useful for you, and we plan to bring more in future.
Yeah. And yeah, please keep the feedback coming. Raffle is just to motivate you guys. It doesn't stop you to give the feedback. So please keep it coming. BDotnet.in/feedback so that we can improvise ourselves in the next events or so. And the last one, what I would like to call out is all the presentations and the sample code repository will all be consolidated into a common repository. So you can go to bdotnet.in/presentations. So that's a URL which you can bookmark it, and then you'll be able to see the links from all the speakers and all the sessions basically. Yeah.
And most likely that's going to be Monday because everyone wants to take a vacation.
Yeah. It would take some time. I'm sorry.
Cool.
All right.
So time for me to test the end broadcast button here.
All right. Thanks everybody. Bye-bye. Have a good weekend.
Bye-bye.
Yeah.
Bye-bye.
Stay home. Stay safe.
Thanks.
Yeah.
Bye.
Yeah. Bye-bye.
Thanks.
Bye.